time it is. I don't know what time it is. I can't see a clock.
No, we're right on time, and I think we have, don't see anybody else in, so go ahead. So good morning, everybody. Come on, a little bit more than that. Come on, good morning.
Good morning!
All right, that's better. Thank you. Thank you very much. I'm Vance Kogendorfer. I'm the conference chair for the 2021 OLF Conference. And it's fantastic to have you guys out so bright and early here in the morning. And then also the folks joining us on the stream as well. I wanted to introduce our opening keynote speaker for the day. Mark Phillips is an engineering fellow. He's got a long career in military circles. He's an engineering fellow with Raytheon Missiles and Defense. And he came to our attention. We were talking about having potential keynotes, and Mad Dog suggested, he said, hey, there's this guy that I heard about back when he was working with the Australian military, and he was replacing their proprietary Unix systems with Linux systems. And thought, he's got an interesting story to tell, some interesting experiences in dealing with free software. So we are very much looking forward to that. I do want to make a quick announcement. When we come to the Q&A, if you would please use the microphone so that the folks on the stream can hear what you're saying. And also the folks who are on the stream, if you're in our Slack channel, we have the main stage channel. You can post your questions in there and someone will ask them on your behalf. So the title of Mark's presentation is called Where is the Secret Source? Which is a mysterious title if I've ever heard one. So let's learn, where is that secret source? Mark Phillips.
Hey. Well, good morning. I'll try and keep this light. Man, I'm reverberating in my own ears. I'll stand back from the microphone. So, so I'll try and keep this light. I've been around a while. In fact, the first time I ran across Mad Dog was I was a young, still enthusiastic officer in the Australian military. I was a major chief engineer for combat simulation in 1996-97. And this gentleman wearing a beard, braces, boat shoes, no socks, and pants that stopped around halfway up his ankles, came into my office with a retired brigadier general and introduced himself as Mad Dog and handed me his business card. I looked at it and said, how do you get to put Mad Dog on your business card? And he goes, well, who's going to tell me I can't? And we've been friends ever since. So 23 plus years later, here I am. And also recently joined the board of directors for Linux for LPI. So I'm very proud to be back in the game contributing to the organization society. So what I'm going to do is I'm going to give you a little bit of an origin story, a little bit about my history, my first experience with open source, which was great from a technical perspective, but pretty awful from a professional perspective. Use of open source in the Department of Defense now. When I say DoD, I'm talking not just US, I would also add in there Australia, UK, Canada, a lot of the countries around who basically want to move fast. How I personally am using open source right now. And then, as to the point of the presentation, where is the secret source in terms of source that's in classified environments? This presentation could just as easily have been called Standing on the Shoulders of Giants, but I thought this was funnier. So every hero has an origin story. I'm not a hero, I'm more of a character. But my technical interest began when I decided that I wanted to leave school at 15. And to get away from school, I joined the Army, which foiled my plans because I spent the next 3 years studying electronics and radio communications. So that's me actually in the picture. I was a young lieutenant had just graduated the year prior, and we'd just finished a 10-kilometer battle run and shoot in South Australia. So what you can't see there is everyone's feet are blistered, and my sergeant, who's wearing the jumper right behind me, was hating my guts at that point because I pushed them a little too hard that run. That's way back when I was a little thinner than I am now. So, like I said, I joined at 15, studied electronics, radio communications. There was really nothing in the way of computers in much of the technology because even in 1980, the equipment I was working on was 60s kind of tech, Vietnam kind of era. So by the time I was 18, I was out in a unit fixing VHF and high-frequency radio equipment. But along the way, I got exposed to 6502 processors and assembler and opcodes, and started fiddling around with that, but still wasn't really much of the way of in wide distribution. And on the workshop floor, we had terminals in the workshop that were connected to a big-ass Perkinelma 3230 or 3252, which was called MAUD, Machine Automated Workshop Documentation. And so you go in each morning, you punch your card in there, you punch your job card in, it would collect that information. If you knew the right key combination of the terminals, you could find Hunt the Wampus on there, which I will admit I did play a little bit. Often got killed in about the third cave by bats. And then I cross-trained in radar, combat surveillance radar. And just to give you an idea of that bottom picture there is what's called an ANKPQ-1 mortar location radar. It's 5 parabolic dishes that basically, when it's in course track, the outside dishes are looking, and when it gets into fine track, the outside 2 cut out, and the inner 3 will lock on. And you can tell from a scope, an A-scope, whether or not the round that you're tracking is coming for you. If it's getting really, really tall, it's time to get out of there. And basically, the only computer that was in there essentially was valve technology. I think there were 10 transistors in the thing. The pedestal had a gray-coated disk, so you knew what position it was in. And so the counters would click over. The person who was tracking the round was filling out a table in real time from the X, Y, and Z data, knowing where their lat long was, where they were geolocated. There was no GPS. This was all hand done. So this same radar was used in the Korean War. It was meant to be thrown away. The Australian government managed to hang on to it until 1987, in which case they leapt from that to electronically scanned array radars like the TPQ-36, which was light years different. But the point being is I was always at the point where whatever I was working on was being phased out. Every training school I went to closed behind me. Now, I don't know if that's a good thing or a bad thing, but I shut down a lot of schools on the way out there. And a lot of equipment that I worked on ended up in museums, which is actually kind of degrading when you think about it. You go and say, hey, I used to work on that. And it has Bakelite switches and whatever else. But what's interesting is, and I was trained as a technician originally, so I was trained to maintain equipment, trained to repair equipment. I didn't become an engineer until many years later, and engineers aren't trained to maintain equipment, just like not everyone is trained to maintain code. A lot of people like to write it, but they don't always write it with a view to the next person behind them fixing it or maintaining it. And that's a skill. That's something that's a mentored skill in many, many cases. So later when I studied engineering and computer science, I'll talk about that. And I got to work on mini computers, and I'll talk about that in a little bit too. And finally ended up in combat simulation, given that when I first went to college, I was a little late. I think I was about 24. I was already an officer in the Army, and I wanted to study computer science. So I went off to Queensland University of Technology, and I spent 2 years studying computer science. Thought, this is great. I'll ask the Army if they'll help me finish. And they turned around and said, well, you used to fix radars, didn't you? I said, why? They said, well, you should be an engineer. We have a shortage of engineers. I said, I don't want to be an engineer. I want to be a computer scientist. I said, you can go somewhere really, really hot, or you can do what we tell you to do. Your choice. So I thought, I'm going to do what you tell me to do. So I went off and studied electrical engineering and thought, oh, well, I guess the rest of my life will be spent working on electrical systems. Nope. I'll talk about that in a bit too. And finally, I moved to the United States in 2000 by invitation of a colleague of mine who ended up being the president of Texas A&M, Richard Bowen Lofton, who was a low-temperature physicist and a good friend, to help him out with some simulation work. But the key to this is, like I said, everything kind of closed behind me. Things changed very fast. And I found myself a couple of times in my career at what I call tipping points. So let's say I graduated from a university in '95 as a young engineer, thinking I was going off to do great things with electrical engineering stuff. No. The gods had different ideas. I was sent to the Defense Computing Bureau for my sins to work on that thing. That thing looks like it came out of the Ark, and it pretty much did. I thought this was a cruel, cruel joke. What's that? The other one was the one that I was working on back in the day. So, so I got to this thing, and I got there just in time to find out that all the Winchester disks that used to be sitting on a box next to the computer had been removed and replaced with SCSI drives, and the disks were now being used as plaques. So they're getting engraved. They put a clock in the middle of the disk, stick them on a wooden plaque, and they present that to you when you left the job. So I mean, I felt like I was right in the middle of the new tech. I was like, whoo, this is great. And before you were allowed to go live on the system, you had to pass some exams and whatever else. And of course, wouldn't you guess it, the final test before I got let loose on the system was writing Hunt the Wumpus. So once again, everything came full circle, and there I was, many years later, working on something that should have been retired. And in fact, we were still using dial-up modems in Australia. Navigator was the browser, if you remember that. You had to get your Wollongong computing Windsock from Tasmania, believe it or not. First Windsock was from Australia, by the way. You dial up your other end and then basically connect in and you download stuff off shareware, bulletin boards and whatever else. That computer system, thank you, that computer system was designed to maintain, or that program was designed to maintain every aircraft in the Australian Air Force and Army. And so basically we tracked all of the life cycles of all the equipment, all the parts, all the deeper maintenance cycles, and we managed that in a database written in OS/32. Or they called it Minex. So we'd have folder parties. If any of you remember back in the day, printing off the big form code sheets, going out, pulling the racks of code off the rack, undoing it. We'd have code parties where we'd pull out the perforated sheets and we'd replace them with new sheets and close off the folder. I was literally in hell. The business reporting system when that thing was written in COBOL. But it was designed to basically work from a base. So you have a base, a bunch of terminals, guys get a new piece of kit, he's going to install it, he enters in his data, and so forth. Well, if you're flying with the Air Force and you're going and deploying somewhere like New Guinea or somewhere else, you can't take that thing with you, so you've got to track everything on paper records. We ported that entire system to that Toshiba laptop. But we couldn't replace it with the Toshiba laptop. We could just deploy Toshiba laptops with air crews, and they'd come back, and then we'd download it onto a disk, and then we'd eventually port it back to the big computer. It was an ugly way of doing things, but it was, again, a time when things were being phased out. There was a system that was meant to replace that. That thing was called CAM, Computer-Aided Maintenance Management. The one that was coming after it was called CAM2. It was Anderson Consulting was doing the work. It was 10 years late and $100 million over budget. So I want you to think about that for a second. There was a program written in OS/32 that couldn't be successfully replaced because the guys I work with on my team kept adding features. So the other company had to write mods to the contract. They couldn't keep up with the features. So I was begging them to stop so we could transition to something a little bit more modern, like a third generation database language. Anyway, again, part of my history, and I left there kind of scarred. So at the end of 1995, I was promoted to major. I thought 1996 was going to be my year because, for my sins, the Australian Army decided that I was going to be the chief engineer for combat simulation. I thought, here, high tech, here I come. I am finally there. No. I showed up in 1996 to be greeted by that VAX. I said hi, it said nothing. In fact, I had a VAX 4000 and I think a VAX 3800, and I had 2 DEC alphas with a bunch of memory on them that I hadn't ported my code to yet. And before I got there, they used to have Tektronix 4225 terminals. If any of you remember the old graphics terminals, the Tektronix graphics terminals, they stopped making them. So to replace them, the only software application we had to replace those terminals was a Tektronix emulator called TGraph, which came out of, I think, White Elephant Technologies in England. And the only thing it would run on was a Spark. So I had some very expensive color terminals that would basically Spark 5s, 10s, and 20s, running RS-232 from a DECnet port out the back of that VAX. And I'm like, I'm in hell. This is crazy. Everything was written in Fortran. It was not pretty. So it was DCL scripts and that. So not PCs. PCs weren't kosher. If you were using a PC, you wouldn't do anything serious. You were word processing using Amy Pro or Lotus 123 or whatever it was back in the day. Very inflexible. And in fact, when we moved around the country, we had to pack that VAX up and all the terminals and printers and everything else into a big box, load them onto a C-130 cargo plane. Myself and my deputy chief and my warrant officer would hop in the back of that thing, and we'd fly deafened for 4 hours. The other end was hot and sweaty. We'd unload the ramp, and we'd then drag 10 base 2 cables to the buildings with duct tape. I was living the dream. Cloud environments, the only cloud was the dust that was getting blown around outside. At the same time, so my unit, in fact, it was when I met Mad Dog, actually, in '97. My unit was directly across the road from a place called Headquarters Training Command. And so we were a subordinate unit, but we were independent. There was a CIO there by the name of Richard Gell. Believe it or not, his name was Lieutenant Colonel Dick Gell. You can't make that up. And he was very much in love with Solaris and Sun. And so there was a technology back then called SolarNet. And I was told to do, for all my file systems, I was supposed to use SolarNet at a cost of $50K a license. And it was complex, it was painful, it wasn't reliable. So I looked around, and my lieutenant and I managed to get hold of a copy of Samba. Samba was written back then, before it was popular, before it became SMB, was written by a guy called Andrew Tridgell out of Australian National University. Tridge, all Tridge wanted for his open source license was a pizza. That's all he asked for. You didn't have to send the pizza, but people sent pizzas from around the world. The condition of the pizza by the time it got to customs in Australia was not good. But yeah, it's a true story. If you look at it, in fact, if you go to the Samba license, you'll probably still find a pizza statement in the license today. But Samba worked perfectly. It was the first time I got to use open source, and I got my butt kicked for that. But I kept proving that it worked. It worked perfectly well as an NFS to connect to the NFS on my Sun Spark stations. And I could mount all my drives, and I could do everything I needed to do, and it was awesome. So the next thing was I got told that a bunch of guys at the Army National Guard in Fort Leavenworth, Kansas, took the simulation called Janus that was written by Lawrence Livermore Laboratories in the US, and they had ported it to Linux. What is this Linux you speak of? And back then, Linux was a CD-ROM you get, was Slackware in Australia, maybe Debian, if you're lucky. There wasn't much other choice at that particular point in time. And so that was my aha moment. There has to be a better way. And so I got sent to the US to investigate. So I showed up in this building in Fort Leavenworth, Kansas. And if you've ever been to Fort Leavenworth, the only thing coming out of Fort Leavenworth are prisoners who get out of the 5 prisons in Fort Leavenworth. And there's an army base there as well, and a really good Thai restaurant. That's about it. So I visited Leavenworth in 1997, and these guys were in there, and they ported it across to Linux. And instead of being a terminal server application, it became a peer-to-peer application running on each machine ran its own copy. So what I didn't tell you was when we deployed to, say, Command and Staff College, and we were teaching tactics to the officers who were going to get promoted to Lieutenant Colonel, if you could game the system, those Tektronix terminals took so long to refresh the screen that if you were stupid enough to zoom in on a location, the other guy could kick your butt and conduct an attack. And by the time your screen refreshed, you were toast. So with the port to Linux, that all changed. So I thought, wow, no longer RS-232, no more DECnet. I can now run on at least 10 meg Ethernet. I think we were still shared Ethernet. We weren't even switched at that particular point in time. And it was free. I wasn't paying VMS licenses. I wasn't installing 900 character license codes and patches on Solaris and VMS. And that was because the National Guard didn't have the money to maintain that VAX infrastructure. The National Guard and the Marine Corps, in my humble opinion, are the 2 most innovative branches or groups in the military because they are creative in that they find ways of doing things but they don't have the budget to do them. And they're more often than not massively successful and disruptive in the way they do things. So I came back to Australia with this Linux thing, and I thought, I'm going to be a hero. Once again, I got kicked in the teeth because basically now I was challenging the Australian version of the software that was supposed to remain compatible with 5 other countries, but wasn't. The only thing that was compatible was its name. So I got punished again for using open source, and but I still wasn't dissuaded by that. But now we were using PCs for something that was actually important, and it improved the situation massively. Well, anyway, roll forward. In 2000, I was going through a bit of a change as well, and I got an offer to come to the US, to Virginia, to Old Dominion University, ODU. So in November 2000, I moved across there. I was working with a group of simulation and modeling folks. We were using Silicon Graphics Onyx computers, Reality Monsters, had 3 graphics pipes at the back of them, driving what we call caves. If you've ever seen a cave, it's a 10-foot by 10-foot cube with projectors in each wall with folded optics and then projected down onto the floor. So you're standing in the virtual environment. You've got a pair of shutter glasses on. You're magnetically, optically, or ultrasonically tracked in there, so you can move around and your orientation is mapped. So that was a $2 million computer driving $1 million visual system. These days, it's a $90 Oculus being driven by a cell phone. And that's only happened in the past 15 years, by the way. So we were still using a lot of high-end technology. The Cave library, the Cave lib that drove that cave was actually open source out of Urbana-Champaign. Carolina Kruzanitsa, I think, was the PhD who did that. And she maintained the Cave lib from the academic standpoint. And then a bunch of his students went and commercialized it. And they became arch nemesises ever since then. But at least the company that took the open source software maintained it and provided a service and provided additions and provided updates and provided a roadmap, which is key. Just having software alone is not enough. Whether it's open source, whatever it is. If it's not maintainable, and it's going to go the way of the dodo. So the United States Marine Corps at that time was pushing PCs. I got $1 million out of the state government, Virginia state government, off Governor Mark Warner, and I built what I called a battle laboratory, which is basically a laboratory for decision making, for people to get creative. So I had clusters of PCs where people could come in, they could drop screens in a room, they could basically work together and collaborate and do interesting things. At the same time, right across the street was a joint warfighting center. And there was do you remember the big computing rooms where you had the big smoke glass windows and all the flashing lights? Well, there was a farm of VAC 7000s running a thing called BBS, Brigade Battle Simulation. And BBS was there with all the flashing lights. 1 year later, all those VAXs were gone. And behind that big glass smoky panel was one rack of PCs in a rack. I mean, it wasn't as impressive. There weren't as many flashing lights. But things radically changed literally overnight. It was about that time that we started to connect all of the military simulation sites in the country and started to make sure that basically we could, when we trained, we could not just train locally or fly equipment around, but we could literally connect out and connect to any training range in the United States and later to other countries. So open source was starting to take hold because every PC, every simulation was being ported to Red Hat without exception. Red Hat was, from the beginning, dominant in that space. And it worked. All the companies out there that supported it, Alliance Sciences, SAIC, Lockheed, all of them, we basically were driving Red Hat machines. And it was a bit of a challenge because it wasn't until about 2003 that the US government, the Chief Information Officer, and I'll get that in a minute, basically decided that open source or free and open source software was a real thing and it was something that we should take seriously. And I'll just put in mind that in 2001, Mad Dog asked me to come to Linux World in February and give a talk in New York at a breakfast about the death of traditional Unix systems. Didn't go well. I guess I didn't realize who the audience would be in that room that morning.
I briefed them on this audience ahead of time.
I probably was young and didn't listen, which is probably true. And to this,
I didn't brief you on that one. That was,
oh, okay.
My bad.
So anyway, let the record show that just because you might potentially be right doesn't make it better. And well, we've all seen what happened since then. Open source and Linux have taken over. And in fact, if it wasn't for the fact that Linux was so well supported, not just by the user community, but by support organizations, it probably wouldn't have happened that way. So what made a difference? This memorandum was actually a second memorandum. If you look in the red circle there, in 2003 is when the first memorandum came out for the Chief Information Officer of the Department of Defense. And basically saying that open source software was a real thing, you could use it, but you had to have the source and you had to verify it. And every time I hear Mad Dog talk, things he says come out and refresh my mind as to, like the comment yesterday in his presentation where he said, just because you can all see the code doesn't make it secure. The many hands make light work, many hands, touching it. That's not always the case. But it was a belief, I think, at the time. And so anything you used in the Department of Defense had to be what we call STIG'd, gold disks. We had to basically run a disk over it, which shut down ports, shut down services, Telnet, FTP, and before you knew it, your operating system was useless, one step short of being bricked. And then you had to try and get waivers and get those services turned back on so your application could do what it needed to do. So it started to drive the difference. And my belief is the change of heart happened with these factors. Number one, affordability. Fraction of the price of commercial offerings. Many people would say that free and open source software is free. There's no such thing as free software. There's never been such a thing as free software. Software costs. You're either going to pay the maintenance internally, you're either going to have your own boys and girls do the development work, or you're going to fund somebody else to do it, or you're going to pay a license fee and support costs because you haven't got the time to risk it going south at some stage or have a vulnerability. Accessibility. open source software was by far easier to find and install. Probably too easy to find and install, I would argue. So you wanted to be disruptive, you wanted to go add new software. I mean, that's all well and good, but you're going to hit a big wall of inertia even with that memorandum, because someone says, well, how do I know I trust that? And why are you doing that? Why aren't you going with a commercial variant? Speed of development. This is a time when middleware became big. Middleware, for what it's worth, started finding its way into a lot of applications, whether it was for protocol communication, transport, whether it was for, in the simulation world, middleware was used for AI. So any of you who've played Warhammer back in the day, or any of the early games where the monsters could track you, if you blew a hole in the wall, they could find their way through. The only reason the monsters could find their way through was because there was a path mesh that was sitting below the terrain file. And that path mesh was a set of goal functions that basically allowed the characters to reroute if they needed to dynamically. We used to call it reptilian brain, because it really wasn't that smart, but it gave the appearance of intelligence to the characters in there. And it made the games much more challenging on the way through. So the Defense Department in the simulation side started to adopt path mesh, because now characters could move autonomously and not have to follow strict vectors like roads and so forth. So now they could traverse urban environments and get around buildings. Trust, that was a big change. Cyber wasn't really a big term back then. Security obviously was. Cyber obviously is now massive. But verifying the source code was a big part of that, making sure you could verify it, get it checked out, and before you could use it on a real system, go live. Training. Training wasn't really that prevalent, but most developers didn't seem to care. There was enough Docker around on SourceForge. I don't know if GitHub was around back then, but people would figure it out. You get a bunch of young guys together, or girls, they would figure out what needed to happen, and they would make the changes, and they would train themselves up in the applications, and they'd integrate them accordingly. Variety of models of licensing, not terribly restrictive, but if you had the wrong license, it was going to cause you a lot of grief on the way through. So you wanted to make sure that you definitely couldn't hand back your source if you modified it on the military side. That was a no-no. And so you found that most of the open source middleware applications got used in experimental or test cases and then didn't make it to the production variant because they had to basically rewrite the code because of a licensing model. And finally, acceptance. The fact that it was being accepted at the Pentagon level down, or any government, made it easier to start adopting. And approvals were key. Otherwise, you just weren't going to get anywhere. So how have I used open source software? Well, it's kind of interesting. First 5 years at Old Dominion, I was using it principally to conduct experiments, to connect simulation together. So a lot of the work I did was what's called distributed simulation. There were a couple of IEEE standards out there to connect simulators. One's called IEEE 1278, Distributed Interactive Simulation Protocol. The other one's IEEE 1516, which is a Corba-based method infrastructure called high-level architecture. So I used to connect things out and make things that weren't meant to work together work together. 2006, 2011, I ran away from home and went commercial. So I worked for a Canadian company, a company out of Tucson. I worked for a French artificial intelligence company for 3 years. And we used a lot of open source software in some of the commercial products we work with. And then 2012 to 2019, low TRL research and development technology. So if you're familiar with the NASA TRL scale, technology readiness level scale, NASA came out with this. The DoD uses it quite prevalently these days. TRL 1 is kind of like, I've got an idea, I'll scribble it out on a napkin, what do you think? And look at its basic research. TRL 9 is, it's bulletproof, it's deployed, it works every time. I can push that all day long. So the sweet spot in early TRL development technology is TRL kind of 3 to 5, and the mid-level is kind of 5 to 7. At TRL 6, the government stops paying you to do funky research. So they have actual account codes tied to those TRL levels. So the highest level is 6.4, 6.4, which is basically TRL 6. Once you graduate to TRL 6, you're done. Then you have to transition to somebody who's going to make it a production system and move it out there. So just giving you a look at the TRLs, because the TRL, if you want to do work with academia or with the government, those TRLs, and there are also MRLs, manufacturing readiness levels, and there's IRLs with NASA, out of NASA Goddard, called interoperability readiness levels. They're a good way to level set people on where you're at in your development cycle and where you're at with your integration, and it kind of level sets everyone. If I'm at 5 or 6, I'm doing a technology demo. I'm probably not going live, but I'm in an environment kind of like I'm going to deploy into. And it gives people an expectation of what they can expect. So when I left the French AI company, I went to Lockheed Martin as an architect. And I mentioned that I'd spent a lot of time connecting things that weren't meant to be connected, and I couldn't help myself. So I decided that I was going to take a live fighter aircraft and connect it into a simulation. And you should have seen the meetings where I told people that I wanted to do that and that I wanted a bunch of money. So the way I got around that is I went and whispered in everybody's ear that I thought was going to be an influencer, what the bill was going to be, a little bit higher than that, so that when I finally came out with the idea and did the presentation, no one in the room was shocked. So it was kind of like, not level setting, but getting everyone acquainted, getting their feet wet, and making sure the water wasn't too cold. So the idea was I was going to have a simulation on the ground. I was going to use encrypted tactical radios, and I was going to take the mission bus on the aircraft and extend it over a wireless network to the ground. So the aircraft, the F-16, has an APG-68 radar on the front end of it, on the nose. On the ground, I had a virtual APG-68 radar. And that APG-68 radar was connected on a 1553 MUX to a mission computer. And so that's a 4th generation fighter. So it's a federated system, which means that it's like a Christmas tree. I've got a mission computer, I've got an electronic warfare system, I've got a weapon system, I've got all different things Christmas treeing off the mission computer on different multiplexes. So on the ground, I'm thinking, well, how am I going to do this? How am I going to get data from the ground to the aircraft? Well, it turns out that massive multiplayer online games, there was a protocol, the MIT license called ENET. ENET, as a message protocol, I could serialize, channelize the data that I needed and write QoS, quality of service environment, so I could figure out what was guaranteed delivery and what was best effort. If I was doing something that I had to have an acknowledgement for, that something had to get there, like a weapons firing event or a detonation event, I had to make sure they got there. If it was just, I'm tracking the position of the aircraft in space, the Euler angles, its velocity, you know what, if it's 20 hertz and I drop 5 messages, does it really matter? I can dead reckon between those drop messages and smooth out the aircraft, because the aircraft doesn't jump in space, so that's not a hyperspace vehicle. So I knew basically where the aircraft should be or where it would be over time, and I could plot that out. So I did that, and basically the government gave me a few $1 million. Because they said, well, this ENET thing doesn't look like it's very well supported out there. It doesn't seem to have a huge following. Tell us what else you might use. Well, ZeroMQ, like ActiveMQ, is a project that's supported by millions of users out there. Different way of communication. So I didn't serialize in channels, but I wrote a QoS for that as well. And so we used ENET or ZeroMQ, and I could just switch between them. What I ran over that protocol was a government open source application technology called TINA, which is a Corba-based application. So the government has its own open source internally because it wants its contractors and its academic supporters to use that as well, because otherwise everyone's going to write their own custom proprietary way of connecting stuff, and we're going to be back to square one. So in 2001, they basically came up with this thing called TINA. It's an ACE-ORB architecture. You can do remote method invocation. So I could turn things on and off in the aircraft through RMI, which if you're a cyber person, you're probably sitting back going, well, that's not really good. So we did that. It was successful. In fact, to get approvals to do this presentation, I had to go back and prove that there was a public release for that flight. And in fact, I showed one of the colleagues here today, my stuff is still on their website, including the video. I was kind of shocked. But we did that. We flew the aircraft. We were over Dallas-Fort Worth area airspace. The aircraft had a box to fly out of 40 miles by, say, 30 miles. If you're in an F-16, you'll cover 40 miles real fast. So the poor old pilot's dragging the aircraft around this box. And DFW is over here. Well, on his radar, he could see aircraft taking off from DFW, but he could also see the MiGs that I was putting in the environment on the ground that was showing up in his display. And if I launched a surface-to-air missile, his radar warning receiver would go off and start squawking, but there was nothing there. So he had virtual missiles on his wings. He could fire his virtual missiles. One of our guys in the lab got careless and dragged 6 MiGs with a mouse. You know, it's very easy to group things and drag them. You've just got to be real careful where you drop them. Well, he dropped them right in front of this F-16. Of course, a big X come up on the HUD like there was about to be a collision. And I thought my career was over. Because when the airplane landed, the 2 pilots, it was a 2-seater F-16D, got out. And I was going to the debrief room. And I thought I was going to get chewed out severely. And Gigliotti, who was the pilot, went, "That was awesome." And I was like, "Really? How so?" He goes, "Oh man, you know." He was doing everything that he would do. I mean, his wingman was sitting next to me in the lab. His wingman was a simulator on the ground. There's a protocol called Link 16, which allows you to send tactical messages between systems, computer to computer. And so from his pilot vehicle interface, everything he saw on his displays was exactly as it would have looked if he had been in combat. But he was, you know, not going to get shot down. His wingman was flying, but was on the ground. And it was a big success. It was actually pretty cool to do. And all the guys I had worked. If you can see the social media post, obviously as the chief engineer, when I wrote, "Holy crap, it worked," even I was a little skeptical that we would pull it off the first time, but we did. And it was successful. I thought when I left Lockheed and went to Raytheon, working on missiles instead of aircraft, or aircraft training or test, that I'd gotten away from all of this simulation, Corba, middleware, open source thing. No. I'm back in the middle of it big time. The picture I'm showing you is a Distribution A picture. Distribution A means it's free to be shown or distributed to anyone, anywhere in the world, foreign, US, whatever else. But it's a Pentagon picture, and it's a subset of the infrastructure in the US. So everywhere you see a line connected to a thing in a picture, that is persistent. The thing that glues that is that TINA infrastructure, that open source, Corba-based messaging protocol. So the way you do that is you write a TDL file, a TINA definition language file. It's XML. It describes your object model or your object model elements all the way through there, and you push that TDL file up onto a website. It's classified, or it's protected. And then you get back, a few days later, you get back code. And you take that code, you integrate it into your system, and you do that. So I've built a bunch of gateways where I'm converting different protocols. So if I want to pack up 1553, push it across a wireless communication network, unpack it, regenerate the 1553 blocks, have them show up, or I wanted to connect some other connection, you can do that. And quite successfully, if you have a 1960s piece of equipment, which a lot of the stuff on those ranges is, you can cut the wiring harness, put an AD converter in there, write an application, connect it up, and next thing you know, you're driving a 1960s piece of kit like it came off the rack yesterday. So even the government has its own open source software, has open source following. It's what we call controlled open source. Not everyone can get access to it. But the intent is basically to help make things more open. And if you've been tracking, there was a man by the name of Dr. Will Roper who left the administration, the last administration, but in my opinion, very forward-thinking. And he, like Mr. Kendall, who's now the Secretary of the Air Force, are about open standards. Open standards, open communication. Unlock the box. Now, it's okay to have a black box. but the interfaces should be open. Those ICDs should be open. And so you're seeing more and more the ability to move faster and faster and faster through open source or open standards communication, open standards methods. And we need to move faster. And so it's speeding up prototyping and testing. I won't say it makes its way into every commercial system. It definitely doesn't. But it definitely makes its way into test applications. And in a lot of cases, it's important because we'll conduct a lot of experiments to see if things are going to work before we put them into production. So, at the beginning of this talk, the question was, so where is the secret sauce? Well, it turns out it's everywhere. It is absolutely everywhere. It's operating systems. It's containerization, KVMs. It's middleware sitting in applications to speed up libraries like Fuel and other libraries like that. It's DevOps and DevSecOps pipelines, GitHub. It's tools, OpenSceneGraph. OpenSceneGraph Earth is massively popular. If you've ever used Cesium or other Earth tools that look very Google Earth type lookish, you'll get OpenSceneGraph. So the open environment, it's source data. In fact, John mentioned this, or Mad Dog mentioned this yesterday. Source data is also important as open source. If you go to the US government USGS website, you can pull down imagery and vector data, elevation and feature information. You can go to TurboSquid and pull down models off there. You can build KML, KMZ files, which the Google modeling standard is actually a government open standard now. It's accepted as a government open standard. So if you do that, you can start building virtual environments very quickly with open source information that's been pulled down. It's geo-rectified, which means it's geospecific. It's been corrected. So when you strap it together, it matches the WGS84 coordinate standards, and it basically works. You can map it into those environments very easily. So where is the secret sauce? It's in experimental systems. It's in test environments. Every day it's in test environments. It's in prototypes. And it's starting to find its way into some deployable systems, especially source that is managed. Linux is definitely in deployable systems to this day. I'm pretty certain that it's out there running command and control systems in some environments, and it's becoming more prevalent everywhere. So wherever cost and schedule is king, you will find open source software. Thanks. Any questions? And the crowd went mild. I'll take that as no. All right. Thank you.
you remember Dwight Johnson?
Yes. Well,
He was.
does in the wrestler?
Hello. All right. Introducing Evan Livovich. He's founder of Linux LPI, basically. Currently, it's director of community development, author of its code of conduct. He's been involved in the first world of open source software since the 1990s and participated in the Creative Commons and internet governance activity. So just hit it, Evan.
Thanks. Before I start, I just wanted to kick in, and I hope it shows up on here, an ad that IBM ran in the mid-aughts when IBM started to embrace Linux.
This is it. This is this way. This way. What happened? Everything happened. I called you as soon as I could. I'm trying to get calm, but everything's gone. You want me to be calm? Is it possible that it's an inside job? I mean, we're inside, right? There's got to be pros, these guys.
Calm down, sir, and tell us what
I can't
happened.
breathe. I need my pills. This way.
The room's completely empty. What was stolen?
Everything.
Everything.
Everything. Payroll, R&D, customer records.
Assets.
All of the assets.
How could they get everything?
How do I know? You're the cops.
I said, look, pal, we're the only friends you've got. How much money we talking?
A lot.
Millions?
Millions.
Millions?
Millions. Millions.
All the assets were in this room?
This is it. The servers. They stole all our servers.
No, we moved everything onto that one. It's going to save us a bundle. I sent out an email.
Calm down, sir, and tell us what
IBM servers running Linux.
What's the server's completely empty.
Good infrastructure. It can save you a bundle.
Everything. Payroll, R&D, customer records.
Oh, it's an echo, I guess. Anyway, so that was just something that came to mind before starting this, so I just thought it might be worth showing. So I guess I'm here to give a slightly different presentation than some of what you might been hearing. A lot of presentations at conferences are about tech or about, how do you do stuff with code or Kubernetes or whatever. I'm with Linux Professional Institute. The only code I write is bad, and so they keep me away from that stuff. But I'm reasonably good at documentation, writing, and that kind of thing, and so that's where they put me. But what I wanted to do is talk a little bit about things that go beyond tech. So for those that may not know, LPI is a global certification body. I helped co-found it in 1999. And we help people get jobs in open source. Our certifications and our exams are recognized worldwide. There is literally 193 countries and territories where there is at least one person with our certification. But if you're trying to get a job in North Korea, you're out of luck with us. And so we've been doing very well at this. We've been very well respected globally, and our certifications are really good at proving that people have technical skills. So our exams are in sysadmin and BSD and DevOps and stuff like that. But I want to talk about something a little bit different. So LPI is an organization. We have a middle word in our name, and that's professional. And so that means there's more to being a professional than just knowing how to code. And so I wanted to spend a little bit of time today talking about the non-coding things of what makes you valuable in the workplace, what makes you valuable as an entrepreneur. And it's just been our experience that this is sort of a side that's lacking, that people are better at talking to their computers than they are talking to other people. And so we are now pursuing more along the lines of, okay, we've done certifications that test your skills at working with the tech. What can we do to advance the state of people's ability to get jobs, of people's ability to create new businesses and entrepreneurship, and basically grow open source beyond simply the tech smarts? And so we've been spending a lot of time thinking about this concept. What is an open source professional? And so we've already got the first part licked, skilled as in dealing with computers. That part you can do tests, can you do bash, can you do systemd, can you program, so on and so forth. How well do you know Git? That part we're basically doing okay at. But now the part about social, how do you deal with the community? And the ethical part about how do you deal with clients and with employers. And some of this gets very sensitive. Right now, I'm president of the Toronto Linux User Group. We've been around since the mid-90s. And one of the people in our organization is a kernel developer with a very long Indian-sounding last name. And he has taken abuse randomly from people on mailing lists and so on, who has nothing to do with the quality of his code. Somebody took a look at his name, never having met him, never having spoken to him in person, but basically just on a name and an email address, being abusive. And he was genuinely wondering, what do I do? Where do I go? And there was no mechanism within the particular community he was in for dealing with that. And we took a look at that, and at least to me, that constitutes a problem that is going to affect the open source community as we go forward. Having good quality code is only part of the problem. Dealing with some of these issues, I think, is going to take up a good chunk of time going forward, especially as we go from the original generation of leaders that came along in the 90s and aughts. They're now starting to get old, to get tired, to get employed by other things and leave projects. What happens? What happens to their community? And also now people that come out of this program that are working with open source, okay, everyone's saying you can make money with open source, but if you can't talk to a client properly, that isn't going to be much help. So this part of the presentation I can go through very quickly because I think I'm kind of preaching to the converted. But this is the way I would talk about open source in a manner that isn't just a technical thing. That when talking about open source to people that don't know about it, you basically can say, this is good for the person who's coming into open source. It's good for their career because right now there's a lot of jobs working in open source. And it's good for projects. So tackling this at a very non-technical, practical level, it's still possible to make the case of why get involved in open source. And then you start to get into the free software versus open source stuff. I think there's lots of room for everybody in this. And I don't think anything we're doing actually runs counter to people that are promoting free software and want to call it that. But it's more than just the coding. It's more than just having quality stuff. It's more than just putting in commits and so on. And so understanding licenses is something that maybe some people spend effort on, but not a lot of people do. Everyone knows about the GPL, and most people know about the BSD license, but there's an awful lot of others. Hands up everyone who's heard of the Open Source Initiative, OSI. Okay, some, not everybody. OSI is essentially the keeper of quote-unquote open source. And so at the website of the Open Source Initiative, they maintain a list of licenses, and there's hundreds of them, starting with the BSD license and the GPL, and of course, if you want to go to the real heart of it, public domain. You can toss stuff out into the public domain, say, I decry all rights, and you can do whatever you want to it. And then everything becomes more restrictive after that. And you have different organizations that have different things they want to get out of a project, and that's how they choose a license. But if you're involved in a project yourself, or you want to start one, how you determine what license you're going to use is going to determine the kind of community you build, the kind of audience for your project, and the code that you produce is going to develop. And so then there's business models. And by that, I mean, how are you going to make money from open source? Are you going to just use like a Red Hat model and say, the code is free, but the branding and the service and so on is not? Or are there other models? There's a number of different ones that are out there. And so if you're working on a project in which you have some sway or you want to start one, this is the kind of thing that matters. Just saying BSD or GPL in itself will either gain or repel various people, both coders and users, depending on who you're trying to attract. And so you have hybrid dual license models where you can say, okay, this part of the code is open source, but we put on a few little features here and there, and if you want that you're going to pay for, that's proprietary. Totally acceptable. I mean, to somebody who wants 100% free and open source software, it's not good. But if you want to pay your rent, for some instances, that's going to work. But there's a number of different approaches. All I'm trying to do right now is to get you to think about there's more than one approach to this. There's more than one way to make money selling your services or training or anything else to do with open source. I mean, now you're out there just being employed as a coder. For some people, is going to be their whole life, and that's great. Some people spend their entire life as an admin. That's fine. Some people want to create businesses and to do innovative things with this stuff or create new projects. And it's important just to think ahead of time about how this is going to work. And of course, for somebody that's just getting involved, you know, get a GitLab account, start contributing, start to see the kind of feedback, and get a feel for the kind of communities that you want to be a part of. And of course, they're not all the same. They're going to, in many ways, take on the character of the people that have either founded it or running the community. And so the term co-opetition was coined by Ray Noorder, the guy that invented Novell, which for 30 seconds, I think, owned a Linux distribution. Sorry? Yes. And in fact, I was there the first year that the first brain share in Salt Lake City, where Novell had invited a whole team from Nuremberg to come over, and they were searching the streets for a decent beer. This was pre-Olympics when you had to get a membership to join a bar just to get 3% Bud. And you have these guys coming from the Bavarian purity laws saying, where can I find something? Utah was not the place for them. So it was very awkward. And I seem to remember once upon a time that the SUSE head office in Nuremberg, it's sort of like there was the line, and there was the red side and the green side. And they barely talked to each other, but that's a different story. But, you know, Novell arguably played an interesting part in the very beginnings of open source. But what they did contribute was the concept of co-opetition. And co-opetition in some cases is very fundamental to some of the models of open source, where you can have a whole bunch of companies, defense contractors, construction companies or whatever, that normally despise each other, but realize that it's in their common interest to have an architecture that they can all build on. And the architecture is common, but their value add is not and proprietary. So there's many different collaboration models, and I'll point to sort of the Bible of this at the end of my talk. But sometimes, you know, things are going to happen. Can anyone think of the F word that I'm thinking of here? Okay?
Not that one.
Not that one. Forking. Right? Almost that one. Okay? Important distinction. But to many people I've heard, forking is open source's F word. Somebody gets tired of a project, thinks, I can do better, and they'll go off, and they'll splinter the community, and you'll have half the good people here and half the good people there. And some are very high profile, like OpenOffice, LibreOffice, and some are not so high profile. But also, this is all have to do with, in some cases, getting along. Now, you can have irreconcilable differences, like some people just couldn't get along with Oracle. But for a lot of smaller projects, you know, if there was just a little bit of social skills and a little bit of slack being given, you might not have quite as much fragmentation as you do. And so I used LibreOffice and MariaDB as two very high-profile examples of forking in the community. And they forked basically because of the participation of Oracle, but which bought Sun and then bought MySQL, and the developers just wanted nothing to do with it. But there are lots of reasons why people will fork their projects, and most of them aren't good ones. They have to do with personalities as opposed to code quality. And so, you know, if people just sort of slowed down, cut a little slack, you know, we could keep these projects together rather than splintered. And so this is why we got into things such as the ethics of open source. And at the very beginning, people just didn't think much about it. Open source itself is ethical. It's a great thing to do. It's good for society. It's good for the world. But there's more to it than that. And that's why I talk about diversity, because it goes back to the experience I had with my friend in the Toronto kernel community who got basically bullied out. He was a very, very good coder. He was paid by a Fortune 500 company to be in the kernel, and it got to the point where he just couldn't tolerate being there. And that was their loss. And at least I, and through LPI, we want to try and do what we can do to try and calm that down a bit and slow that down. And some of this is the same kind of conversation that's having in society as a whole, but it shows up a lot in open source, where you don't have an employee that you can control. You have volunteers and participants in a mailing list who are collaborating on a project and have to depend on each other. So there's a dynamic here that's a little different from you have a bunch of employees in a shop that are coding according to what their manager wants them to do. Here, you know, if you're a volunteer, if you don't like what's going on, you walk. And so it's important to try and make sure that people don't walk. And that's why I'm saying, it may sound obvious, but I've come across enough instances where people just feel unwelcome where they are. And I don't mean snowflakes and that kind of thing. I mean people that are into a project to try and deliver good code. Most of the complaints that I've heard have come from women that just, again, based on names on email addresses and things like that. There was a couple of years ago, I was into content management systems for a while, and the same year I went to, there was a DrupalCon in Toronto, and there was a WordPress conference in Toronto. And the audiences were staggeringly different. The WordPress conference was about 50-50 male-female. The Drupal conference was, I think, something like 10% women. And it's not like one system was inherently superior to the other. They both performed their role in the community. But why is that? Why did one community have a really good balance and one didn't? And I don't know if I have an answer to that, but it's worth thinking about. If you're involved in an open source project, think about whether you're attracting the best talent you can, because you're not attracting people with money. You're attracting them with goodwill and the feeling that you're contributing to something useful. And so there's that. And then I also want to think about the ethics and talk about the not quite open. So I'll use two examples. One is called open core. So it's one thing to say you have an open source base for something that allows other companies to put on proprietary value add. In the world of open core, and there's an actual, I believe, open core consortium or whatever, where that gets really tightened. Whereas The free and open source stuff is a real tiny part of it, but to do anything useful, you need to get the proprietary add-ons, and that's not, well, to me, that's not good. That's not really honoring the spirit of doing this in an open source way. And it's important when getting into a project, knowing what that is. And then there's another component to this that on one side seems really ethical, but also goes against what both open source and free software is. Anyone here aware of the ethical source movement or licenses? You have a category of people that says, I want to do open source, I want to put my software out in the world, but you can't use it if you're one of the companies that was just talked about in the keynote. Can't be used for military, can't be used for in various countries whose human rights I don't like. And so there's a concept of open source that allows the authors to determine the use, who can use it. Anyone can code for it, but only, peaceful companies or whatever can use it. The problem is that goes against both the open source definition and Freedom Zero as defined by the Free Software Foundation. Free Software Foundation says Freedom Zero, you cannot restrict use, period. You must have the stuff that's out there available for use by anyone. And so on one hand, you have a community that's saying, well, we're just trying to do the right thing. We want to use our work, our code for good. And there's a place for that, but it's not open source. The moment you put any restrictions on use, even if it's for things you don't like, you could put out open source code and it could be used by hackers that are doing ransomware. You could do open source code that is being used by militaries that you don't like. But in open source, in the world of open source, both according to the open source definition from OSI and according to Freedom Zero of the FSF, you cannot restrict use. So I want to turn the corner a little bit and talk a bit about what my organization LPI is doing about this. So LPI turned 20 in the year 2000, and we did a major bylaw change to make LPI into a membership organization. So we now have enough certified people around the world that we can say to them, we want you to be members, we want you to pick our board. And we're trying to turn LPI more into what you think of like a bar association or an engineering society or something like that, where the practitioners actually control the direction of where the profession is going. And so one of the things we've been doing with LPI is to encourage membership. And when people become members of LPI, they don't have to retake exams or do anything like that to keep their status active. We encourage professional development. So somebody teaches a course, somebody takes a course, somebody contributes open source code, somebody does advocacy to a business or government, somebody writes an article, somebody does a podcast. All of these are part of professional development. You don't see doctors and lawyers having to retake their college exams every 5 years. In the world of IT, though, to a lot of programs, if you don't retake the exam every 5 years, well, it's as if you never took it. We're not going that path. And so we're encouraging the concept of professional development. And part of that means talking about the stuff we've been talking about. It means being a good professional, contributing to it. And that also now means we did a code of conduct. And we scoured the internet. We scoured open source projects. We scoured every possible ethical group that we knew that was doing a code of conduct. We didn't find one that actually combined ethics for being in an open source community as well as ethics for being an employee or a contractor. And so we created our own. And this code of conduct is, I believe it's being made available under CC BY. So it's like a very BSD kind of license, which is what Creative Commons uses in that respect. So it started out as a part of membership, but now we require our employees, our contractors, and the people that are working with us to sign on to this. And the thing that at least bothers me the most is that we have to lay this stuff down. I'm going to go through some of the components of it. You may think they're obvious. Unfortunately, they're not. And so we've codified this. And like I say, we've done this uniquely for the world of open source, where there's entrepreneurship ethics here, as well as working in the community ethics. So there's 4 components of the code of conduct. And rather than just read out what's on the slides, you can go to it, lpi.org/conduct, and it will go into this into more detail. But essentially, this is what we're trying to do. We're trying to promote open source in the world, and part of that involves having a component that says you're protecting the public interest. So you don't put malware into code as an experiment to see if the developers will find it. Which was done at a university I won't name not too long ago. And so maintaining public trust in open source is important, because especially when it doesn't have a vendor that's marketing the crap out of it, trust is really what's holding it up. Trust in quality, that the code is good quality, and also an end user, where that end user is you on your computer, or the Department of Defense, or the European Union, or whatever, can trust this for their own use. That it's trusted for the infrastructure of the internet and all these other things. Trust is an important component to this. And so that's why we put in issues such as, on a global scale, promotion of the public interest. Conflicts of interest are also a big deal. If somebody's contributing to a project and they are employed by somebody that has a specific motivation to put a certain kind of code in there. You're right, you're doing hardware drivers, and you want to make sure your company's hardware drivers are in there. Well, at least you need to disclose that to the rest of the group. Again, that's the kind of thing that you'd think would be obvious, but it's not. And so protection of public interest is basically a global scale. Demonstration of personal integrity, is an elaborate way of saying, don't be a jerk. You'd think that people would do that voluntarily. Unfortunately, it doesn't always happen. So we've codified this in here. And what it means is, when you have a codified code of conduct, it means then that you can then put together a process of what happens when somebody breaks it. And that's going to change from project to project. But at least it means you have something there. There's expectations of the people that are there. I don't think they're too onerous. I don't think most people will think they're too onerous. In fact, as I said, you might find them obvious. But at least it says, we have a code of conduct, and that means we have these expectations. If you break it, we have a process of dealing with it. This is only part of the answer. The other part is what happens if somebody goes against it. And that's going to differ from community to community. So the other 2 parts of this, again, you might think were obvious, but maintaining confidentiality. Somebody who has multiple clients, don't talk about one client's business to your other client, even if they're not in the same field. Abstain from gossip. You'd think that's obvious. No, it's not. And although you're working in open source, your clients are going to have trade secrets. Your employers are going to have trade secrets, and they're going to have their own proprietary stuff. And although you're an open source advocate, to be a professional at this, you've got to respect your client or your company or whatever. So if they say, we're having this part open, we're having this part proprietary, as much as you can advocate for them to have more of it open, you've got to respect their decisions. And the last bit is the part that most corporate codes of conduct don't have, and that's the open source community one, and that is showing respect for colleagues and collaborators. Every project will have its own litmus test, its own sort of bar, but all I'm trying to do is get it so that in any of the open source projects in which you're involved, you're not going to have that situation where that person with the unusual name or the person with the female name is going to be treated different from any other contributor. The idea is this supposed to be a meritocracy. You're as good as your code. And the idea is to try and keep personalities out of it, and that's how your open source is as good as it can be. And actively seek to welcome newcomers. This is going to come more easily to some than others. There's a couple of techniques that I'm going to suggest now, especially as we're making a transition from, the 90s and aughts where this thing started, into how do you keep a community growing and vibrant. And so to put a bit of a bow on that is just what we're trying to do with this, at least in LPI, is to elevate the profession. We want to have a level of societal respect for the people that are working in IT as much as they do in other professions, to me, like law or engineering or medicine, because, if a technician doesn't do their job now, depending on where they are, really bad things can happen. It's like if an engineer doesn't do their job, a bridge falls down. If a technician doesn't do their job, a power grid goes down. There's that same level of responsibility that can be there. And so building public trust in open source, improving the community, to me, in the long run, is just going to grow the world of open source and help with the advocacy that I think all you want to engage in as well. It's basically just saying, this is a world that is trustworthy. This is a world that is this is a world whose code is worth using. And I added this sort of at the last moment. If you want to follow up on anything I'm talking about, I cannot recommend this PDF more highly. It was put out in 2008 by the Mozilla Foundation, and it's called A Framework for Purposeful Open Source. And it details about a dozen different, what they call archetypes. And the archetypes have to do with who you bring into your community, what your aims are. Is your intention of making something commercial viable, or are you just trying to muck about and do an experiment? They're both open source, but they're going to have very different ways how you license them, how you go after the people that you want in your community, and how you promote the results of your work elsewhere. They're both absolutely valid, but they have very, very different modes of operation, very different forms of corporate governance. You're now starting to see more and more open source projects become foundations, where they're doing fundraising, where they have leadership, where they have marketing, heaven forbid, where they actually have to encourage people to do documentation, because very often the coders don't want to do it. So you have all these things in mind. And that also means that the leadership also has to think of succession planning. So that is, you have somebody that comes up with a great idea, and they're fearless leader to the community for a while. But then they'll get tired. They may get sick. They may decide for one reason or another, this is just too exhausting. What happens? Does the project die because they don't have fearless leader anymore? Or has there been a thought given to who's going to step up after that? Right? In the kernel, they've already started. When Linus walks away, what happens? They've given that long and hard thought. And so there is a process. But that absolutely is going to be important for every single open source project that's out there, big or little, corporate or individual. They all need to deal with how that's going to happen. And that means that you want to start thinking about internal mentoring, whether or not it's formal or not, where you have the leaders that are talking to the newbies and saying, get comfortable with the community, and those who want to step up have an opportunity to show their talents and show their capability to lead and to do more than just code, because you do need all of that. And I mentioned from email to Discord, because you're also going to find that as this generation of open source practitioners is aging, literally, you want to bring in new blood. The colleges are all graduating people hot into open source, but they're not using email, right? They'll all eventually get accounts on Git or whatever, but when it comes to how people are talking to each other generally, the standard you know, the old mail serves, they serve their purpose, but the new generation isn't using them. And so, for instance, the Toronto Linux User Group just recently went onto Discord. And we're finding a whole bunch of new people in the audience who are using open source who wouldn't be caught dead on a mailing list. And so it's not a matter of either or. It's a matter of how you're going to evolve, how you're going to encourage the next generation to come in, because the next generation is going to be using different tech than you did. So how welcoming you are to it is going to have an effect on your sustainability as a project. And I just wanted to make one other comment about this thing about open source program officers. I had the ability to be at the Open Source Conference in Paris 2 weeks ago. It was not a pleasant trip, thanks to COVID. But what I did find is that there is a new directive that every country in the European Union now is being required to create an open source program office. And that process is also now being followed by all of the Fortune 500 and is now starting to trickle down to SMEs. And so this is actually a new growth opportunity. This is non-technical people that are there to advise managers and HR and IT staff about advising them what licenses to use, what governance to use, what kind of projects they can, what kind of open source code they can use and which they can't, which they can trust and which they can't. This is now a thing in that it's reality, that open source is no longer a niche. It's no longer something you have to convince most companies to use. They've decided they want to use it. Now they're all trying to figure out how. And there's a need for people in those organizations that can tell them how. And as for consolidation, no. You know, there are thousands of distributions now. There's going to be thousands of distributions in a few years. So, you know, things are still going to fork. I can still try and do what I can to reduce that, because the less forking there is, the more amount of talent there is in any given project. But this is, I think, going in a good direction. And I think it's all important to the sustainability of open source. We've come a long way in going from something that companies had to decide, do I want to use this? To now they're asking, how do I use this? And now it's up for us to step up and make that job easier for them. And on that, thank you very much. Do we have any time for QA? I don't have a timer on here.
We have time. If you have questions, use the mic. So we have a couple of comments online. So someone says, I fear for the Free Software Foundation not having a succession plan, even though Richard Stallman is problematic and they stick with him. I think the Free Software Foundation may fall apart when he's no longer available. That's a comment.
I'm not touching that one. I have my own views, but I keep them to myself.
That's cool.
The
I appreciate
FSF
that.
has some big challenges ahead of it, and whether or not it can maintain its own relevance is within its own hands. And I'll leave it at that.
So my view of this is that the GPL, regardless of who created it, still has power. And
the product of what the FSF and Richard Stallman did will never go away. That legacy will never go away.
Yep.
Okay? There's other baggage that's unquestionable.
Right.
But what was created and what exists can't be undone. The GPL was as great as it was, continues to be great. There still needs to be other things, like as more of the world goes in the cloud, we need to encourage more people to move to something like a Pharaoh if you're still interested in cloud-based open source, because the cloud is the way for organizations to use the GPL but still close off their code because their users are all doing it in the cloud. So there's still a challenge for the free software world that wants to maintain software freedom And that means more use of a Pharaoh in the cloud. And that's still a fight that needs to be done. And we need organizations like the FSF to do it. Is it capable of stepping up? Like I said, that decision is in their own hands, and that's as far as I'm going on that.
Thanks, Evan. Question for the speaker: why Discord instead of an open chat system?
We went through Matrix. We went through. There's so many different ones, and we ended up making the strategic decision to go where the people were. And so that's always a difficult decision. Do you want to use the tool that is open source, or do you want to use the tool that's got the massive installed base of people that are already there that you want to try and attract in? And so we evaluated all sorts of things. I mean, we're still using open source as much as we can. We're using Mattermost instead of Slack. We're using Big Blue Button for our meetings and so on. So yeah, we try and do it whenever we can. But in this particular case, the purpose behind going to Discord was to attract a new audience. And when that happens, you sometimes have to make a decision to go where the audience is.
I had a question. Really good talk, by the way. Really enjoyed it. I was wondering, since you implemented your code of conduct, what would you gauge its effectiveness has been, and have there been consequences for, quote, bad behavior?
The consequences are going to be different depending on the context. So for instance, within LPI, if a member exhibits egregiously bad conduct and does not account for it, there's mechanisms to either remove membership or whatever. We've never come close to having done that. We've actually found that the mere existence of the code of conduct gives people an idea of what their target is. And unfortunately, you have to say, don't be a jerk to get people not to be a jerk. But sometimes merely having merely that statement that's saying this matters to us actually is effective far more than you might expect.
I had another question. Okay, I'll do one more. I'm a little concerned. You look at the age, if you do an average age of everybody in here, you get a little concerned about the young folks and membership and succession. So I'm wondering, have you seen an uptick in 20 and 30-year-olds in your organization? Are you concerned, like I am a bit, that we might be, there's no generation to pick up the ball?
That's why I'm giving this talk. I mean, I want to try and raise the alarm that succession planning is a thing that open source projects need to concern themselves about. That assuming that the people that founded it in the first place are not going to be there forever and having to deal with that reality is something that projects large and small are going to have to deal with. And I guess that's the point behind me being up here, is to try and note that, the tech skills aren't enough. There are people that need to step up in leadership, and sometimes that could be leadership by committee. You don't need to have, a charismatic person at the top. You can have a leadership by committee. It doesn't have the same sex appeal, but it can work just as effectively, especially when you have a situation where you have a lot of large companies that have agreed to do an open source infrastructure project on which they all build their own things. In that case, leadership by committee will suit everyone. And I would point back to that Mozilla document again as giving in numerous examples of different ways to do an open source project, and they'll have wildly different ways of doing governance, of doing their boards, of doing leadership. And it might just be a charismatic person at the top, and that thing might just, explode into something great and then fizzle out just as fast, and maybe that was what was intended as an experiment. That's still legitimate use of these techniques and these licenses. There's lots of stuff you just toss over the wall, and maybe people will pick up on them, and maybe they won't. And that happens too, and that's totally legitimate. That encourages innovation. You may toss 3 things over the wall, and only You know, the fourth one gets taken up by anyone. That happens. That's the way it works. To me, that's a good thing. But it also means that there's a lot of different ways to handle this. So that's why I wanted to call attention to that Mozilla document. And if you missed it on the slideshow, just do a search for Mozilla open source archetypes, and it'll point you to that. It's a PDF.
Thank you.
Alrighty then, I guess that's it. Thanks again. Enjoy the rest of the conference.
So, about 15 more minutes to the next talk, guys. So. All right. Our next talk is by Stephen Pritchard. He's a Puppet certified professional. Is currently employed as an architect for Secura, and he's focusing on Puppet compliance automation, all things DevOps.
Thank you.
Stephen.
Okay, so if by any chance any of you were here for my talk yesterday, this is basically behind the scenes of how I did my demo yesterday, essentially. So I want to talk about two tools that I use, Bolt and Vagrant. In my job, I do a lot of infrastructure prototyping, so building a bunch of servers, setting them up to mock out what a server environment would look like with different pieces of software. And oh, who am I kidding? This isn't just for work. I do this for fun too. Anyway, this is the pattern that I have kind of landed on recently, and I think it's interesting, and I hope you do too. Okay, so let's talk about the two pieces. So Vagrant, I don't know how many of you here are familiar with Vagrant, but Vagrant is one of the many products from HashiCorp. It was actually one of their earlier things, but HashiCorp is the makers of Terraform and Vault and just, I don't remember how many other things, Nomad and so on and so forth. Anyway, HashiCorp makes a lot of cool stuff. And what Vagrant does is let you do easy infrastructure prototyping. You can define one or more virtual machines with basically any configuration that you want. CPUs, memory, disks, et cetera, and real quickly spin them up, and more importantly, tear them back down, and then lather, rinse, repeat, right? It has a unified configuration language for VirtualBox, libvirt, and others. It's actually based on Ruby at the moment. I don't know how many of you here are familiar with Terraform, but HashiCorp actually announced recently that Vagrant is going to be moving in the direction of using the HashiCorp configuration language that they use in Terraform. So there will actually be some synergy between those two tools. But anyway, you can find more information at vagrantup.com. By the way, this talk is very slide heavy because I'm going to do a little bit of a demo at the end, but I am going to have a lot of slides. If anything that I'm saying is not terribly clear, any of you who are in the room, feel free to go up to the mic and ask me questions, interrupt as much as you want. I'm fine with that. All right. So the other piece of this is a tool called Bolt. Bolt is from the company Puppet, who makes the tool called Puppet. It was announced a few years ago at their at PuppetConf, and basically started out as kind of their answer to Ansible, being able to do one-off things. Because the thing about Puppet is and I'm a big fan of Puppet, don't get me wrong, but Puppet is really, you're defining a state that you want to maintain over time. It's not really about like, I want to go start up this thing and I want to go start up this other thing, and right. So, Ansible and Puppet to me have always been two different tools for different jobs. Bolt was kind of their answer to that, and initially it was kind of janky, but it had a couple of interesting ideas, and over time it's really grown into this really cool tool that will let you do the automation of like starting up a cluster or something like that, where you can go do a thing over here and do a thing over here and do a thing over there in order. But it lets you do, you can use it to run commands and scripts, and also you can actually use the Puppet language configuration. So if you've got Puppet code that'll do a thing, that'll maintain a thing over time, you can use that to bootstrap things, right, using Bolt. So anyway, it's a great orchestration tool. One of the things that I want to focus on actually here is the inventory support. This is one of the cool things about this. It has a pluggable inventory system. So when you combine that with Vagrant, you can define your inventory based on the boxes that you've defined in Vagrant, which is kind of cool. Anyway, you can go to puppet.com/open/bolt to learn more about that. So to get started, you need three things. Bolt, Vagrant, and then you need a Vagrant provider, a virtualization provider, because what Vagrant does is spin up virtual machines, right? Actually, what Vagrant does is spin up whatever you tell it to spin up. That can be virtual machines, that can be containers, that can be cloud instances. There are actually other ways of doing this besides just using a virtualization provider. Anyway, the virtualization provider that most people end up using is VirtualBox because it's available basically everywhere. And yes, VirtualBox is absolutely the lowest common denominator. I don't know if anyone's actually a fan of it. It has its limitations, shall we say. I happen to be a big fan of libvirt on Fedora, but when I go over to a Mac, I can't use that, right? So if I so if I use VirtualBox, I can use it on a Mac, I can use it on Linux, I can use it on Windows, whatever. Anyway, you can pick whichever one you want. Okay, so if you've never used Vagrant, the way to get started with it is you create a new directory, you go into the directory, and then you run Vagrant init and you give it a box name. If you Google for Vagrant boxes, it'll take you to the site where you can actually find different boxes that you can download. So the way this works, it's kind of like when you're pulling a container off of Docker Hub or something like that. It's basically a pre-configured VM, right? So very, very basic pre-configured VM. Some of them have more configuration than others, but most of your Linux distributions actually ship official Vagrant images. I do a lot of my work on Fedora and CentOS, so usually those are the two that I go after, and they both have official images. You can get images for RHEL and Oracle Linux and SUSE and Debian and Ubuntu and so on and so forth, right? So you just have to find the name of one of those, and you do Vagrant init and that name, and it'll create a basic Vagrant file for you. So this file, capital V Vagrant file, in that directory defines the virtual machines that you want to start up. That initial configuration looks like it's got a ton of comments telling you like all the things that you can do in this Vagrant file, but it basically boils down to the 3 lines that are on the screen there. So and again, it's Ruby based, and the most Ruby that you actually have to care about actually is that boilerplate first line that with the do and the pipes. So if you don't know Ruby, it mostly just looks like a configuration file beyond the do and the end in there. So you can edit the Vagrant file and you can define additional virtual machines. So in the example I've got on the screen here, I have that default CentOS 8 box, and I've set it to have a gig of memory when it's running under VirtualBox. So as an example. And then I've also defined a Windows VM. So there are a bunch of Windows Server boxes on the Vagrant site, and also configured that one for a gig of RAM. So once you've done all that, you can run Vagrant up, and it'll start up these virtual machines, and it'll do some basic configuration like set up SSH keys so that you can do provisioning with them and stuff. So again, if you're not familiar with Vagrant, there are lots of things you can do with it. I mentioned Vagrant up, and I mentioned Vagrant init, but there's also a Vagrant rsync. Your current directory, by default, will actually get copied into the virtual machine so that you can, if you drop scripts or something there, you can actually run them from inside the machine. There's probably the most useful thing is Vagrant SSH. So if you've got just one virtual machine defined in your Vagrant config, you run Vagrant SSH, you'll SSH into that machine. You don't have to know its IP address or usernames or anything like that. It'll SSH right in. There's a Vagrant halt that'll stop all the virtual machines. Vagrant destroy will kill them all. Basically, those two are the opposite of Vagrant up. Vagrant status in a directory with a vagrant file will tell you what virtual machines are running, or which virtual machines are defined. And then there's a vagrant global status that will work from anywhere. It's not just looking in the current directory's vagrant file. There's a .vagrant in your home directory that'll look there and see all the vagrant configs. So, and there's a few others, but I'm not going to spend a lot of time on that. Okay, so that is your almost 10-minute introduction to Vagrant. So let's talk a little bit about Bolt. So with Bolt, you can download, install Bolt, and you can just start using it. You can basically point it at systems using their DNS names, and you have to do no configuration whatsoever, right? But for the purposes of this, I want to kind of tightly integrate it into this Vagrant environment. So in the directory where the Vagrant file lives, I can run bolt project init, or I can do bolt project init project name. It'll use the name of the current directory as a bolt project, and it'll create it with that. But if the name isn't something that is valid for a Puppet class name, basically, letters, numbers, underscore, basically. If it's not that, you might have to say bolt project in it and then give it a friendly name. But that creates two files, a bolt project.yaml and an inventory.yaml. The name of the project gets recorded in bolt project.yaml, and inventory.yaml is basically empty, but that's where you define your inventory. All right. Now, the last piece of magic in all this is a Puppet module called bolt_vagrant. This was written by a guy who actually just recently left Puppet. And what it does is there's a task in it that will, script in it basically, that will go and fetch the configuration of all your Vagrant VMs. And it'll build inventory for that dynamically. So if you run bolt module add and then that name, Dylan Ratcliffe -bolt_vagrant, it'll go download that for you, and it'll update your bolt project.yaml, and it'll drop the module in place and any dependencies that the module has. And then last thing we have to do to set this up is in that inventory.yaml, we have to tell it that we want to use that bolt vagrant module to fetch our inventory, right? So we set our targets to use underscore plugin task, which tells it it's a bolt task that we're going to run. In Bolt, a task is basically a script with some associated metadata. It's pretty simple stuff. And the task name is bolt_vagrant : targets. If you go look up that Dylan Ratcliffe bolt_vagrant module, the instructions are all there for how to set this up too. But at that point, you should be able to run bolt inventory show -t all, and you should see the full inventory. And actually, let's go test this theory, shall we? So I have, this is actually the Vagrant environment that I used for my demo yesterday. So we're going to run this command, bolt inventory show -t all, bolt inventory show -t all. And if the demo gods are smiling on me today, we see I have targets, Puppet agent GitLab runner 01, runner 02. So those are all of my VMs that are defined in my Vagrant file, and that's generated on the fly. All right, so now, once all this is set up, we can start to use Bolt against all those VMs, right? So for example, if we run bolt command run hostname -t all, it will run the hostname command on all of your targets, right? So the -t all is telling it, -t for targets, all is all of your targets. I can also say, -t and then give it specific targets. If I want to run it on, on one or more, I can do comma or space separated, basically, after the -t. But if we go over here, I can do bolt command run hostname -t, like I have, there's a GitLab target, right? So I can say just run on the GitLab target. And so what that does is that actually SSHs in, runs the hostname command, and then spits out the output. So that's one thing you can do with Bolt. The next thing you can do with Bolt is you can run arbitrary scripts. So if you've got a script, you can say Bolt script run, and then give it a path to the script. And then again, you tell it what targets you want to run against. So in this example, if you'll recall early on, I had a vagrant file with a CentOS and a Windows VM, right? So the nice thing about running the hostname command is that actually exists on both Windows and Linux. That's why I was using that in the example. And in this example also, if we write hostname out to, myscript.ps1, then we can run Bolt script run myscript.ps1 on all of the targets. On Linux, nobody cares what the extension means on the file. On Windows, that'll tell it to run it with PowerShell, and it still works. So this is one of those rare cases where you can do something that will actually work on Linux and on Windows. So I'm not going to do a demo of that. Anyway, I mentioned running tasks. So Bolt tasks are scripts with some associated metadata. I can show you an example of some tasks as we go along later. I'll go into some code. But there's actually a bunch of tasks that are shipped with Bolt, and you can run Bolt task show to see those. I actually will show you that real quick. So if we do Bolt task show, what we will see, let me make this a little wider, is there's a bunch of stuff. So we see our bolt _ vagrant : targets task, which is what we're using to generate our inventory. And there's a couple of GitLab related tasks because I've got a GitLab module dropped into here. There's like a package task, so you can install and remove packages with as a task. And various other things. I can mess with the Puppet agent and reboot systems and things like that, managed services. Those things are built in to Bolt, and then you see things like this, these role : things. Those are ones that I wrote to build my GitLab environment. So, okay. Anyway, to add additional tasks, you can install Puppet modules, or Puppet modules that contain tasks, that is, or you can create a directory named tasks and drop in the necessary files. So basically, every task has the implementation of the task, the script or whatever associated with it, and then it has a JSON file that basically defines like what the parameters are and whether it supports the no-op flag, and there's not a whole lot to it. Again, I'll show you examples in a few minutes. Whoops, that's not the thing I wanted to hit. I wanted to hit this. Oh, hey, that's right. I have an example right here. So this is what it looks like. So the JSON that describes the thing, it says Puppet Task version 1. This particular thing doesn't support no-op. The description, which is what shows up when you do the, on the right there, whenever you do the Bolt task show. And then in this case, I have a fun thing with implementations. So that thing where I was saying I was running stuff against Windows and Linux, and that only works so far. There's only so many things you can do on both. Well, the way that you handle that, if you actually do want a task to be able to run on both, or on multiple operating systems or whatever, is you have this implementations block in your JSON, and that actually tells it which script to run for which platform, right? And so in this case, I'm saying if I have a shell, run hostname.sh. If I have PowerShell, which is only going to be on Windows, then use hostname.ps1. And then if I had parameters to the script, they'd be listed in this parameters block, and it actually lets you do data types like you would in Puppet, where you can say this is a string or this is an integer or whatever. And then the rest of the pieces are the actual scripts themselves. So in this case, I have a very simple hostname.sh on the right there, which just runs hostname, and hostname.ps1, which just runs hostname. So again, very insanely simple example, but hopefully you get the idea. So anyway, once you have all those files in place, basically, then you can just run bolt task run, and then the name of the task, and then again, specify the targets, right? And if you have any parameters, then you just specify those, key equal value at the end, and those get passed into the script either as environment variables or as a JSON blob, depending on how you configure some things. Okay, now, all of that is very cool, and most of that actually worked with that very first version of Bolt that I said was kind of, iffy, but definitely, definitely something interesting. But anyway, where Bolt started to get really interesting for me was this concept of plans. So Bolt plans are a set of commands, scripts, tasks, or other plans that run in sequence. Now, what's really cool is Bolt actually supports two different kinds of plans. You can either do a YAML plan, which is going to look a lot like the way you would do things with Ansible, or you can write plans in the Puppet language. Now, for those of you not familiar with Puppet, the Puppet language is actually kind of cool. It's kind of turned into this functional programming language. And so there's some really cool stuff that you can do with it. And so plans written in the Puppet language, to me, are just awesome. I can do some really cool stuff. And again, I'm gonna get into some examples here when I get done setting the stage for you all, assuming I have time. Okay, so if you want to write a plan, you can, unfortunately, there's no Bolt command to generate a task for you, which is weird, but there is a Bolt, there is a Bolt command to create a new plan for you. So it'll lay out the basic plan. So you can either run Bolt plan new and then your plan name, or you can run Bolt plan new, the plan name, -pp. So if you don't have the -pp, it creates a YAML plan. If you have the -pp, it gives you a really basic Puppet language plan that you can start from. Or alternatively, you can just add the YAML file or the .pp files to a directory named plans in the Bolt project. So here's an example of a YAML plan. When all this is on YouTube later, if you all want to prove that all this stuff works, go for it. If you follow along with all the code in the slides and copy, or well, I guess you can't copy paste, but there's a blog post with actually all of this information that you can find if you dig a little. If you copy and paste the bits from it, you can actually walk through this whole thing and kind of see how the whole thing works. Anyway, so for our YAML plan, we're going to basically give the description for it. We're going to say what the parameters are, which basically all we're taking as parameters are the list of targets to run on, in this case, and then we have steps. So and this again, this is the plan that's generated by Bolt, and so basically it's just it spits out a message hello from this plan name, and then I've added a command step that runs hostname on all the targets, right? So every one of these examples does exactly the same thing. And I know they're just getting progressively more complicated, but that's also because we could do a lot more. And I, again, will show you. So our Puppet plan looks like this, where we have the plan and then the plan name. We specify as a parameter to the plan the targets we want to run on. we call the out : message function to spit out a message, and then we do the run command function in order to run the command host name on all of our targets, and we return a result. Running those looks an awful lot like running everything else. You do bolt plan run, and then the plan name. In this case, we don't have to give a list of targets. We can. We don't have to, because in our previous example, we defaulted to a target list of all. So if we don't specify the list of targets, then it just runs on all of them. Okay, now, we talked about Vagrant, we talked about Bolt. Now we talked about that, the Bolt Vagrant plugin that lets us tie the inventory together, right? Now, the last thing that makes this super cool to me is actually using a Bolt plan for provisioning. So if you're not familiar with Vagrant, one of the things that you can do is you can have scripts in line or point to scripts on the file system to have it run. It copies everything over to the /Vagrant directory on the VM. It runs the scripts. You can do all kinds of crazy stuff. And I've got all sorts of examples where I did all kinds of crazy stuff with shell scripts and whatnot. But what we can do is we can completely disable copying the /Vagrant directory over, and we can just run a Bolt plan that does everything for us. We have to enable one experimental Vagrant feature called typed_triggers. And you do that by setting an environment variable. Well, it just so happens you can just set the environment variable in the Vagrant file because, again, it's just Ruby, right? So we can set env Vagrant_experimental = type triggers. And that lets us do the next thing we're going to talk about, which is configuring a trigger. So what we're going to do is we're going to configure two triggers. We're going to configure one for before certain commands run. So in this case, we're saying config trigger before up, provision, and reload. So those are the commands we're going to add this trigger to. It's going to run this. It's going to run the trigger.run equal inline bolt module install. So we want to do a bolt module install because if you grab this whole thing and we've added plugins like that Bolt Vagrant plugin, we need those modules downloaded and ready, right? So bolt module install with all of the other configuration available will go fetch all those modules for you. So we need that to happen before we do anything else with Bolt. And then the other thing we want to do is we want to run a trigger after this is run. So we define all of our virtual machines. We do a Vagrant up. Vagrant spins up all the virtual machines, and then it runs Bolt plan run, and then the plan name that we want to run with this trigger in place. So there are lots of examples of this. Well, lots. I think 4 or 5 that are on GitHub. They are all mine, but I tagged them all with the same tags so that you could actually see those individual things. All right, we are right on time. So what I want to do now is switch over and actually show you a little bit of what one of those things looks like. So this VS Code window back here that I need to blow up. This is actually this is the demo that I did yesterday. Okay, those virtual machines that are running in Vagrant are the virtual machines that I was running. And all of this, by the way, is on GitHub. You can find it by using the search terms that I had in the last slide. Go back to that real quick. The search terms are puppet-bolt and vagrant-environments. So you can find those on GitHub pretty easily. Also github.com/silug, S-I-L-U-G, that's me. So anyway, all right, so let's look at the pieces of this. So there's a lot more to this particular thing because I've got it doing a lot of stuff and this is pretty fleshed out. But if we go down here to our Vagrant file, this Vagrant file is not substantially more complicated than what we had there. I have a little bit of extra stuff because I have some configuration options. Like I can actually like change the box that I'm using. I have the ability to run to use a cached GitLab RPM, because the first time that I tried to work on this when I wasn't on my home internet, I realized that 10 megabit Wi-Fi trying to download a 1 gigabyte omnibus GitLab package was a little slow. Yeah, took a while. So I'm like, okay, I'll download that once, and then I'll just copy it over to the VM, and I'll go from there. So there's a little bit of extra code in here to do that, but most of this is just defining my virtual machines, right? So I do a little trick here where I'm actually setting up for either VirtualBox or libvirt. I'm running libvirt locally. Libvirt's a lot faster if you've got a Linux machine. Use libvirt. Don't use Vagrant. You'll thank yourself. But true story. Yes. Confirmation. Anyway, so I have my Puppet virtual machine, and I'm giving it 3 gig of RAM, 2 CPUs. I'm setting the host name, a little bit of configuration there, right? And I'm also setting up a private network on each one of these so that they can talk to each other. And then I define an agent, which I never used yesterday, defining my GitLab server, giving it 6 gig of RAM, 2 CPUs, and then I've got a couple of runners with 4 gig of RAM and 2 CPUs each. So like I said, most of this is just setting up all of my virtual machines. And by the way, the little bit of Ruby that I am doing in here, I am going to super miss when they do move over to the HashiCorp configuration language. I'm going to have to figure out how to do all that with that language again. I've done Terraform, but it's been a minute, so I got to go remind myself how to do that. Anyway, and then there's that before trigger that does the bolt module install, and then afterwards I'm running a plan named roll, but I'm actually passing some parameters into it. One of the parameters I pass in is demo equal true. So I started trying to refactor things so that the demo environment builds with some defaults set. But if you ran this plan against real systems, then it wouldn't do the weird defaults that make sense only when you're running in Vagrant, like the port redirection and stuff like that. So I started trying to refactor this a little bit, which actually, by the way, is a point that I kind of didn't make in my slides. One of the things that's cool about this is I can prototype all of this stuff out using the bolt plan. When I'm done, I can just run the bolt plan and set the targets to real hosts, right? So if I've done it right, and I'll tell you honestly, I haven't done this right because I haven't tried running it against real systems, so I know I've still got some Vagrantisms in it. But if I can strip that out, when I'm done, I should actually be able to run this bolt plan with a target list of a GitLab server and a Puppet server and some runners, and all of the right things should just happen the exact same way that they happened in Vagrant. That is the ultimate goal here, right? Because the thing is, all of my prototyping before, where I was just writing a bunch of shell scripts, if I wanted to do that on a real system, I had to go back and then go figure out how to copy those scripts over and run them in the right order, and and again, strip all the Vagrantisms out of them and whatever else. It just showed me how it showed me how it would work. It didn't show me exactly how to do it, right? So my eventual goal is to make all of these projects that I have on GitHub work for real. So you could point them at a real system. And at the moment, they're all in varying states of that. And by the way, in fairness, I think I figured out how to do all this in the last 8 months, maybe, I think. So this is still a relatively new pattern for me. I'm still sorting it all out, but I still think it's cool. Okay, so that's our Vagrant file. And in this thing, I've got more Puppet code because, again, it actually started life as a thing to build a Puppet server and show how to bootstrap a Puppet server. I actually talked about this project, an earlier version of this project, a couple like 2 or 3 years ago. I don't remember exactly. I had to talk about building about bootstrapping a Puppet server and like what that looked like. That was all done with a bunch of shell scripts and stuff in the Vagrant config. And I refactored that whole thing to use Bolt. So that's one of my sample projects out on GitHub. When I was building this, I actually just grabbed that, tacked on the GitLab server and some of the CI automation to that project. So if you look at the Git history on this thing, it goes back a number of years. But anyway, so my main plan is actually very, very long. 247 lines. It's not that long. This is, this is kind of first attempt at this. I haven't gone through and really, really, really tried to clean this thing up yet. But anyway, what I started to do though is like say I have a parameter that's $demo here, and then I set some things based on whether $demo is set or not. So like the this user, I use the Vagrant user if it's in the demo environment, but otherwise it sets it to undefined. But anyway, so this is what the Puppet language looks like. I have some code in here to set the Puppet version because that was another thing that I wanted to do with that other that Puppet server environment is I wanted to be able to like show what it looked like with Puppet 6 versus Puppet 7, things like that. But where it gets fun, this is my favorite part here. So I have this snippet of code that actually goes out to one of the first things it does is it goes out and hits every system and it grabs their facts. So in Puppet, you have this concept of a fact, right? So things like the host name, the IP address, the whether the system's virtual or not, things like that are all facts. And you when you're writing Puppet code, you use those facts to do a lot of logic, right? So what I do is I go and I fetch the facts from a system, and then I iterate over all of those targets. And I grab the IP address of the last network interface that has an IP address associated with it, and I store that. And I also store the host name of the box and the AFQDN. And then I have a little snippet of Puppet code that goes and sets host entries on every box for the IP address and the host name, the fully qualified domain name and the short host name for each one of the systems in the target list, right? So if we actually were to look on any one of these VMs, you'd see that they have defined host entries for GitLab and Puppet and the runners and whatever else, so that I can use host names, various places, and things just work, right? Without having to have working DNS. So that was a fun one that I figured out how to do. And then I just kind of start diving in and start doing stuff like I copy my GitLab package over and install it. And I've got a task that imports my controller. Basically this repository gets copied into the GitLab server. And that's done with this shell script that does lots of JQ. Anyway, lots of things. But it's just a shell script. That shell script has this JSON file associated with it to define the task. So again, tasks are pretty simple. Where did I clicked away and there it is. Anyway, so again, this is somewhat involved because there's, in order to, bootstrapping things is hard. And that's one of the reasons why I love prototyping things with Vagrant, because then you figure out, oh, I have to do this thing, and then I can do this thing, and then I can do this thing, right? And when you build all this stuff by hand, you know, a lot of times you just know, well, I got to go over here and I got to do this thing, and then I got to go over here and do this thing, and then I got to go back over here and I could do this thing. And or over time, like you've built something and you've iterated on it, and you don't actually remember like all of the steps to get to the point you're at, right? So I love capturing that stuff with Vagrant and being able to say this is exactly the steps to get from 0 to finished product, right? So anyway, I have, if we go back to here, I actually have this. This is that the search page on GitHub that shows those things. So apparently I have 4 repos at the moment. So the one that we're looking at in VS Code is this GitLab Puppet thing. I actually have one for spinning up the compliance automation software that we use. Basic AIO is actually the project that my GitLab thing was based on. But something completely different that I have is I have one that spins up a couple of systems and sets up a Samba 4 domain controller. I actually have one more project that isn't showing up on that search page because I haven't merged the changes yet. That sets up an active-passive firewall pair using CentOS and Keep Alive D and Contract D and various other things. It's actually, I actually wrote this with all shell scripts and everything else and demoed it for a users group meeting like 4 years ago. And since then figured out how to puppetize all the bits of it, and I actually use it at home. Anyway, I'm circling back around and taking the Vagrant demo that I did and trying to use this pattern with it. I just haven't merged the changes yet, so I hadn't gone back and re-tagged that, but I'll get to that now that I'm remembering that that's a thing that I need to do. But anyway, I have gone on now for 40 minutes, so surely someone here has a question for me. Anybody, help me out. All right. If anyone has, if you have a question, there's a mic right there.
So for those that were at the talk yesterday, how long does it take with like a Vagrant up to actually spin up that full GitLab environment with Runner and Puppet server and everything else? All
right. So on my beast of a laptop that I just got, it takes about 14 minutes for that whole thing to spin up and do all the things. On my slightly less beefy desktop at home, it takes about 17.5 minutes. So I have some other Vagrant environments that take like, half hour plus to spin up. I should mention one of the other reasons why I started going down this path is with Puppet code, one of the cool things about it is that it is eventually consistent. So you try to write your Puppet code so that when it applies, it gets everything into the end state that you want on the first run. But if it doesn't, it'll just keep doing things in order to get closer and closer, and it'll converge on the state that you want, and then it'll maintain it, right? So if you're writing a lot of this stuff using Puppet code, you can rerun the provisioning over and over again. And as you're iterating on, trying to figure out how to set all this stuff up, you can just run it over and over again. When I historically have done things with Vagrant, I would modify scripts and stuff, I would tear the whole thing down, and I'd start all over again, right? So when you start getting into environments that take, 15 minutes, 30 minutes, an hour to spin up, right? It starts to get really obnoxious in order to iterate by tearing the whole thing down and completely starting over, right? So using Bolt, I can do a lot of my iteration by just rerunning the Bolt. I actually can just run Vagrant up again. Like I can make changes to the code. I can run Vagrant up. It won't do anything with the virtual machines, but it will run the provisioning trigger again, right? Which runs the Bolt task for me. So I don't have to remember how to run the Bolt task off the top of my head with all the parameters and stuff. I can just run Vagrant up, and boom, the thing happens. And in a lot of cases, if I'm, especially when I'm getting close to being done, instead of taking 14 minutes to do that one thing that I added to it, it might just take 30 seconds, right? So it saved me a lot of time. So that was kind of cool. Anyway, any other questions? I feel like I have bored everyone to tears. This talk's a little deep in the weeds, so I wasn't sure how everybody would feel about it. This is something I've been living, sleeping, eating, breathing for like I don't know, a while now. Hopefully I did it some justice. So. But all this will be on YouTube, and if you're interested, the company that I work for, Secura, we've got a table right out here. The QR code on the left will take you to the Secura site. The QR code on the right is my LinkedIn profile. You can feel free to message me if you want more information or whatever else. Or if you want some help with doing some server automation and compliance stuff, feel free to ping us over on the other one too. If there aren't any more questions, then I guess I'm done. So thanks, everybody.
Thank you, Stephen. Just a couple of announcements. If you bought a T-shirt, you need to go and pick it up. If you haven't picked it up already, by 3 o'clock, I think, is what they're saying at the booth. The next talk is on Kubernetes, and it's at after lunch. So lunch is going to be in Union A and B. So if you bought lunch, if you didn't buy lunch from OLF, you can go down to there's a food court nearby down the escalator that way. So thank you very much. Principal DevOps engineer with approximately 20 years of IT experience. He's been using Kubernetes in production for the past 3 years.
Excellent. So let me first get, is it presenting? Okay, excellent. Let me go over here and make this full screen if I can. Yay. All right, good afternoon, everyone. Welcome to my talk, Kubernetes Fundamentals. Everyone have a good lunch, we're awake, not getting the itis or anything like that. We're good? Okay, cool. So we'll get started. Then the next slide. Excellent. So who am I? Thanks, Paul, for the introduction. My name is Greg Greenlee. I'm a principal DevOps engineer for a company called Insight. We're an IT solutions company. Been there for about 3 years. So we do everything from web application development, AI, machine learning, DevOps engineering. We augment teams or we place an entire team to take on projects. We are hiring, especially for DevOps engineers. So if you're looking, go to insight.com and I think you can go to careers from there. Born and raised in Cincinnati, Ohio. Currently reside in Cleves, Ohio, which is actually west of Cincinnati. A mentor for Perscolas. That's an organization that seeks to train people for entry-level IT positions. Linux enthusiast. I've actually been coming to Ohio Linux Fest, or now Open Libre Free, since 2006. So quite a long time. Comic book enthusiast, Marvel, DC. And I'm also father or husband. And my wife told me not to put her on the spot, so I'm going to do exactly that. Because this is her first time actually seeing me speak in person, so there she is in the middle. Yay! She'll kill me later. No, she's not. We're going to Ruth Chris, so. All right, so our agenda for today is we're going to talk a little bit about some of the common terms that we use when we're discussing Kubernetes. We're also going to talk about what is Kubernetes, or K8s, or K8s. Why do we need Kubernetes? How does Kubernetes work? So we're going to go over some of the components, some of the objects, and then how do we interact with Kubernetes? So microservices, we're going to go through this whole list of common terms. So microservices are essentially a bunch of small independent services that communicate via RESTful API calls from one another. You have all these microservices and they communicate with each other and they form a bigger app. So anyone who's not familiar with microservices, that's essentially what it is. And the microservices allows you to scale up, scale down, the different components. So for instance, if you have a website that has like a shopping cart, that shopping cart might be a totally different service from the actual front end that's presenting it. So in periods of like high load, you can actually scale that microservice that runs that shopping cart. And that way, you can have these independent components and you can scale one independently of the other. We're going to skip imperative versus declarative and current state versus desired state. I'm going to come back to those. Cloud native. So essentially, cloud native are just apps that are built for the cloud. They're built to actually utilize cloud services. So Azure, AWS, GCP. When you build your apps, a lot of people or a lot of companies are now refactoring these apps to work with these different cloud services. So these cloud services, they offer things like database, message queuing services, and things like that. And so when you build a cloud native app, you're building it to utilize these services natively instead of some type of bolt-on component. So immutable versus mutable. A mutable object can be changed after it's created. Immutable objects can't. So if you think about your traditional IT, operations back in the day, you kind of SSH on the servers to make configuration changes. And so Kubernetes will help with that type of thing. And so you don't actually make changes to the server, you make changes to the image. You wind down the servers that's running, you spin up the other ones, and that way you always know kind of what's running because you're not changing it on the fly. So you don't have like this configuration drift that's happening. Containers. Oh, by the way, I didn't ask. Does anybody in here actually use Kubernetes? Show of hands. Okay, so a few people. Okay, cool. So containers, standard unit of software that packages up code, analysis dependencies. Images lightweight. They share the machine's OS. So, and then the container runtime is the software that's responsible for running the actual container. So you have your container runtimes like Docker, Containerd, and there's a few others that are out there now. But they essentially make sure that these containers are running and that these containers are doing what they say they want to do. So we're going to talk about imperative versus declarative. And I like this analogy here because imperative is more concerned with a series of steps to achieve its goal, and declarative is just you declare what you want. So in this analogy here, you might have, you want some cake, and imperative way is to actually have your recipe and you list step by step exactly what you need to do. Declarative is just saying, no, I would just want some effing cake, right? And it goes out and it gives you a nice chocolate cake. In this sense, however, it's going to be about spinning up containers and declaring what you want that to look like. All right, so current state versus desired state, and I like this analogy where it uses the nest because current state is what does your environment look like compared to what do you want your environment to look like. So in this analogy here, your current state is 72. You want your desired state to be 68 degrees, right? So you set it, and then if at any time the temperature actually rises above that, then of course the air conditioner kicks in and it sets it to the desired state. So that's the difference between current state and desired state. So what is orchestration? And I grabbed this definition online and modified it a little bit. The arrangement of containers for application of system performance and the planning or coordination of the elements of a situation to produce a desired effect. So essentially, Kubernetes is an orchestration tool for orchestrating containers. And we'll get more into that in a bit. So Kubernetes helps you scale up, scale down, can perform updates, rollbacks. It's orchestrating this whole thing. So it's self-healing, a node goes down, you need to do upgrades. It does all that stuff for you. All right, so what is Kubernetes? So Kubernetes was first open sourced by Google in 2014. It's not the same exact thing that Google was using. It shares DNA with Borg and Omega. It comes from the Greek term meaning helmsman or pilot. It's what's considered or has been considered a data center OS. And I like that term because if you think about what an OS is, it's essentially abstracting away the hardware from the applications that's running on top of it, right? So it governs resource allocations and things like that. So Kubernetes does the same thing, but in the same thing, but with data center resources, right? So you have the operating system defined as system software that manages computer and hardware software resources, and then this is no different than kind of what Kubernetes does, which is abstracts the compute in your data center, right? So it sits above your cloud-specific platform. So Kubernetes runs on, or each one of these different cloud platforms, such as Azure, such as AWS, they have their own implementation of Kubernetes, which essentially sits on top of their infrastructure and provides you with compute resources and things like that. So why do we need Kubernetes? And I just had a pretty good discussion with a guy out in the lunchroom about this. Chris, is Chris here? Did he come in here? No? Okay, good. All right. So why do we need Kubernetes? Because all these smurfing containers. Like, what the mother smurf is going on? You got Papa Smurf popping over here. You got Brainy Smurf braining. And we need a way to be able to control these containers. Containers are a good way to bundle, run your applications. But in a production environment, you need a way to manage these containers. And since we live in a world where uptime is critical, we need to ensure that there's no downtime. So for example, if a container goes down, another container needs to start in its place. And this is all handled by Kubernetes, right? That's how Kubernetes comes to the rescue. It provides you with this framework to run these distributed systems resiliently. It takes care of scaling and failover for your applications, provides deployment patterns, and more. So, for example, Kubernetes can manage a canary deployment for your systems, right? And so what this gives you is online self-healing, speed, safety, and reliability, zero downtime updates and rollouts, immutability, and it does this all in a declarative manner, right? So this part of the talk, I'm going to go over some of the Kubernetes components. These are the components that actually make up the Kubernetes platform. Real quick, so kind of the steps to deploying an app or having an app run on Kubernetes. You write your app as a microservice in a language of your own choosing. You package this service in its own container using Docker files or using a Docker file. So you build the image, you upload the image to a container registry. And then you essentially wrap each of these containers in its own pod, right? You deploy the pod to the cluster via deployment, daemon set, stateful set, cron jobs, and you do this using what's called a Kubernetes manifest. All right, so we're going to talk about the various different components. So on the right-hand side there, you have the Kubernetes nodes. This is the compute that actually runs your workload. And on each one of these nodes, you have a kubelet, and you have kube proxy, and you have the container runtime. So the kubelet is the agent that runs on each node to make sure the containers are running in a pod. And it communicates back to the kube API server. So if there's a pod that goes down, the kubelet is the agent that notifies the kube API that it's down, and then it goes through the whole process of spinning that pod back up. You have your container runtime, which we talked about, which could be Docker, it could be containerd. You have your kube proxy, which is a network proxy that runs on each node as a daemon set. And that maintains your network rules, allows communications, network communications to your pod, and it uses OS packet filtering, if that's available, and it forwards traffic itself if it's not available. And each one of these nodes actually has its own IP as well. So then you have your control plane, which they used to call Kubernetes master, but now they just simply refer to it as a control plane. And this is the Kubernetes API service, the component that actually exposes the Kubernetes API. And the cool thing about Kubernetes is each one of these components utilizes the API. So it's kind of like they eat their own dog food. And which makes Kubernetes extensible as well. So you can write against that API and you can extend Kubernetes as much as you want to, right? So everything that needs to communicate within Kubernetes communicates via the kube API server. So then you have etcd, which is your key value store. You use to store all your cluster data. And your etcd should be backed up because that's what stores your cluster's desired state, among some other things as well. So you need to safeguard that as much as possible. Your kube controller manager is the controller of all controllers, right? So I'll be talking about different controllers and what they do, but the kube controller manager actually controls those controllers. So it consists of like several different, what they call control loops, and it watches the API server for changes. So if the API server communicates that there's a change, then it notifies these controllers, and these controllers go out and it does their thing, whether that's spinning up a new pod or placing a new pod or placing a pod on a new node if it's within a daemon set. So it does all those things. Then you have your scheduler, and that essentially just watches for new work and assigns it to the nodes. And then you have your cloud controller, which is mainly used for services or integrations on a cloud platform. So it manages integrations such as nodes, load balancers, and storage that these cloud providers actually provide. All right. All right, so essentially how this communication works is you write your manifest, which is written in YAML, and that's kind of a declaration of what you want. You submit it to the API server via kubectl, kubecontrol, or kubectl. Use any one of those. And then it manually, and that's done usually via automated pipelines. And then the API server then communicates with the various other components. Schedules it to run on one of the nodes, and then that node communicates with the API server regarding the status of the pods that are running on that node. So that's kind of the communication flow right there. All right, so now we're going to talk about the K8's objects themselves. The first one, the Cage Smurf object. No, I'm just kidding, this namespaces. So namespaces are essentially a virtual cluster inside of your Kubernetes cluster. It's a way for you to logically separate. You can separate out different types of things. I've seen people separate environments, or based on environments, based on application. And it's just a real good way to isolate each one of these different services that you have running in Kubernetes from each other. And then you can apply like, rollback, RBAC to each one of these namespaces for security purposes. So if you don't want someone on your team messing with an application that resides in one namespace, then you can set up RBAC to role-based access control to prohibit them from doing anything within that namespace. And you can also limit other things, such as quota levels for cluster resources, like CPU, memory, that type of thing. You can base that off of the namespace as well. So essentially, that's really helpful for preventing this kind of like this cross-project contamination. And since, these namespaces, they provide like these independent environments. So that's a way to kind of take your Kubernetes cluster and kind of chop that up even more if you need to. All right, so the first, or I guess the second Kubernetes object we're going to talk about are pods. It's an API object. It's the smallest atomic object, and you really won't interact directly. You won't deploy a pod per se. You would usually deploy a pod within the framework of a daemon set or a deployment or a stateful set or something like that. If you're working with Kubernetes like in a development environment, on your laptop or something like that, then yeah, you probably will deploy a pod or something like that just to play around with it. So in terms of Docker concepts, pod is similar to a group of Docker containers with shared namespaces, shared file systems. Each pod is meant to run as a single instance of a given application. So rule of thumb is one container per pod. Although there are things such as sidecars, which allow or gives a pod more functionality. So for instance, if you have a pod and you have a centralized logging system, you might run a sidecar to facilitate, taking logs from that pod and shipping it to a centralized logging server. But you rarely create these individual pods by themselves. Like I said, you normally create them as part of a deployment, a daemon set, stateful set. So this is kind of how it would look like. You have little Smurfs running in each one of these pods. And you can have similar pods running on different nodes. And that is done for like if you need to scale out or something like that, and you need your pods to reside on different nodes for fault tolerance purposes. That's essentially how that would look. And so now, pod health, and I thought this was a demo. It's not. It's so pod health and liveness probe. So you want to know when your pod is, dead, or if it's not up and ready to receive traffic. So Kubernetes uses liveness and readiness probes to help with that. So the kubelet uses the liveness probe to know when to restart a container. And liveness probes are used to kind of catch like these deadlock situations where application is running, but it's unable to make some type of progress, and so you need to restart that container. And the kubelet used the readiness probe to know when a container is ready to actually start accepting traffic, and I'll show you some code here in a second. But it's essentially where a pod starts up. There might be some additional configuration that needs to happen, and you don't want to send traffic to that pod before it's ready to actually start accepting traffic. So you can have a readiness probe wait for a certain amount of time before it actually starts sending traffic to that pod. All right, so that is very small. Okay, that's very big. Cool, so essentially how this works is you have your pod specification here, and this is what this piece of code is showing. And then you have your spec for your container. It's using an image called liveness. And then down below where you see the liveness probe, you can do an HTTP GET to a certain path. And it'll check that to see whether or not that path is up. And if it's not, it will restart that. It'll essentially keep checking on that specific page. And if it's stops responding, then Kubernetes knows to restart that pod. I actually didn't show the readiness probe, but the readiness probe, the YAML looks pretty similar, but it just has some different configurations when it gets down to configuring it to actually say, hey, take this many seconds before you actually start sending traffic to it. All right. So we are going to go into demo stage. You know what? Hopefully I can figure out all about bringing this over to here. Not going to work. It's not bringing it over. Hold on. There it is. Cool. All right. Okay. So let me get my. All right. So we are going to first VM into demo 1 pod, and we're going to show you the Kubernetes manifest for the pod. All right. So what you have here is the API version. To start it off, and then you specify the kind, which in this instance is a pod. Then you just give it some metadata, and this metadata can be used for different things. In this instance, once I create the pod, you'll actually see the pod being called nginx -pod. I'm giving it a label, and that's going to be useful for when we talk about services. It's essentially how a service finds a pod and knows to associate that service with the pod. And then we give it some specs for the actual container itself, right? So the container that'll be running inside the pod. So you'll have your image, in which I'm grabbing an nginx image. I'm giving it a name. I'm actually specifying resources, which you can do in Kubernetes. So this is good for when you wanted to limit certain services or certain applications from kind of hogging all the resources on a specific node. Because some services actually do that, and so this is a good way and good practice to actually implement this in your teams to say, hey, you have to have resource limits so you're not hogging all the resources. And then we just give it ports to be able to connect to that pod. We want to expose those ports, so that port section actually specifies what ports we want to expose. So that's that. I'm going to close that, and now I'm going to start the pod. So to start the pod, do a kubectl apply -f. -f is for the file, and then demo 1. Cool. So pod is created. So I'll do a kubectl get pods, and that shows us our pods. All right. So I have nginx pod, the one that we just created, and you can see that the age of it is 8 seconds. And I have nginx curl running because what I want to do is I want to do a kubectl exec, it, nginx curl, then bash. So that'll essentially allow me to get a bash prompt on that nginx curl pod. Cool, so I'm inside the pod. So now, just to prove that pod is actually running Nginx, you know what? Let me do this first because I want to do a kubectl describe pod Nginx curl. All right, okay. So some essential, when kubectl or kubectl describe gives a lot more information about that specific pod. It gives the image ID that it pulled it from. Of course, you can see it pulled it from the Docker registry. It shows you the IP address of the actual pod itself. And it also shows you, I should have done this on Nginx pod, not curl. All right, cool. Similar stuff, but this IP is really what I need right here. So on 172.17.0.2, you can see the label, all that good information. And then down here, it actually shows you the events of what happened. So you can see that it created the container and started it up. So cool. So let me go back to my command. All right, so now I just want to do a curl 2.17.0.2. Boom. Nginx. Right? Excellent. So the demo gods were nice to me today. All right. So let me go back to, okay, presentation. All right. So we're going to talk now about services. So now that we have our pods running around and cutting grass and doing Smurfy things, right? We need a way to be able to access those pods. When a pod comes up, normally you can only access that internally. As you've seen, I just used the IP that it was assigned. But you know, in order to make these things useful, we need to be able to access it publicly, right? So how do we do that? Gargamel, right? He was responsible for trying to expose the Smurfs. Get it? Forget about it. Anyhow, so services to the rescue, right? Each pod has its own unique IP address. Those IPs are not exposed outside of the cluster without a service. So how do we do that? So services allow for your applications to receive traffic, and it's an abstract way to kind of expose these applications running on a set of pods. It's an API object. It provides stable IPs to the pods, provides some a level of DNS as well. And there's different service types. You have your cluster IP, which exposes the service on an internal IP in the cluster. So, I mean, that's kind of useful, but not, it's only reachable from within the cluster. So if we want to expose it publicly, we can do it using a node port, or in which we really don't want to give people access directly to the node. So we usually do it through a load balancer, which creates this external load balancer, and then it load balances across the pods. So essentially how that looks is you have your service, it gets spun up. You have what's called a selector, and that's what the service uses in order to associate itself with the pod. And we set that label within the pod manifest itself. So that's how it knows to say, hey, I'm going to send traffic to these specific pods using a selector. So you can see I have 3 different pods there, but the label on the last one is app Apache and not app Nginx. So it won't send traffic to those 2 pods, or that pod, it will send traffic to app Nginx. And so you have this stable IP sitting in front of your pods where you can send, people can access, and they can get access to the services that's running behind it. So how does this look? Another demo. All right, let's get it. All right, so let's get back to. Why didn't that come up? There it is. All right. And let me get my thing here. All right, so what I want to do now, I want to clear this. So we're going to look at the service YAML. Pretty simple. You, same API version, you declare what kind of manifest this is because that's used for the API server itself to determine what to do. So the kind is a service, give us some metadata, my Nginx service. Once I show you the services, you'll be able to see that my Nginx is the name. I'm going to use a node port for this since I don't have the capabilities to bring up a load balancer, so we'll use the node port. And then the selector, the app Nginx. So you remember in that pod, use the label app Nginx. So that's how it knows which pod to select. Then we just essentially expose ports on that. So exposing port 443, the target port is port 80. All right, so, okay, let's not do that. All right, so I am going to start up this service, apply-f, demo2, boom, service is created. That's how quick it is. So I'll do a kubectl get service. Okay, so you can see the my Nginx service is using a node port. It gives it a cluster IP, but we're not going to use that to actually access it. And it's using port 443, but the port that we'll use to access it is actually 3183. So what I'm going to do is let me make sure. Just want to make sure that this. So 99.100, okay, cool. Clear that. So I am going to do just another curl, but I'm going to do it to the node port on port, what was, oh shucks, let me get that port back. 3183, okay, so. Curl. 100 on port 3183. There you go. So that is essentially the service fronting that pod. And you can tell by you look at it, the services uses this concept of endpoints. And that is essentially what keeps track of the pods that come and go, because pods will die and they will come back up. And each time it does that, it assigns it an IP. And so the service itself needs a way to be able to keep track of those IPs. And the endpoint, the Kubernetes object called an endpoint, is actually how it does it. Need to put a get in here. Is it endpoints? Boom. And so you can see that my Nginx service, the endpoint is that you can see for that specific service, the endpoint is actually the IP address of that pod that we spun up, that 172.17.0.2. And if we were to spin up additional pods, which we'll do with the deployment, we'll go back to that and you'll see those additional pods in there as well. So the IPs of those. Cool, so back to here, get back to the, all right. So the demo gods were once again kind to me. All right, so we're going to move on to a replica set. Replica sets are actually the underpinnings of a deployment, daemon sets, and we'll talk about those here in a second. But with replica sets, it fulfills the purpose of creating and deleting pods as needed. Whenever a pod is, whenever you do a deployment, if, for instance, one of those pods dies and the deployment calls for 5 pods, the replica set is actually the underpinning that is actually saying, okay, there's 4 pods, you declared 5, I'm going to spin up another pod. And we'll see that here in a second. But I just wanted to talk about replica sets. You actually rarely ever interact with the replica set. But I just wanted you to understand the underpinnings of the deployments and the daemon sets is actually replica sets. So daemon sets ensures that all or some of the our nodes are runs a copy of a specific pod. So as nodes are added to the cluster, the pods then are replicated or added to those. As nodes are removed from the cluster, then those pods are essentially garbage collected. And so the usage of a daemon set is if you need to run a particular pod on each one of the nodes in your cluster. So for instance, if there's some type of log collection daemon or something like that that you need to run those on every node. If, for instance, if you want to get logs from that specific node and you want it to get moved to a centralized logging server, you need to make sure that a log collection pod is running on each one of those nodes. You will use a daemon set in order to deploy that. Same thing for like monitoring or something like that. You need a monitoring pod on each one of the nodes. A daemon set is your answer for that. So a deployment is another Kubernetes API object, and it utilizes replica sets. It creates pods in the background. So it enables you to easily move from one version of code to the next version. So it does application rollouts. Deployments are managed by the deployment controller. It builds, like I said before, builds off of replica sets, and its main purpose is for updates, rollouts, and rollbacks. And it also helps with scaling. So you declare how many specific pods or whatever you want, and it maintains that number based on what you declare. And we'll have a kind of solidify that. So you kind of have like, the replica set, which is the underpinning, running, kind of like this control loop, right? They call it a reconciliation loop. And so for a daemon set, as you can see on the left, you need Papa Smurf to run on every single one of those nodes, right? So a daemon set is used for that, for that specific purpose. A deployment, however, is just used to kind of run a certain number of pods within that cluster period. So you might not necessarily have all of them running on each one of the nodes. You might have 2 Papa Smurfs running on node 1 and then 1 Papa Smurf running on node 2. And that's defined in the Kubernetes manifest. So this reconciliation loop that the replica sets is in control of takes your declared desired state and your observed current state, and it takes action based on what's going on. So if a pod was to die, it would look at the declared state and say, hey, what's the state of this supposed to be? Oh, you're supposed to have 3 pods? Okay, I'll spin another one up. Woo, all right. How are we doing on time? Okay, cool. So we're going to do a demo of deployments. Okay, I get my notes up here real quick. All right. Do an LS. Okay, so 3. All right, so this is what the manifest looks like for a deployment. All right, so name the deployment, Nginx deployment. I want 3 replicas, right? My rolling update strategy is to be able to have 2 spin up at a time. And then the selector, the match labels app Nginx. But for my template, I want each one of the pods themselves to have a label of app Nginx. And then my spec for my containers, once again, Nginx 1.16. The port I want to expose is port 80. Simple, pretty straightforward. So kubectl apply -f demo 3. Boom. My deployment is created, so I'll look at the deployment itself. All right, so you can see the name of the deployment, Nginx deployment. 3 of 3, which is what we specified. And then get pods. You can see all 3 pods are running, Nginx deployment, and then it gives it some arbitrary numbers there. Yeah, so that's deployments. Pretty easy, pretty simple. You just scaled your service up 3 additional pods, right? Cool. All right. So let's talk a little bit about ingress. Ingress is used to expose HTTP and HTTP routes from outside the cluster to services within the cluster. So, you know, we're going up a layer in abstraction, right? So we had our services, which abstracted our pods, and now we have an ingress, which abstracts the services, right? And we do that so that we can write different types of rules. So anyone who's worked with Nginx, it's kind of like a proxy. That's essentially what this ingress controller is doing. It's routing based on, you know, application layer. So, you know, the headers and things like that is what it's going to route using. So ingress can be configured to give services externally reachable URLs, load balance traffic, terminate SSL, TLS, and offers name-based virtual hosting, right? I'm not going to do anything with do a demo with the ingress. That's just to kind of show you kind of, you know, what's possible using the ingress. And the ingress itself is actually made up of 3 different things. You have the ingress object, you have the ingress rules, and the rules is what you use to kind of describe what you want to happen to the traffic. And I'll show you a snippet of code here in a second. And then you actually have the controller itself, and that's the actual proxy that kind of does all the business, right? So kind of how that looks is like this. The API version is obviously different, but then you specify your kind, which is an ingress. That the annotation is telling it to use the Nginx ingress. Rewrite target, and so then you give it your specs, which is your rules, and in this instance, you say anything coming into test path, then let the service test handle that, right? So you can write all types of, you know, complex rules or rules to move traffic to different services that are fronting different pods. So that's essentially what the ingress is used for. How much time do we have? All right. What time is, we have till 1:50 or?
Yeah, we'll try to shut it down at 1:50.
Okay. All right, so I'm not gonna do maybe I'll do a demo. Okay, so config maps are a way to separate the actual code from the configuration of that code, right? So it makes it easy for you to be able to kind of run it makes your code easier to be able to move from node to node, and you don't have to have that configuration embedded right in your code. So the example I like to give, for instance, if you're running your pod, for instance, on your laptop, and maybe you have a backend database that's running on your local laptop, your config maps can actually be used to kind of separate, say for instance, the database target from your code. So you use Kubernetes to spin up this config map, and you can either have it spin up a config map for your local database, or if you're moving it or you're doing it in the cloud or something like that, that database will be inside the cloud. So obviously you want your database connection string, it might be totally different. And so you can use these config maps to kind of separate that stuff out from your code. And then your pod can consume these config maps in a number of different ways. Command line arguments can be the entry point to a container. Environment variables, which is the demo that I'll show you. It can actually be used as a volume, a read-only volume for the application to read. And so if you configure your application to read from a specific volume and read configuration from that volume, you can use it in that manner. and you can write code to run inside the pod that uses the Kubernetes API. And then secrets are essentially the same thing, but it's for secrets. I don't recommend, I mean, it utilizes, it's used in the same type of way as a file in the volume or environment variable. I don't recommend using Kubernetes secrets. It's better to use something that, something like Vault, HashiCorp Vault, or Azure Key Vault Flex Volume, because the secrets are actually stored in plain text in etcd. And from a security standpoint, anyone who has access to the Kubernetes API can essentially grab those secrets from etcd. And also, if you're storing this in, you're in manifests too, anyone who can read those manifests can essentially read those secrets, which is, I don't know kind of why they did that, but yeah, so do a real quick demo, hopefully. Oh. Yeah, I got a few minutes. This is the last demo, so I smurf to you, demo gods. All right, let's see. So there is the config map. Okay, so I want to take a look at the config map itself. All right, so essentially what I'm doing here is I'm just declaring some data in the config map. So kind fit config map, giving it some metadata, and then I'm saying, the data that I want is just key value pairs. Color, purple, hair, fairly nice, text mode, true. Pretty simple. So I will go ahead and create that. Core fig map. All right, that's created. Now, I want to utilize that, so I'd have to spin up a pod that is going to utilize it. So I will show you that core dash config map. All right, so a lot of this stuff is you've already seen from a pod, but here's where it gets interesting is around here. I'm declaring an environment variable. I'm giving that environment variable the name of example key. I'm referencing the key map, the config map that I created, and I want the value of that key value pair of color. So what we should see once we echo this environment variable is we should see purple, the value, right? So, oops. All right, so ctl apply-f core fig map. All right, so cube ctl get pods, cube ctl get pods. All right, so I have my, so I'm going to ctl exec, come on, fingers, T, core fig map, and bash. Oh, what does it say? Oh, okay, so it doesn't have bash on that. So I actually have to do just a shell. Boom, okay, cool. So now we'll do an echo of that. What the heck do we call that? Sample key? Is that what we called it? No, shit. Oh, I spelled that wrong. There you go. Demo's complete. All right, how much time? All right, one minute. So, all right. So then, real quick, how do we interact with Kubernetes? I've already said. Can anybody guess what that is? Cube cuddle? I thought that was funny. Ice cube cuddling, come on, man. So, various ways of interacting with Kubernetes. kubectl is the client side that interacts with Kubernetes API. It uses this kind of nomenclature, so kubectl, the verb, the object type, the object, and you see me use kubedescribe, kubectl get, and then delete will delete whatever object that you created. Create will create the object, and then apply will actually, so if you've already created something, you just apply if you made a change or something like that, and it'll create that change. All right. And last but not least, here's some resources. Kubernetes docs are very good, very solid. Minikube is what I used in this demo. It spins up a one node cluster, Kubernetes cluster for you to play around with. Of course, don't use it in production. Kubernetes Up and Running is a really good book. I think they have a new version out for that. If you want to use Kubernetes with multiple nodes in a cluster, labs.playwithk8s.com is a really good one. It's an online way to mess around with Kubernetes. And then the Kubernetes cheat sheet is pretty good. And that's it. That's my talk. Thank you. Sorry I didn't have time for questions. I do have time? Okay. Sorry I don't have time for questions. No, I'm just kidding. Anybody have any questions? No? One? Okay.
I have two.
Yes.
I'll do one overview and one pretty technical. What's your experience in using the cloud providers in Kubernetes, GCP, AWS, or Azure come to mind?
Right.
I was wondering just your random thoughts on their implementation of Kubernetes.
I've always had a positive. I've used AKS for Azure, and a really positive experience. I mean, it takes away a lot of the hard work that you have to do in order to set up a Kubernetes cluster. The management plane is essentially operated by the cloud platform itself. And so that takes away a lot of the complexity that you have to deal with. And essentially, you kind of just, you utilize their service. They take care of the scaling and things like that. So yeah, I've had a positive experience.
Okay, I had another one.
Yeah.
So technically, I was following your second demo.
Okay.
And you
Service
had
one?
node port, and you had a cluster IP and a port 443. Could you have curled that cluster IP with 443? And if not, why? And if so, why wouldn't you have done that?
So I'm trying to think. Where was that one?
Demo two,
so
node port.
The node port one. I think I tried to use 443 because when you use a node port, it assigns an arbitrary port to utilize on that node, and so in that instance, it assigned that 30 whatever to use, and that's the one that you essentially kind of have to use. Okay. So I didn't actually try 443. Or maybe I did and it didn't work. Can't remember.
You didn't during the demo. I was starting to wonder.
Say that again?
I'm sorry. You didn't during the demo. I was
Right.
why.
I'm pretty sure when I ran through the demo before, I might have tried to use that and it didn't work. I was like, oh, okay, it assigns this and you kind of have to use that port. So.
Okay. Thank you.
Oh, no problem. Anyone else? Excellent. Oh, got one more.
Just a quick question about the scaling that you keep referencing.
Yes.
So when you've created your deployment and you say, I only want 3 pods with this particular service running.
Right.
And you've given them a set determined amount of compute resources. Is the scaling that's taken care of by these cloud providers that just creates another node? And then,
so,
I'm just trying to understand that relationship of the scaling
versus
the services.
Right, and from that aspect, if you start running up against like resource constraints, and I think Azure used something called scale sets, And you can say, oh, if it's running up against a certain amount. I guess what I was saying with that is you don't have to go out yourself and build another node. Azure will take care of that for you. You specify that within the scale set, and you can say, okay, I'm reaching a certain number of this resource constraint. I'm going to increase my scale sets, and Azure will then. But from the pod standpoint, the pods themselves, you have to specify in your manifest, in the deployment manifest. They don't do what's called horizontal scaling in that manner. You manually have to specify that. But there is something called horizontal pod auto scaling that you can integrate with Kubernetes, and it'll take care of that auto scaling from a pod standpoint itself. So you give it like whatever resources that you want it to act on, and then it'll scale out those pods across the nodes. The nodes themselves would then have to be scaled out if you reach a certain resource constraint there. And I think with Azure, you normally use scale sets in order to scale those out. Anyone else? Excellent. Thank you. Appreciate it.
Thank you, Greg. Appreciate it. If you ordered a T-shirt with your conference pass, go pick it up before 3 o'clock. And our next talk is on in about 4 minutes. All right, quick reminder, the raffle closes at 7, so if you haven't got your raffle tickets bought and the t-shirts as previously discussed, go get your t-shirt if you've got one. I'm going to introduce Adam Waniger, who is Vice President of Identity and Access Management at Chase.
JP Morgan Chase. Thanks, everyone. Let's see if I can get this to work. How's it going today? Everyone having a good conference? Anyone come to Columbus for the first time for this conference? Never been here before? What'd you think of it? It's good. It's an exciting city sometimes, except if you don't follow Ohio State football, and then you're kind of confused during the fall when traffic just comes to a complete stop in the entire city on Saturdays. So a little bit about myself. I was in an application support role after college. I became fascinated with how that application worked. I taught myself to code with some online resources, mainly the Odin project. That's an online open source coding platform. Throughout my career, I've worked at Nationwide Insurance as a test automation developer. Worked at JP Morgan Chase as a software engineer and eventually a lead software engineer, and currently work in product management, again at JP Morgan Chase. I should point out that any and all views expressed in this presentation are my own personal views and not necessarily the views of my employer, now that that legalese is out of the way. My career has positioned me really well to understand what users expect in a good experience and how to make those user experiences scalable and maintainable from a technical perspective. And on a more personal note, I'm a cat lover. So, thank you. So on the left-hand side there is George Costanza, and on the right-hand side is Colonel Cat. And cats are my partner and I's hobby, but my cats have hobbies of their own. So George loves to chase butterflies in our yard, and he also loves to sit in the middle of our sink and drink water. In fact, if we don't give him water from the sink every morning, he will get very angry. Colonel likes to find new and innovative ways to make my partner and I, to wake my partner and I up in the morning. These can include, but are not limited to, a paw to the nose, paw to the chin, paw to the forehead, or getting right underneath the middle of the bed frame where no one can reach her and screaming at the top of her lungs. So what's this talk about besides cats? So it's about product management and how your skills as an engineer can make you an amazing product person, and why you should consider product management as the next step in your career. Since all of you have chosen to attend this talk, you're probably at a point in your career where you're considering where you want to take that career long term. Show of hands, how many of you have had friends or colleagues that moved on from doing everyday development to technical architecture or people management? Pretty common career path, right? In fact, most developers I've spoken to think they have only those two choices, continuing to become a more experienced developer and eventually an architect or principal engineer, or management and managing developers and sort of giving up that ability to write code. Product management gives you a mix of both because you own the design of your product and you get to lead a team of developers on implementing that design. But what is product management? So, according to Wikipedia, product management is an organizational function within a company dealing with new product development, business justification, planning, verification, forecasting, pricing, product launch, and marketing of a product or products at all stages of the product lifecycle. That's a lot. What's the TLDR on that? 'Cause that's a lot. It just means that within product-driven companies, the product team identifies business problems and technical solutions to those problems. That's it. For example, Uber saw that traditional ride-hailing methods offered a user experience that left something to be desired. They used technology to solve that user experience problem, and people are willing to pay Uber in order to use that product because it's that much better of a user experience. Now, show of hands, how many of you are familiar with Agile and have maybe heard of the role of an Agile product owner? That's good. That's a good amount. So it's important to call out that Scrum doesn't have an explicit role called product manager, but they do have a role called product owner. These titles are typically used interchangeably, but the roles and responsibilities of each is very different. So let's discuss the two. So a product owner has a few important responsibilities under Scrum. Those include running refinement, the ceremony where the dev team points cards. And this is a critical Agile ceremony. It is the handoff when the dev team reviews the product's asks, points them, and then by the act of pointing those cards, that is the agreement of the contract between development and product that says development is ready to accept the work. If the dev team doesn't have enough information to estimate effort, it's on the product team to get them that missing information, or else work grinds to a halt. So show of hands, has anyone here ever been in a situation where they were working on a card or building something that just had incomplete and missing requirements? Right? It stinks, right? You get blocked and you either can't finish or you build something that you'll likely have to rework later. So let's talk about the other roles of a product owner. So the product owner maintains the roadmap, backlog, and the product vision. That sounds like a lot. So wait, what's a product vision? The product owner decides what purpose the product will serve based on what problems it solves. This becomes the product vision. For example, Uber's product vision is transportation as reliable as running water everywhere for everyone. The theoretical product manager for Uber would keep that vision in mind when planning new features and choosing the order in which they'll be delivered. This queue of future work is the product roadmap. Features that help further the product vision the most would be built sooner than features that further the vision less. But all features should further the product vision. If a feature doesn't further the product vision, it shouldn't be included in the roadmap and probably shouldn't be built. So let's talk about that roadmap. To put it simply, the roadmap is the plan of what features and functionality are we going to build into our product so that they can best fulfill that product vision. A roadmap is typically filled with a wish list of features. They're not really well defined yet and not ready to be taken into the sprint or worked on by an engineer. These items typically get refined over the course of several months by the product manager and the stakeholders requesting the work. So let's talk about the backlog. The backlog is just a queue of work that needs to be built. Items in the backlog exist in two states, refined and unrefined. Refined items are ready to be worked and have been accepted and estimated by the delivery team. They can be taken into a sprint at any time. Unrefined items are waiting to be reviewed and estimated by the team and can't be taken into a sprint until that happens. So that's what a product owner does under Scrum, but what's a product manager? So according to Wikipedia, they perform market and competition analysis, initiate product and product-specific service improvements, requirement profiles, specifications, for new products and product-specific services, participate in the creation of in the creation of specifications, create and implement the market launch concepts. The product manager is responsible both for the development of the product strategy and for the planning, implementation, and coordination of the measures derived from it and for the permanent and final control. They are responsible for managing products across departments. So that's a terrible and confusing explanation. What's the TLDR on that? So the product manager is ultimately responsible for ensuring that their product solves customer problems, or maybe even just a single problem. They're essentially the CEO of their product. Remember what a product owner does? Well, a product manager is responsible for filling the agile role of product owner, but also has a broader range of responsibilities. The responsibilities of a product owner are a subset of responsibilities of the product manager. And it's important to call out that while a product manager is ultimately responsible for fulfilling the role of product owner for their respective teams, they don't have to fill this role themselves. Some product managers choose to delegate that role so they can focus on big picture items and longer term strategy. This organizational structure of multiple product owners reporting to a product manager is typically common in larger companies where a product manager manages multiple products and dev teams for those products. So what does it mean to be the CEO of a product? So first and foremost, you own the budget. You set the objectives and key results, commonly called OKRs, and you're the public face of your product. So what's an OKR, for those that haven't heard of it in the room? Well, they're how you measure success. So for example, a few quantitative OKRs for Uber could be grow the user base this year by 10% worldwide, and retain at least 90% of the existing user base throughout the year, while maintaining a 4.5 or greater rating on the Google Play Store and Apple Store. What does it mean to be the public face of your product? So you're the expert of your product. The business can come to you for any and all questions if necessary. Not only can stakeholders come to you with questions about your product, they should come to you. You own all communications about your product, even if you don't manage those communications personally. For example, lots of products employ someone to send out customer communications and write customer-facing documentation. It's typically not all done by the product manager alone, but it could be on small products. This does not mean you just answer customer questions all day. It just means you're the person ultimately responsible for getting customers correct answers. It also means that you're responsible for representing your product to the world. This can mean doing public interviews or conference talks to discuss your product when it launches, or to discuss new features of your product when they launch. For example, Google product managers often publish blog posts or make announcements on tech news sites to discuss new features for their products. And sometimes these announcements are delegated to a community manager. But what's a product-driven company? So a product-driven company is one where success of the business is explicitly linked to the success of the product. Typical business functions like finance, HR, and recruiting all exist to forward that product vision. Remember the OKRs we just talked about? Those company-wide OKRs are typically set by leadership, and the product teams typically translate them into product-specific OKRs. For example, a food delivery app may set up an OKR across the company that says something along the lines of, we want to increase revenue by 10%. The product team that manages the food delivery application would then decide how they could enhance the product to meet that OKR and define OKRs as a result. If the product team knows that adding certain features will attract additional users, it would set an OKR to roll out those features well before end of year. This OKR would then influence the priority of items in the product team's backlog, and other lower priority items would get pushed out. Well, if that's a product-driven company, what's everything else? So some common alternatives to a product-driven company that I'm going to talk about are sales-driven and market-driven. So sales-driven companies that deal in software products typically let their sales drive feature development and bug fixes. For example, a company has created a popular content management system for small bed and breakfast rentals in Canada. The vision of the product was simply to be the best CMS for rustic Canadian getaways. The sales department needs to bring in sales revenue, and so they want to expand to larger hotel chains in Mexico. They speak to several large Mexican hotel chains who will only use the software if the company makes many functionality changes to support large hotels. The app development team then gets pressured to build those changes, even though they are completely unaligned with the product vision. So a market-driven company. So market-driven companies build features or enhancements based on market trends in order to sell the software to a target market. For example, a company that produces a popular ride-hailing product sees that a competitor is adding a different line of service, allowing users to tell their driver the temperature preferences before they're picked up. The company is worried about losing market share to their competitor, so they rush to implement this new feature, not knowing if any of their current or existing stakeholders even want it or even will use it. It's important to call out that these choices are not mutually exclusive. Most companies are a mix of all three. For example, a product-driven company could certainly evaluate the new features being released into competitors' products. And if those features are in line with that product vision and meet a customer need, they'd probably implement similar functionality. But which companies are product-driven? A lot of them. Let's talk about everyone's favorite example. So normally when you hear about product-driven companies on the internet, or if you Google it, the top result is going to be Apple. So notable products include the iPhone, Apple Card, Apple Pay, MacBook, Mac OS, to name a few. And it's important to call out that not all of those are physical products. The iPhone's a physical product. The Apple Card's a physical product. Apple Pay's not. It's a service. Maybe a capability. Like, they still have product owners too. So for Google, they have some notable products such as Search, Maps, and you could say the entire Android operating system. Uber, notable product is the Uber app. It's also important to say that not all companies have multiple products. A lot of startups only have one. It's also important to say that even if a company looks like it has a single product from an end user perspective, there may be multiple products working behind the scenes to create that main product and a seamless user experience across those products. You may ask yourself, what do I bring to the table as an engineer? So as an engineer, you understand technological hurdles. You've probably seen software rollouts that have failed. You can identify technology solutions that can solve multiple problems at once. You understand pressures that engineers are under, and you know what they need to succeed. So how many of you have seen projects or initiatives fail in your workplace due to a lack of technical understanding? Show of hands. I'm glad people raised their hands. I was terrified no one was going to raise their hands for that one. So, as a product manager, you're a core part of deciding what gets built and can help prevent these failures. And what good is the ability to identify technology solutions that solve multiple problems at once? So for example, programmatic users of your application need to know when a certain batch job has been completed each day. Your application also needs to know every time someone updates a record in another upstream application. As engineers, we can see that both of these issues can be solved by a messaging bus that both your downstream users and upstream users can take advantage of. What does it mean to know what engineers need to succeed? You know the level of technical detail an engineer should need to build a specific feature. You can bring items to the engineering team confidently during refinement, and the dev team will be able to estimate them confidently and correctly. This will allow your team to deliver work at a very predictable pace, which will help you properly predict when items in your roadmap can be delivered for your stakeholders. This keeps your engineering team happy, because they have the requirements they need, and it keeps your customers happy, because they get all the functionality they need. So how has my specific engineering background helped me in product management? So as an ETL developer for Nationwide Insurance, I learned a lot about cross-application ETL flows. And I learned a lot about how failures in those flows can affect data quality and cause outages. Since most applications rely on some kind of ETL functionality, whether it's database-driven or API-driven, the ability to understand how data flows across an ecosystem has been incredibly helpful in debugging production issues. And as a full-stack developer, I've worked with a lot of client-side frameworks like React and Ember. These frameworks make complex client-side validations easy and scalable. And knowing how client-side validations can be used to create a better user experience for customers has helped my team build forms that can make our user experience enjoyable and frustration-free. As a developer, I've built many features that span multiple applications. Knowing these integration points allows me to direct the efforts of my QA persons efficiently when implementing large ecosystem-wide features. So what are those typical career paths for an engineer? So there's really three things I want to talk about. There's being a people manager, there's being a senior or lead engineer, or there's architecture. So let's talk about people management. So some engineers eventually reach a point where they don't want to write code full-time. These people often move into engineering managerial roles, managing other engineers. I've managed engineers before, and I can say it was very rewarding. Successfully managing a team and helping them solve problems while growing their career is a great feeling. But what's rewarding about being a people manager? Well, seeing the team grow, seeing the team accomplish challenging tasks, and seeing the team improve over time. And as a product manager, you'll still get to help the team achieve all of the above. So let's talk about being a lead engineer. So as a lead engineer, you're expected to drive development from the engineering side when it comes to new features. You'll most likely be responsible for mentoring junior developers and ensuring the team has a well-rounded technical skill set. You may also be responsible for implementing more complex and potentially more impactful features. But what's rewarding about being a lead engineer? You get to solve complex problems, you get to mentor and grow your team. As a product manager, you'll solve complex problems for your customers as the core part of your job. You're ultimately responsible in making sure the solution meets the customer's need, even though the delivery team is designing that technical solution. It's also really worth pointing out that as a product manager, you'll not get any opportunities to code hands-on. But if you wanted to keep hands-on coding for the rest of your careers, you probably wouldn't have chosen to attend this talk. So, how about architecture? Not all companies have a dedicated architecture role. A lot of smaller companies simply have their lead engineers act as architects in a limited capacity. But of those companies that do have a dedicated architectural role, you'll find that role doesn't typically get to write any hands-on code and doesn't typically involve leading a team. But what's rewarding about being an architect? You get to solve complex problems by influencing others. As a product manager, you own your app. Just because the dev team is writing the code does not mean that you don't own that code. You own every piece of the code that composes your application, and you're responsible for ensuring that it functions in a way that meets the needs of your users. You as a product manager have the right to challenge any technical design proposed by your engineering team. And having a technical background will allow you to truly understand those designs. Why you should consider product management as a career path. So you get to see the larger picture and have a hand in shaping it. And you get to create. It's a really creative process. Creativity is a central part of product management, since product is responsible for designing new products and enhancements. Coding is a really creative process, and product management takes the process a step further by allowing you to design entire experiences from start to finish. You don't get to engage in this creative process for just your application, though. You get to see the overall design and development process happen across your whole organization and truly get a sense of how your product impacts your customers' lives. And with that, I'll open up the floor to questions. I see we got a lot of time left. Please feel free to ask about anything.
So can you tell us about like kind of what your journey was to be from a software engineer to product manager, kind of, you know, things that you did along the way to kind of get you to that level, and kind of how you got into that role?
Sure. So as a lead engineer, we were not in a product environment. So we didn't have a product manager. We hadn't gone through a product transformation. So we were just an engineering team working in a roughly agile, really waterfall-ish style. And we needed the lead engineers to essentially step up and manage the teams. That's when I became a people manager and also essentially started talking to customers to refine those original requirements and take ownership of everything the team built. So we fractured into what we called work streams. So each team, there were two, owned specific chunks of the app, specific features that we would all build, and we'd split new features up as we wanted. But I became responsible for all those different work streams and for designing it from start to finish, from the user experience to the technical implementation, from writing the original requirements, from signing off with the customers, from defining the definition of done. That really triggered me to think, I like this. This would be a great career path. What's this called? It turns out it's product management.
So did that involve like any additional training for you? Did you, because then at that point you're taking on a little bit of the I guess, did you run Agile before that, or?
I did. Okay,
so once you became the product manager and you start taking kind of control of these different teams, was there did you have to implement anything new from an Agile standpoint in order to, or kind of just how did you get nominated for the position, or how did that all transpire?
Oh, so that happened essentially through attrition. So we lost some senior engineers, and we needed people to fill in. So general evolution of a team, I suppose.
Okay.
But
so no additional like training needed outside of that for you to become kind of step into that role, or?
If you've never been in an Agile role, which I had been in before, so I didn't need any Agile training, but I'd highly recommend some if you've never been in that role. I've led a couple teams through Agile transformations, and I can say that it's tough if they've never done it before, but once they really get in the groove, they've all really enjoyed it, if done properly.
When you've been in the lead role, have you actually created acceptance criteria for the project?
Yep, absolutely. Okay. And I've done that for for individual stories on like the small individual feature level, and as a product owner and manager, I've done that for entire new applications.
When I was working a project, and we discussed what we wanted, and the product owner would start saying what he wanted. An hour later, he was still talking what he wanted, but he never gave us acceptance criteria. So we created what we thought he wanted, and he didn't like it, and then our manager yelled at us and came in the meetings that we needed to create what the product owner wanted, and we brought up the point, he never gave us an acceptance criteria, and then she hit us back again. Well, he is not the problem. You guys are the problem. Well, he never told us what solution he wanted, so it's kind of hard to create a solution if you're going to get told what the solution is.
And that's the goal of the Agile ceremony known as refinement. So every time I take cards to my team, or have had cards taken to me as an engineer, the acceptance criteria is key. So that's where the delivery team looks at the card, reviews that acceptance criteria, and says either, this is completely bogus, we can't build this, like this doesn't make any sense, or yeah, we can build that if you give us more details, or yeah, that's fine.
Kind of based off the last couple of questions ago, your journey to becoming a product manager from an engineer, I think the skill sets are drastically different from engineer to product manager, and I wanted you to comment a little bit on like soft skills and skills that you think are unique to enable a product manager to be successful, which are drastically different than, say, a lead engineer.
Absolutely. So I'll say that the key, I don't know if it's technically a soft skill, it's probably a technical skill, but the key soft skill is communication. So, and that's when I hire engineers, I look for that in engineers as well. Not just technical ability, but the ability to share their technical knowledge with their technical peers is key. As a product owner with a technical background, if you have the ability to explain technical solutions and technical problems to your non-technical peers, that's amazing. Like that is very, very, very helpful. That's what I would call that the most beneficial skill you get coming from a technical background into a traditionally non-technical role as a product owner. Did that answer your question?
Yes.
Okay.
I had a couple others too. As your role of product manager, do you find yourself, little follow-up to the last question. Sure. As a product manager, do you find yourself in a lot more meetings than you were as an engineer? And do you find yourself kind of herding and babysitting a lot more?
So overall, yes. But I'll pick that apart a little bit. So as a lead engineer, I spent maybe 50% of my day in meetings. And my lead engineers now, not due to me, spend just about as much time, if not more, in meetings. So they as lead engineers mostly spend their time writing or mentoring others to write good code and not necessarily writing it themselves. So I'd say it's kind of a wash meeting-wise, but yes.
Okay. And last one. Our company does the Agile methodology. I was wondering if you could just elaborate on an OKR that you're currently working on and your progress towards achieving that OKR.
I don't know what I'm allowed to say.
Yeah.
I don't think I can. I don't think I'm allowed. I'm sorry.
Okay. Thank you.
Anyone else? Well, thanks for attending the talk. I appreciate it. If you think of any other questions, here's my contact info. Feel free to hit me up after this.
Thank you very much, everybody. Just wanted to give a last announcement. If you had ordered a T-shirt with your registration, that also goes for speakers who are entitled to a T-shirt. Please pick it up at the registration desk. Any that are left over at 3 p.m. we're going to put on sale. So if you didn't order a T-shirt, that's your opportunity to get one. We also have the raffle open. Please go ahead and you'll find QR codes scattered around to get the URL to that. So we'd appreciate all that support. Thank you very much. All right, welcome back, everybody. We are continuing now with Don Vosberg, and it's really a delight to welcome him back to our stage. It was interesting. I was just talking with him about his shirt. The shirt that he's wearing is from OLF 2006. So he has appeared on our stage many times, and it's really wonderful to have him returning. We are, he is the product manager for SUSE Manager, which sounds a little bit redundant, but he's going to explain what that means exactly.
Nobody wants a single point of failure, right? Redundancy is not bad.
And we're going to learn a lot about SUSE Manager and the technology behind it called Uyuni.
Thank you.
So please take it away. Oh, and let me quickly remind everybody, if you're asking questions here, please come up to the microphone so the folks on the stream can hear you. Folks who are in the stream, please post your questions on the main stage channel in Slack, and we will read them out and relay them along for you. So without further ado, Don Vosberg.
Thank you. So, hi everybody. My name is Don Vosberg. I'm on weekends. I'm Don at vosbergs.org, an update enthusiast. I was just reminded by a longtime friend of mine today that I am in fact addicted to updating. So that is a good reason to be a systems management product manager, which is what I do during the day for SUSE. I've been at SUSE since 2003. And and now I'm, as of September, product manager for our systems management portfolio. And behind it is Uyuni, and that's what we're going to be talking about today. So what is Uyuni? Uyuni is a scalable systems management solution focused on Linux systems. We don't really care where they are. And in fact, we have more than 16 Linux distributions that are a part of what we support. And it's most of what large organizations are running. You'll see some of the lists of those later on. But you can deploy them with tools like Kickstart and AutoYast, or with operating system image building like with Kiwi. And you can put them wherever they are, and you can manage them from wherever your Uyuni server happens to be. You can do both hardware and software inventories of the client systems. You get configuration management built into the system. So if you don't already have Ansible or Salt or Chef, Puppet, those kinds of things, SUSE Manager and Uyuni are Salt masters. So it already comes with the infrastructure for you to run advanced configuration management, declarative salt states built into the box, and very granular control over content delivery. So for example, if you have test, dev, production systems, you can align RPM content or binary package content. If you're on the Debian side, it's Debs, and migrate that as you test through those environments without having to re-register the systems to different repository or package sources. So there's a lot involved in Uyuni, but it's always good to know where things came from. So today, actually, I was inspired earlier when our keynote speaker this morning was talking about some of his history and what he had done in the past. My first IT job, I was in charge of a Quantel mini computer. Now, how many of you have actually used a Quantel mini computer, right? No one, because they don't exist anymore. But I was working for a company, and they had this system that they used for benefits administration. It was so proprietary, everything was proprietary on it. The internal pieces you had to buy from Quantel, even though the disk drives were Seagate disk drives, and if I bought the Seagate disk drive, it was $1,100. the same drive formatted to work on Quantel was 16,000. So I would try to hack these things. Back in the day, I was so frustrated with all the proprietary nature of things. I walked into my boss's office. I had learned the Quantel stuff. I looked over the shoulder of the engineers. I learned it. I did it because that was what I had to do for work. And my boss says to me, "You're the best Quantel guy there is." I said, "Oh, don't tell me that. I don't want to be pinned to this horrible proprietary technology." And a month later, they filed Chapter 11, and by 1992, it was over, right? So I think that frustration from all of that super proprietary thing has kind of propelled me into the world of open source. So it's good to know where things came from and where did Uyuni come from. Its origins lie with the Spacewalk project. Now, have any of you ever used Spacewalk? Yeah, some of you. Good, great. So Spacewalk was actually started in 2008 because Red Hat bought the company and open sourced it. So it was underneath Red Hat satellite server through version 5. And because Red Hat open sourced it, we're like, you know, we don't really have, SUSE didn't have its own systems management tool. Let's take something that's open source and we'll do the good open source thing, contribute back upstream, and sell support for it and call it SUSE Manager. So we added a few elements, scripting to talk to our customer center, and voila, out came SUSE Manager. And then promptly, well, not promptly, but sometime after that, Red Hat announced they were in fact moving to a bunch of other new open source projects that would be underneath Satellite Server 6, Foreman, Catello, Pulp, and so on. We chose not to move there, but the project Spacewalk, as you can see from the website, actually stopped in May of 2020. So we created the Uyuni project to have something where our code could reside that would be useful for us and for our customers. And we named it after Uyuni the place, which is Uyuni, Bolivia. It's the gateway to the largest salt flats in the world. If you want to see some absolutely stunning pictures, look on the internet about the Uyuni salt flats. It's a beautiful, amazing place. So that's what we named our project after. And it's actually a fork of the Spacewalk project. So fork is a four-letter word that starts with F, but it is not necessarily a bad thing when you find out the history of how this occurred. So we had been contributing to Spacewalk for quite a while, and suddenly Red Hat stopped accepting any new feature introduction, in part because they were trying to encourage their own customer base to move from Satellite 5 to Satellite 6, in part because they just could. So after 2 years of this, the distance between what we had built with SUSE Manager and what Spacewalk was widening. And when Red Hat was getting ready to stop the Spacewalk project, they put an announcement up on their webpage. We're looking for someone to take over the Spacewalk project because we moved on and we're doing other things. And we scheduled a meeting with them to talk about potentially taking over sponsorship and whatever of the Spacewalk project. And the day before that meeting occurred, the banner announcement went down off of the Spacewalk website, and those negotiations were unfavorable, I would say. That's sort of a euphemistic way to say it. It wasn't going to happen. So we actually forked the code, and we took the downstream and made it the upstream. So we took what was SUSE Manager at the time and did the rebranding thing. We pulled out the SUSE Manager names and put Uyuni in there, and we moved the code up there while creating a sort of informal project structure and a website up there for Uyuni. And all these things are things that we actually added to the code that were missing at the time of the fork. So SALT capability, which we put in there to resolve client communications and numerous other things. Scalability, which Spacewalk was woefully inadequate at scaling. Usability, some of the web UI changes that we made, we put back up into Spacewalk at the time. So under the covers of Uyuni, which has been going as a separate project since 2018, we have several important open source projects. Apache Tomcat, OpenJDK are driving a lot of it. PostgreSQL is our database of choice. So that's what's running and gets populated with all of the stuff that you see in the web UI and the API. SALT is a key component both for client communications and for configuration management. And we also use Prometheus and Grafana for the monitoring tool, which I'm going to show you a little bit of, hopefully, if we have time in the demo. So Uyuni is the upstream project now for SUSE Manager. So we have a monthly meeting at the end of every month for Uyuni for you to be able to participate in and ask questions. At the community hours, typically we'll have at least one of the engineers that's working on Uyuni present what's coming in future releases. It's the last Friday of every month at 4 p.m. CET, which is Central Europe time, which turns out to be 10 or 11 a.m. Eastern, depending on how our daylight savings align. It runs on OpenSUSE Leap. We target to have monthly releases, but it's basically a rolling release project. So by rolling release, those of you who may not be familiar with that strategy, you don't get patches for what's out there. You wait for the next one to replace the packages, essentially. So you can import distributions, and what it says here is products, but so if you want to add something like CentOS 7 or Ubuntu 18.04 LTS, you can use a command line tool to create those channels, and you'll see that in the demo, what it looks like. In the paid for version, you actually have a web UI that does those things, and that's really the only difference. We're not trying to make it a paywall product where the pay for one is massively better. In fact, Uyuni is ahead of where SUSE Manager will be code-wise. So if you're looking at Uyuni, there's some stuff that hasn't yet made it into SUSE Manager, typically. So we also have translations. So we had community translations. So we had a community person in Japan that donated his time to build the entire Japanese translation. And we worked hard at coordinating that with WebLate and trying to make it useful. So we've had significant contributions on the translation side by the community, but we'll take whatever contributions you want to make, whether that's bug submission or usage feedback, anything like that that you want to do on the community side for Uyuni, or if you want to contribute code. We have people working right now on the errata for Debian-based distributions for Ubuntu first, and then it will be on the Debian 10, Debian 11 side. So those are fun things to watch the community do that are important and good. So our goal is to have a monthly release. So unfortunately, it's December and we're still on 2021-09. but there's a release that's due next week. I was hoping to have it for today's session, but QA held it back. So even though this is an open source project, the release manager works for SUSE, and he has access to a quality assurance team that runs it through before it gets pushed out to the community. So there's a cool feature that they're wanting to put in. It didn't pass QA, so it got pushed back to this coming week. So you can upgrade from the 2021-09 release to the 2021-12 release that's coming out. That is supported, supported in terms of we expect customers to be able to do this, and we've tested it. This is still a don't call me product, right? So don't call me. And it's been the upstream for SUSE Manager since 2018. So we've been doing it this way for more than 3 years now. And we have a great release manager who he actually also runs the community meetings. So very open for participation whenever you want to add things, have comments, test, play with it. It's up to you. There is a development version called Head or Master that is not tested, that will be broken. And this is where a lot of the stuff appears ahead of the general Uyuni releases. So if you really like bleeding, this could be for you, right? So here's the basic architecture of Uyuni. So you have a server, and above that server, I didn't put the icons on this one, you might connect to a source for repository content. So that may be Ubuntu's repositories. It might be Alma Linux repositories. It might be the SUSE Content Delivery Network or Red Hat Content Delivery Network. And that comes into the Uyuni servers. Clients can be registered directly against an Uyuni server. We actually have a Terraform script called Sumaform that will build out an Uyuni server and all the clients for testing and development purposes. You can also register clients through proxies, and this is a way of growing and scaling the product. So on an individual server, the largest one that we know of right now, a company in Italy, has 17,000 clients on a single server. I would not recommend that you start that way, but it can work. And we're scaling to a very large quantity of servers by using both the proxy things that are shown here and a new feature called Uyuni Hub. And Hub is basically an Uyuni server that has other Uyuni servers joined to it. And the content flows down. The clients don't see each other. The servers don't communicate individually with each other, but it rolls back up. And we just started the RFP for doing a data mining for that kind of gigantic, huge environment where you can look at reporting and see what's going on under the covers all the way down to the client side. Lots of Uyuni features you can use. I won't read all of these. You'll get to see some of them. Things like scheduling actions to happen in a chain of things. You have some monitoring that we'll also see. You can manage systems that are located anywhere, on premises, in the cloud, on a VM on your laptop. So I have systems that are on a VM in a laptop at my house, registered to an Uyuni server in the cloud. So SALT is very good at doing NAT traversal without having to open ports back down to the client. So excellent thing that makes it super simple for you to be able to be flexible in how you deploy things. So another thing that's important that we sensed from the very beginning after adapting Spacewalk is Spacewalk already had all this really good Red Hat-ish things. So why did we want to break it? And we chose not to break it. We chose to continue with the same API threads and keep support for Red Hat-based distributions. And in fact, we've actually enhanced it to support more than just Red Hat Enterprise Linux, but all the RHEL clones that we can find. Oracle Linux, CentOS, of course, and now Almi Linux, Rocky Linux. We had Scientific Linux for a while. How many of you are running Scientific Linux? Okay, that's the reason why we don't do it no more. So there you have it. So here's some of the operating systems that we support. Obviously, the SUSE ones are important to our enterprise customers, but we also support OpenSUSE, Ubuntu, Debian, RHEL, CentOS, Oracle, Rocky, and Amazon Linux too. So it might surprise you, but Amazon Linux 2, which is, if you go to Amazon, how many of you ever built servers in Amazon, right? Some of you. The default is to build an Amazon Linux one. Well, what is it? It's a RHEL clone. It has another kernel. It's sort of like a dune buggy, where you take somebody else's chassis and you bolt on a really cool engine. So they've kind of done that with Amazon Linux, but they have their own patch metadata and errata structures. We import those natively into SUSE Manager. So all the security patches, all the bug fix patches, you get to see all the details behind it, and you'll see some of that in the demo, hopefully. If you want to get started with Uyuni, so there's really good quick start guide that's here. If you go to uyuni-project.org, you'll look at the guides and you can find it. You start with an installation of OpenSUSE Leap. The current one is 15.3. That aligns with what we have validated for libraries and everything on the Uyuni side. Coming soon to an Uyuni near you, we're starting with the proxy servers in making it containerized. So by next summer, we will have the ability for you to deploy with either a Helm chart or with Podman, a containerized version of the Uyuni proxy, so it doesn't have to run on a VM at all. It's much faster to install, much more consistent. It takes, like right now in our labs, we're doing about a 5-minute deploy for the Uyuni proxy with containers. So it's 4 separate containers that are orchestrated together, but we're getting ready to do that with the server too. But for now, if you want to build a Uyuni server, start with Leap 15.3. That can be either in your lab, on your laptop, or whatever. Make sure you have enough RAM and disk space to be able to run this thing. So 8 gig is probably the minimum RAM. And if you're going to do multiple distributions, you're going to need lots of space to store that stuff because it's going to replicate the content down. And you'll see some of that in the demo, which is now. So hopefully you guys can see this okay. Yeah, good. Awesome. Okay, so we have an Uyuni server. This one happens to be up in the cloud, and I'm going to try it. Yeah, that'll make it bigger, right? So I have several systems that are here listed in my cloud server. So I have an Amazon Linux system here. I have an Alma Linux, and I have a Rocky, and I have an Ubuntu. So I did like an M&M bag where I have all colors. So each of these now is registered to my Uyuni system. So by default, they don't have the client necessary to register them. So what we're going to do is register another Amazon Linux system. Now you'll see that all of these systems say that they are system type of salt. So they are communicating with the Uyuni server using salt. And so those salt binaries are actually supplied by Uyuni. So for all the systems that we support, We don't make you go out to SALT and pray that you can find the right one. We build a Bootstrap repository for you and a tools channel for you to be able to install the SALT client necessary to be able to talk to the Uyuni server. So there's really two ways for clients to talk. I install a SALT minion, and that SALT minion is actually running as a daemon on my client system. Or I can use SALT SSH, which doesn't scale as well, and it's a bit less immediate, but it's kind of cool in how it works. So these are all talking SALT, and we're going to add another Amazon Linux instance. So I have an Amazon Linux system running, and hopefully I can get there. So here is my, this is my Uyuni server. And I have cut and pasted too many times. So I have a system that if I can ping this system on AWS. It's called DPV Amazon Linux Test 1. So we're going to connect this system to my Uyuni server. So you have, in order to be able to SSH in, you kind of have to have SSH open and a path to get from there to here. In this instance, my Uyuni server and my client are on the same network, so I didn't have to do a lot of firewall-ish things in order to get it to work. But we're going to connect our Uyuni system up to this guy, and hopefully I have my Firefox open. Here we go. So you can onboard a system with the user interface, and this is a practical way to do it. If you only have 1 or 2 hosts, you can do it this way, where I just put in the host name, I tell it what port, and of course this is Amazon Linux too, so my user is EC2 user, and I'm going to use a private key. So I'm going to browse and select my private key from my local system here. So I've now opened my private key. I don't have any passphrase. Uyuni uses what are called activation keys. This is to help automate things. When you bring them on board, you can auto-install packages. You can assign it configuration channels. You can assign it to system groups, which are essentially tags. So I can tag it and say, okay, this is a database server. This is an infrastructure server. It's whatever you want it to be tag-wise. It could be geo, it can be function, however you use it. So I'm going to pick AL2 SSH. So this is Amazon Linux 2, and I'm going to communicate with it over SSH. I don't have a proxy in this scenario. I could add one if I had one, and then I'm going to tell this to manage the system completely via SSH and not install an agent. And when I click on the word Bootstrap, now it's actually going to try to do this, and I should get a message up here. Right now it says blue, and it's waiting for a response. So once it registers to my Uyuni system, it will come back, and this will turn green if I haven't done anything to tick off the demo gods this afternoon. So, and I'm hoping it's good because I already tried this once today and it worked. But even if it doesn't, hey, there we go, look at that. Now it's green and it says your system should appear in systems. And usually I'm famous for doing this when things go right. Woohoo! That's all right. You know you've been working on open source software for a long time when you get super excited that things just work, right? But oh well, anyway. And there's a lot that went behind that. But now when I look at my list of systems, I should see my Amazon Linux 1 guy. Here he is. He's got an hourglass because he's still running some things. So when a system gets onboarded to Uyuni. He adds some entitlement. He does some additional salt states to assign it the right software channels. And then he appears in the list. So one of the things that you can do with Uyuni is a tool called remote commands. So here in Uyuni now, I can filter this list to have a subset of different systems if I wanted, or I could do an individual system, or I can just tell it to find the targets, and it will look at all of my systems. And you saw it matching the SSH push command to these systems, so it can now talk to them. And since they're all disparate operating systems, I can't exactly do the same command on all of them, but I certainly can do a uname -a and see what kernel is running on these guys. And when I click on run command, it does not do a centralized scheduler, and each task then sequentially wait behind that like Spacewalk used to do. This does an immediate parallel remote command send out to Salt. And Salt does the execution on the clients on their own clock. And you saw how quickly things came back to my server. And I can, in fact, see the different kernels that are running. So on Rocky, it's got a 4.18 kernel. On Amazon Linux 2, it's running a 5.10, even though theoretically it's RHEL 7, right? And then my Ubuntu one, it's running a 5.4 kernel. So each of these, before I did all this, I synchronized the channel content. So I had all that software already on my Uyuni server. So when I click on software, you'll see I have all these channels selected. So I have Alma Linux 8, Amazon Linux 2. I even have OpenSUSE Leap here. The channels are defined, but I haven't synchronized any content. I have Rocky Linux 8. And you can see Rocky, actually, we have two architectures for Rocky. So if you have an ARM-based system, you can do that too. There is a whole long list of channels that are supported under Uyuni and architectures. So if you have one that is missing that you're passionate about, join the Uyuni project and encourage us to adopt more. So now I've got all of my systems here. One of the things that you can do with Uyuni is run Salt states. So Salt actually allows you, yeah, here we go. Okay, this is too small. Hang on. So this is another Uyuni server. This one is actually running in production at a school that I have worked with, and I've spoken here at Ohio Linux Fest about this a couple of times now. These two guys here in the middle have been partners in crime with me at this school numerous years. But here, this entire school is running on OpenSUSE Leap and CentOS 7. So we have 19 servers. This one is an experimental one, so it's not included in most of my controls and monitoring, but I can I've created an interesting salt state that you might wish to play with. So in configuration channels, you can create a salt state, and this one is called update everything. So it's a very simple state, and let me make this just a little bit bigger. All I'm doing is, no matter what operating system I'm running, Salt is going to do a package refresh and update everything, okay? And then I have a conditional reboot. So the conditional reboot looks at whatever OS I got and makes some decisions. So if I'm running a RHEL 8 clone, I need to use DNF to query about needs restarting. If I'm running a RHEL 7 clone like CentOS or any of the earlier ones, it actually uses that needs restarting from the command line. If I'm running Debian or Ubuntu follows in this, it creates this var run reboot required file when it's required. And on SUSE Linux ones, it uses zipper pf, and it does a query to see if zipper says it needs to be rebooted. So by doing this, I can apply the same state to my entire portfolio, regardless of what Linux operating system it's running, and it will apply all the updates and reboot. Now, I don't want to do that on my production systems, but I've created a system group called infrastructure. So if I look at my system groups in here, I created a system group, and this system group is called infrastructure. There's 8 servers in it. Some are CentOS and some are OpenSUSE. You can see they all have updates available. It's Saturday, first of all, so I don't care if I reboot these things. But second of all, these are a system group that's infrastructure. So these are not client affecting, these are like management servers. So I have backup servers in here. I have servers that run my imaging software, FOG. So I have a server that's my Uyuni proxy in the other building from where this one is. I have a server that's running Apache Guacamole for remote access. I have a couple of servers that are doing monitoring. So I can actually run this salt state that's associated with this group. So I've created, inside of this group, I've told it, use the update everything. And all I have to do now is click on execute states. It will update everything and reboot those boxes, right? So I can do that, or I can schedule a high state to occur on these systems and do that in future. So anytime you apply an individual patch or like a high state like this one, I can create a recurring. This shows me what servers it's going to apply to. And I can schedule it to happen at an earliest time. So this is not a time machine where you get to go back to yesterday and do the things that you forgot. No, it has to be in the future, so sorry. I wish I could give you an open source time machine, but not today. So we can schedule it to happen anytime in future, so I can tell it to happen at 4 o'clock after we're done with this. This is on Eastern time zone, so it says America, New York. So I can schedule this high state to occur at 4 o'clock later today. One of the things I referred to earlier and what's included in Uyuni is, how am I doing? I'm just doing about right. So is Prometheus and Grafana for monitoring. So what we do inside of Uyuni is we allow you, when I look at my list of systems, you can see they have the system type monitoring. All of them except for my test server that I don't really care about monitoring. I'm monitoring these guys with Prometheus and Grafana. So if I look at an individual server, like let's look at this one, which is a cluster node that's in a physical system in a building that I have. It creates what are called formulas. So when I click on formulas, I can choose to configure the exporters for Prometheus and Grafana. These are the ones where it collects the information from the client. How many of you are Prometheus gurus? Yeah. So yeah, some of you may have used it. So these are the exporters from the client, and it gives me a tab to be able to configure those exporters and tell it whether I'm using a Node exporter, Apache exporter, Postgres exporter to get information from that box. And when I do, it automatically sets up that system with the necessary binaries, installs and makes sure the Prometheus exporter is running, and it becomes part of a scrape that happens on my Prometheus server. So in this list, I have a Prometheus server. It's called Nausus, not nauseous, Nausus. the school uses all characters from the Chronicles of Narnia, so we're pretty far down the list right now in terms of name selection. But Nausus is in there, and on this one, I have a formula for a Grafana server too. So it's added the other pieces to this box. I've already installed Prometheus. So I can actually look at my Prometheus server here. Come on. Okay. Let's go back. Okay, so this is my targets. And you can see all of my endpoints are being picked up by my Prometheus server. Plus it's managing the Uyuni server itself. So it has a number of things that it's tracking. That's kind of okay. But what I really want to see is the graphical stuff like this. Whoa, looky there. This is my Uyuni server, and it's telling me the health of my Uyuni server. So I can see network, disk I/O, database operations, Java virtual machine health, things that correlate to Uyuni like the server actions and the Taskomatic centralized JVM scheduler and the health of all those things over time. And of course with Grafana you can drill into a specific time. If you wish, this one's on the last 12 hours. In addition, it picks up all of the client systems and scrapes those. So I can see each of these clients and what they're doing for the last amount of time. So I can look at the last 3 hours, for example, and kind of get some trending and see what's using a high CPU or what may be almost full of disk. This is all included in what we give you with Uyuni. And with that, my demo has actually worked. We'll switch back to our slides, not to that. Switch back to Keynote. And what happened here? That's music. That's not Keynote. Okay. Here we go. So what questions do you guys have? How can I help you? What would you like to know about Uyuni? Hopefully I can give you some answers, and I'd love to hear some feedback from you. Have any of you tried installing Uyuni yet? Yeah, a couple of you. Was it painful or okay? It was okay because I was there. Well, thanks, Trent. I appreciate that. No, it's really a relatively simple process. You want to make sure that you have some adequate disk space on your Uyuni server. So in this one, here's my Uyuni server. Here's what I have for disk space. Right now I have 330 gig that I allocated for the place where all the RPMs or the binaries get pulled down, and I'm using 194 gig. So please don't underestimate the size of your potential repositories, especially when you do an M&M bag full of different distributions like I did, right? I have one in my lab in Utah that I'm using 2.9 terabytes worth of downloaded content. I have every architecture and every flavor of every distribution we support. So it's somewhere between 300 gig and 3 terabytes. So, go for it. Any questions? Anything online? We okay? All set. All right. Well, join us at ouni-project.org. We'd love to have your participation, especially for we've inherited a lot of the people who used to run Spacewalk. If you have experience or you have systems management challenges that aren't being met by competitive product, we'd love to hear your input and have feedback. And thank you very much for your time today.
Thank you, Don. Reminder that you've got a couple of hours plus to buy some more raffle tickets for the items we're raffling off here. So that, and I hope you picked up your t-shirts. And next talk is in about 10-15 minutes here. All right. I'm here to introduce Robert Sachia. Is that how I say your name? You got it right. Awesome. He's a senior technical evangelist with SUSE.
All right, well, hello and welcome. My name is Robert, as you heard, and today we'll be talking about writing policies for KubeWarden. Now, go through the agenda first, kind of who I am, talk about what KubeWarden is, talk about policies, and then I'm gonna do this slightly different where I'm gonna walk you through how I wrote this policy, and then have a kind of a surprise at the end for everybody. So, who I am. This is not me. I know you see my last name and everyone thinks this, but I am not Sriracha, it's Sirchia, so thank you for pronouncing my last name. Senior Technical Evangelist at SUSE. My job is to work in the community. I get people excited about our technologies, all being open source, and I get to talk about it. And not only do I get to talk about it, I get to learn it, and then turn around and help others learn it and know it and understand it. You can follow me on Twitter at Robert Sirk if you'd like. Harass me, talk about football, technology, all of that. So what is KubeWarden? Well, KubeWarden's a policy engine, and its mission is to simplify the policy adoption of policy as code for Kubernetes, right? And it has two main focused audiences. The first one is the policy developer, and we'll be walking through what a policy developer does, and we'll talk about it in the demo at the end, what a policy operator is, right? And writing a policy for KubeWarden is actually relatively easy, and you can bring your own language, and it's what makes KubeWarden really kind of cool, right? So if you've ever used OPA, you have access of running that in KubeWarden. KubeWarden has a handful of highlights I want to talk about, and first is our open source hub for existing policies. You can download, you can run them, and these are things that we know operators struggled with in the past. We've written some, other contributors have written some of these policies for us, and they're up on our policy hub, and that's hub.kubewarden.io. You can go out there and check it out. But if you have policies that are OPA, written in Rego, you can bring those along. And why I got excited about KubeWarden is I had a use case for WebAssembly. And it's not often you get a use case that you can go, hey, I can actually write this and test it and play with some bleeding edge technologies and have it adopted and used relatively fast and easy with it. So policies. Our policies, when we're writing them, are compiled into a WebAssembly binaries, and these are small, compiled for specific tasks. We don't recommend doing multiple things in these policies. They have a job, let them do that one job and do it very well. So when we recommend you writing a policy, think about what it is. If it doesn't exist in Policy Hub, check there first, obviously. But then write it yourself, but have it do one job. Don't try to overload it. I've learned the hard way that this is a bad thing, and the KubeWarden team will remind you that it's a bad thing. They do quite frequently with me. So if we think how policies work, we have an operator or a developer with their cluster, right? And they want to do a particular operation, and KubeWarden kind of stands in there with their policies that they have running, and let's say we want to push a pod or push a deployment. It checks and makes sure that everything that you are attempting to do, and you have not only the permissions, but it makes sure that the object you're trying to create in Kubernetes is going to match what the policy states, right? And why that's important? Well, some of the policies out there and some of the demos you'll see, we'll talk about, I don't want you to name your pod something silly, right? Because you might think it's funny as a developer going like, hey, my pod's name is I see your butt. But that's not necessarily good for business, so we want to put some rules that you don't put swear words or something silly in there. But we're here to talk about writing our first policy, and we're doing it in Rust. And Rust is a unforgiving language. I looked at it a few years ago, and it was very painful, but it's come a long way since then. It's relatively easy to install, and we'll talk about that. And not only is it easy to install, it's easy to get started with. right? The community for Rust is amazing, and you can find Discord channels, you can find Rust for specific things, and what makes it kind of awesome is we've adopted it for how we're able to write policies. So we're gonna build something, and we're gonna build a policy. And this is not a real good use case policy for Kubernetes, but in development, I actually had this problem right here, where I had developers over allocating CPU resources on containers. And I thought, what's bringing this cluster down? What's grinding us to a halt? What are the developers doing beyond their developer workstations to do this? And we kind of give them free rein, it's developed, and then realizing they were over provisioning, and it was crushing everything else in there. So I figured, why can't we just write this, right? So that's what I did. So for this demo, that's kind of what we did. So we set up with setup and configuration. First is VS Code. I don't get into the war of what's the best editor out there or best IDE. I just use this because it's relatively simple. It has a high level of adoption. The Rust extensions, I don't want to say it's a must-have, but it's pretty much a must-have. I just said must-have. It's actually a must-have. It makes your life a lot easier with syntax. It makes your life a lot easier with some of the formatting. I love using it, so I always recommend it. And if you notice that I have hyperlinks in this deck, I will share this deck as a PDF when I'm done. So if anyone wants it out there in the field, I can show you where you can go get that. Installing is relatively easy. Now it's a curl command. If you don't like the curl command, they actually will go show you how to, rustlang.org will show you how to manually do it. I'm pretty lazy. I use the curl command. I know it's not best practice, but hey, on this work machine, it works. And when you install Rust, you always want to make sure that you do a Rust -V, make sure the version's up there, everything works, everything's good. I always recommend it. Just verify. But we can't really test this. We can, but we want to deploy it. So we'll talk about the deployment later, but we need an environment to do so. So we need some type of Kubernetes. And for my example, my demo, I'm going to use Rancher Desktop because, well, if you haven't seen it, it allows me to quickly spin up a local instance of Kubernetes. And if I mess up, I have a reset button that resets it back to normal and makes everyone's life easier, especially mine. So when I was building this, I can't tell you how many times I hit that reset button. You're going to need Helm because, well, that's how we deploy kubewarden. And you're going to need the KWCTL or kubewarden control. And this is a CLI that you can download from GitHub. And this helps us verify and annotate our policy after we write it. And then that's all you need to install kubewarden. Now it does need a cert manager. It's in there. Now this is right from the kubewarden documentation. This is the best way. This is how I recommend installing kubewarden, and it's done. Takes about 30 seconds to run, depending on your machine size. So cargo install, cargo generate. No time do I recommend that you go out there and natively try to write this on your own. We have a template for you to use, and to use it, you're going to need to install cargo generate. Cargo generate just allows you to run a command, go out to our GitHub, pull our template down, which has our SDK all ready to go. Did I lose it? Oh. And from there, when you create it, you're going to see two important files in there. You're going to see librs, settings.rs. And those are going to do most of our work in. So first, we want to update the settings, and we're going to put a string value out there for CPU limit, right? We want a user to be saying, I want to give you whatever CPU's allocation that your pod can create. Your pod can use upon create. So we added that to our struct that's called settings, right? And inside the SDK, we have something that allows us to verify that. We want to make sure that value's there because, well, what's the point of having the policy if that value's not there? And so inside that validate function, you can go in there and say, hey, If this is set to, if it's an empty string, throw an error. If not, I know it's okay. Now, this is a demo, right? There should be some validation. Don't I want a particular string value? Do I like what if someone puts ASDF? Is that going to work? Well, we'll get to that validation here in a minute. But as good developers that we are, or engineers, we want to make sure we have tests. And we actually stub out a handful of tests in the project when you scaffold out this project to go in there and do such a thing. And that's what we're doing here, is we're making sure that we have the values that we're seeing for settings, right? And it's always good practice to do this. So there's a test file at the bottom of settings when you see it, or test section block, excuse me. And that's where you want to update and put those tests. Now, this is not the policy test, but this is just the settings, making sure it has the values that it needs. So, the policy. We have a pod match. What the scaffolding has, it's a little bit much, so I stripped it out to what we need, right? Here's the pod, here's an error, go with that. But we want the policy to have a response. So we have a struct, or an enum, excuse me, and it's either accepting the results or rejecting it with a reason why we rejected it. And once again, we want to validate. And so we have a validate pod function that I added to this, right? And so in here, what I'm saying is, give me a pod spec. I have a function that I want to iterate through all of the containers, and I want to be able to compare it, right? And if all's well, give me an okay. But if all's not well, tell me it's rejected. Our match policy will either give us an accept or reject that matches up our enum. But then I created a function here, and I call it, pod at or under limit, right? And right now, I'm just setting this to true. If I ran it, if I deployed it, it'll return true. But we need to test it and make sure it's going to do what we need it to do. And to do that, this is the test for it, right? Now, we're using the Open API, and that gives us the ability to look at what that particular pod looks like, and we iterate through there, and we go down to what we care about. And for this example, for this demo, it's the limit. And I set that here in the test, and I'm looking for it to accept. Now, this is one of many tests. You should always have a negative, and to test the negative, I can put another value in there, and it should bomb, and I should, instead of looking for accept, I should look for rejected, right? And this is one way of testing your code as you're writing a policy, right? But there's 3 ways we're going to test it, and this is the first one. And so when you're writing your test, make sure you have a positive, a negative, and then try to squeeze in an edge case here and there. So to build the policy, we have to add a new target, and that's for WASM32. And so you have to do a rust up, target add, WASM32 -unknown -unknown. I didn't know this didn't come default, but you do. And then in the root directory of that project that you scaffold out using cargo build, you just have to do a make build. Now, I'm going to warn you that it's going to run format, and you're going to have a lot of issues. It's going to run test. You're going to have a lot of issues because, well, the Rust analyzer that you use in that VS Code extension does not catch everything, but this will. What I recommend that you do is open up that make file and look at every one of those commands and run them individually, and then fix your issues through there. It's usually a lot faster, a lot easier if you're not doing it as you're developing. But who does that as they're developing, right? Why would I care about formatting? I just care if it works. And when the make build's done, you will have a file inside of target, WASM32 unknown, release, and we call this pod sizer, right? Because this is what it is. It's a pod sizer. I want to make sure it's the right size. So we need to annotate the policy. You don't have to, but it's best practice, right? And it's just allowing to set a bunch of metadata around the policy that travels with it when you deploy it. Because one of the cool things about building a WASM policy for KubeWarden is that you can write it once, you can build it, and you can deploy it to any cluster that you want to deploy it to. Doesn't matter. It's just a little binary, right? And that's what we use the KWCTL to do. We can annotate, and in that directory, they have a template for that metadata, right? And you just set the meta path to that metadata and that output path to an annotated pod sizer. Now, I said there's multiple ways for us to test this. And KWCTL has a run, and you can test what this would look like if you were attempting to run this on a cluster, right? And that's the command that it comes with. So it's a really powerful CLI that I didn't realize how many bells and whistles like these guys packed in there, but it gives us the ability to test it. So I was not only having my unit test, but I was able to test against test data I have and set those particular limits right here and there and see what the results were going to be. And it gives you a higher level of confidence when you are deploying your test, right? Because now your unit test passed, and now I'm going to run it against a test runner in the KWCTL to test it once again to make sure we see what it looks like. Now deploying. This is where it gets kind of interesting because there's a few ways of deploying it, and inside of this we have a YAML file to deploy a cluster administration policy, right? And you can see here, it's what it looks like. But if you look at the modular, I'm setting it up to a registry. Now, that's not the only way you can do it. You can do it by file system. You have to mount the file system, and the pod has to be able to have access to it for you to deploy it. Or you can use it via HTTP, but the pod has to be able to talk out to that particular HTTP instance to do so, right? But the best practice is to use the registry, right? Because it's kind of how we wanted to do it. So for this example, I actually pushed it to GitHub so I can pull it back down from GitHub and run it and deploy it. And this puts all the settings that I want this particular policy to have. So yes, you can use file system. Yes, you can use HTTP, but it's recommended to use it through a registry because that's the best practice of having this, having KubeWarden, right? Is that you're getting everything from a registry. You know where it's coming from. It's not willy-nilly here and there. Now, in here, we have a handful of information, but in the settings, we have CPU limit, and I set that limit. It's 1.0, and I want to make sure that nothing exceeds that. Now, with the Open API, it does do a check against what the values are that someone passes in, right? So if your pod doesn't match up to what that is, that's an issue. Now, for our demo, I didn't really validate that, right? I didn't go and make sure that it was, 100M versus, 1.0 or whatever it might be. I did not do any, regular expression to validate that because it's just a demo. So you see it, you're like, well, this might bomb out. It might. But when users put the particular input, we kind of let them put their input. If they want it to bomb, then it should bomb. And then from there, you can be able to see it, right? You can apply that particular YAML, and it will create that policy for you up there. But to test it, all you really have to do is just run apply and test a pod with more than one of that CPU. Now, I'm going to stop for a moment. I'm going to switch machines because there should be a demo. Give this a moment to come up. And you should be seeing my screen. Now, this is really tiny, so I want to try to spruce it up here. And that should be big enough, right? Here is that pod sizer. Here's my code. Here is all of everything in there to use. But you're seeing the terminal, and that doesn't look good, right? So we'll walk through it. Just give you kind of an example of what this looks like. A handful of scaffolding here that we have. There's the policy response enum that I talked about. Here's our validation all in there. But I start peppering some logging, right? Because when something goes wrong, we want to make sure we can see it and it's good. So I added that. And then here's that iteration that we're going through, right? Iterate through all these containers. Make sure that every container in that pod YAML or deployment is matched up to those settings. And if everything's good, I'll give you an okay. But if one's bad, I bomb out. You're like, that's not really a good use case, but again, it's a demo, right? Some more logging, because that's always important. And then the most important part, a ton of tests. But if we go to here, I have my pod sizer, and I have a couple pods YAML files in here. If I just show you what these look like, I got one that's one CPU, and I got the other one that's two. No, it's one. I don't like that. Let's fix that real quick. So go to test data, pod YAML 2. Let's make sure let's give it more than two. Let's just give it 2, right? Because it's called 2. Save it. Let's go back to the all right, so KW or kube CTL. Let's get pods. I'll see all of them. Let's just see what's there. As you can see, I have my cert manager. I have kube running. I have nothing in the default main namespace. But let's just see what that looks like, and we'll do it from this aspect of things. Too small for you guys? Tough crowd. It's pretty tiny. I know. Better? I know the people at home are probably telling me, they're just like, I can't see it on this iPhone. It's just too small. All right. So let's try to deploy something real quick. So let's go K or CTL. Apply. Let's find POD 1. And if we go over, it's created. Let's look at that. She's pending. She's looking at it. She's thinking. Give her a moment. And if you guys don't know what this is K9S. It's a really awesome little tool, especially when you're doing anything with a cluster. As we're giving this now, mind you, this is a old laptop, and it is running Rancher Desktop as my Kubernetes, so it's going to take a fat minute here. But as that's running, let's try the second one and see what it looks like. Oh, nope. It gave me a rejected error. And so now I know something went awry, something went wrong, and let's see what that looks like. And this thing is really heating up over here. She's on full blast. I see my cluster is now reaching its limit, and I'll talk about that is because this machine is really small. It's actually a really underclocked machine, so it's going to be a little slow, so I apologize. All right, so she's thinking about it. But if we go over to all of our instances and we go to our policy server and we wait for the logs and give it a minute, in here, all of those logging functions that I put in there will show up here. Now, obviously, because it's the demo gods are not blessing me today, you're not seeing them just yet, but everything in here, you should see the rejection listed here and above. And I guess it's an underpowered machine, and I apologize. But with that logging that we have the ability to go see what happened for that. And the policy server gives us all of that as we go. And K9S is really telling me that my CPU levels right now are way too low, and that's unfortunate. So that being said, I want to move back over, and I want to talk about why I kind of wanted to do this slightly different. So I want to unplug this, let it die here, trying to create that pod. I'll come back to this. Generally, when you come to a conference, you go, hey, this guy's going to talk about something, this guy or gal, this individual is going to talk about something, and I'm going to learn something and take it from there. Give it a minute so you guys can see my screen. But I wanted to make this kind of different. So I want to give almost next steps, right? Something to take away from what you learned here. And because you might not have learned enough. So if you want, I could put it all on GitHub. Step-by-step instructions, and it's github.com/Robert Cirque, Rust Labs, WASM. You can go out there and pull this down and follow the README files. I actually have 7 of them in there that you can follow, and it's step-by-step instructions on creating a policy. And to do that, you can just download it and run the policy yourself. Now, that being said, to test it, you're going to need to publish it to a particular repository. So for that, I actually published it twice, right down there. There's no difference, actually difference in the syntax, but you can go out there and run this, demo yourself, pod sizer. The code's there, you can build it, or you can just pull it and just push it to your Kubernetes cluster running kubeborden and test it out. So I kind of did it a little differently because I gave you kind of homework. If you wanted to do it, you can. If you want to play hooky, by all means do so. And I'm going to turn over to questions, comments, concerns. Really? Nobody? Go ahead. Can you actually, I think you gotta go talk to the mic so other people can hear it, because we're live streaming. So there's individuals at home or at the office.
Yeah, I may lost somewhere. I saw you wrote the rule with policy with Rust and then run in Kubernetes, which is a Go environment. Like, how do you feel like these two languages work together?
Wait. Can you repeat the question?
You write the policy with the Rust, and then running in Kubernetes, the Go language environment. So how do you feel like how they work with each other?
Well, that's a great question, and actually it gives me the ability to kind of jump back. Rust is the language I chose to do this in, but kubeborden supports Go. I'll go back here. It supports Go, and you can use TinyGo to compile into WASM, right? So you have that ability. Now, I know .NET has Mono, but we do not have an SDK, but we do have a Go SDK, right? And so kubeborden's documentation will go through and show you that. You can use Rego as well, so if you have OPA existing, you can bring those policies over. I just chose Rust because I don't want to say it's the latest hotness, but it's been a language I wanted to, put a lot more focus on in 2022, and it's gave me an opportunity to kind of jumpstart on that. But we could have done the same thing in Go with relative ease, but the compiler is going to be using TinyGo, and our SDK and the documentation for that will go through and go into detail about that.
Cool. Thanks.
Now, one last slide, and I will let you guys go. Additional resources. I, again, make this is a PDF. If you go on my GitHub page that I put all this at, you can go down and download it. I have documentation links for the docs, KubeWarden, Rust, Rancher Desktop, and the reason why is it's just an easy, instant Kubernetes on your desktop. It runs on Linux. You saw it right then and there. Runs on Mac and Windows. I said Windows, so no one get upset, please. I know we're at a Linux conference. There's also a link to the community site where I work, right? And that's where community members can come through, assist you with questions, comments, and concerns. And it's anything to do with the SUSE and Rancher community. So if you can't find me on Twitter, you can find me on the community site. So that's community.suse.com. And we also have a Rancher Labs Slack channel, and that I'm always in answering questions and helping out in the community as well, all right? And if there's no other questions, I want to thank everybody. And for you guys at home, thank you. I appreciate you listening here on a Saturday, on football Saturday. So thank you.
All right, our next talk is in about 30 minutes. It's about AI and cloud infrastructure. So you got about 30 minutes from now. Reminder, there's still raffle tickets for sale. And if you haven't picked up your t-shirt, you need to do so. I'm here to introduce Lian Yang. Lian, is that how I say it? Yes. All right. He's a virtualization software engineer at SUSE Labs.
Thank you. My name is Liang Yan. I'm software engineer from the SUSE Labs. As you may notice, I'm the third presentation from SUSE today. So I think before we start, really thanks the OLF to provide this opportunity for me, for SUSE. And thanks for all your time here, to spend the time here. Hope you could find something enjoyable. And before we start, I think I have some borrows here. Cash. I'll just catch one. Oh. Anyone here? Okay. Last one. Want to try? Okay. Yay! We got a winner. Okay. Let's begin. My topic is accelerate your AI cloud infrastructure, but we don't do that. We saw all these kind of AI cloud from the public cloud provider, but we use them, but you may don't know how it is really implemented from the low level. So there's a lot of different implementation based on different infrastructure. But here today we're looking on SUSE, Linux, and the KVM and QEMU. So let's begin. So first is a little bit introduction from myself. I'm working for the SUSE Labs. It's around 5 years now. And I'm mainly working on the I/O virtualization, which is the network before and the GPU today. And also working on the ARM64 virtualization. So my work is pretty close with all the vendors, like the NVIDIA, AMD, Intel, ARM, and customers sometimes for some solutions there. I'm personally also working on some AI, machine learning accelerator research there. So this is part of the research, today's topic. I think, that's me. And here's our... This is you too? This is you? No, I wish. This is an astronaut from Mars. So we're kind of like him to do some exploration today. So today's agenda here, we'll have a quick brief on the AI cloud and hardware accelerator, have some basic idea. Then we'll take a look why we want to use NVIDIA GPU virtualization. And also we give you how we integrate partnership with NVIDIA, how to integrate GPU virtualization in our SLE Linux. I also show you a demo after that, give you a basic idea how to really run a vGPU and in a VM and run some AI instance there. So last we'll just see the future, our future, vendors' future, and the community activity for the next move. So back to the AI topic again. So if you are a data scientist or you're working on some data research project, data development, you may be pretty familiar with this workflow here. So basically, we are going to face a mount our data, do some training or do some mathematical algorithm, we call it, and then get a model out of it. This part, we call it training from the AI world. Once we got this model, this is not the purpose. We actually want to put it in use in a real product environment. And that's called another phase, the inference. And in that part, this model will make a decision for us. And that's what we call it machine learning. And that could do it all automatically. And if you work on that, if just yourself, you probably don't need any accelerator. But in reality is that you need to work on some quite big data there, like gigabyte or terabyte even. In that case, you really don't want to work it on CPU only. at that time, you may need some accelerator to do it. And these kind of three types in the current on the market. So the first is quite a mature product. We all know that. It's the GPU. Actually, we should call it the GPU, general purpose GPU. It's only for the computing. And we have this NVIDIA, AMD, and Intel. This is mainly used. Like I said, it could provide the OpenCL CUDA library. And if you are doing some training studies we just discussed earlier, you basically need the GPU there. But that's not the only option, like especially when speaking to the inference phase. There's other options, like the one, the FPGA here. It's actually already used by a lot of public cloud, like the Microsoft, the Azure cloud there. They're using FPGA. Not only for the AI workload, they even use that to accelerate their network. That's quite interesting. The other one is the most another popular one today, but it's not for training purpose or not on the server side, but it's more like in your mobile world, like the phone today. It also has AI chips there. That's actually the ASIC, and that could do some inference function there, and it like to process your image or some other purpose there. So anyway, we have this kind of a different accelerator. But back to the cloud, like the data center, we still need to focus on the GPU. Again, like if you're only working for yourself or you just do some scientific research, you probably don't need a cloud at all. But that's not the reality. In reality, actually AI workload is used like this way. So it's integrated with your the general cloud there inside your data center. It will manage all the physical resources and automatically. So in this case, when it comes to the accelerator, so there would be comes to the questions like in a general cloud there, we are running VM there. We know the benefit, like we can run multiple VMs in one physical VM. We can do a snapshot on it. We can do line migration, which is quite convenient for management. But can we do the same thing on the accelerator, especially the GPU? Earlier, the answer is no. It's difficult. Like at least from the hypervisor, from the virtualization stack, it doesn't support. This needs the hardware has its own mechanism to do the management, like to snapshot its device state, and like we can restore a device state and then we resume it back, make it work. Based on that, we can do other cool stuff like migration and so on. So the real question is here, like how we fix these problems to fit a hardware accelerator to fit in a cloud. So now it comes to the GPU virtualization solution here. And so thinking about the three problems, we just discussed that, like can we run multiple devices on one real physical devices? That's actually a very cool function. Thinking about it today, you're buying a GPU, that would be $1,000. And especially if you are working for a team, there's 4 or 5 people there, you definitely don't want to buy each one for every people. So in this case, we really want to run multiple GPUs there, or we call vGPU, virtual GPUs there on one physical GPU. And then the second one, like do we want to also do a snapshot for your device there? So like when we set up all the AI framework there, like if you have done that, you probably remember, it's disaster. There's so many libraries, so many configurations. You really don't want to do every time you're working on a new project. So why don't we like store a VM image there? So we finish the configuration, we save it. Next time, we just start a new copy of it. That won't be nice. And that needs the device to implement it. And that part comes to the vGPU manager here. It's kind of a module, kernel module, dedicated with the normal virtualization stack. It will operate on the GPU directly. It's kind of a alternative driver there, if we see that. So this vGPU manager could do a couple things. First, it's a scheduler there. It coordinates multiple vGPUs to share this GPU more efficient there. And it could also manage the device disk there. We can save it. We can do a snapshot there. We can restore it, resume it. And the other cool thing is we can also do monitoring. Like we want to check what kind of utility usage for the GPU today. What's the overload for this GPU? Like should we cool it down or should we fire it up? And that's another cool point. So that's a very good benefit to put GPU virtualization above the other hardware accelerator we saw there, like the FPGA and ASIC there. But only speaking of this part, NVIDIA is actually not better than Intel or AMD there. Because actually from the software perspective, Intel is earlier than AMD, than NVIDIA there. But as we all know, Intel doesn't have a dedicated GPU. It needs to use a system memory there. That limits its usage a lot. And AMD actually has a better hardware design. It uses a FRIOV mechanism there. So it actually implemented the resource splitting by the hardware. So that's more convenient. However, we still stick to the NVIDIA. And I think that's probably obvious today. Like if we check the software ecosystem today, it's basically dominated by the CUDA. And every data scientist couldn't bypass CUDA. Like even it could use OpenCL, but still most of the commercial product or stuff, they still rely on CUDA. The other side is NVIDIA, evolves quite better. If you see the picture there, each generation, Pascal, Walter, and Ampere, they have significant performance improvement. That helps them to attract customers a lot. So anyway, we stick to this NVIDIA GPU virtualization as the start point. So we partnership with them. We work close with their engineer, and we work on all the downstream implementation, and we provide a SUSE GPU virtualization solution from our side. So, like I said, so there's because from the we haven't talked a lot about the detail yet. If thinking a lot about detail, so because the vGPU manager there, this is the kernel module, and it needs communicated with other kernel modules and user-space libraries there, like the VFIO, MDV, mediated device, and the QEMU, the Word.io there. So it's a lot of work there. So it would be nice to provide it by a Linux distributor, and that's what we do. So we provide a reference platform for our customers there, and we start from the SUSE Enterprise Linux Enterprise server there from the 15SP2, and the latest one is 15S3. We use it as the host. We deployed the kernel, the vGPU manager driver from NVIDIA, and we use our driver, we use our kernel, we use our QEMU there to make it work. For the guest VM side, we also tried a different couple choices there, mostly from SUSE Linux today, and also some Windows VM there. So, but mostly we focus on the functions there. Like we needed to make sure it works correctly. All the library, no library conflict, no kernel ABI conflict there. So we make sure their driver, the CUDA could run smoothly in a guest VM. And we also want this guest VM has the 3D graphic performance, even though like today is AI cloud, so 3D is totally a bonus plus bonus there. And also like the remote display, like the remote desk VDI, some stuff there. And we also tried the max vGPUs there, running multiple vGPUs, 4 vGPUs, even 16 vGPUs in one GPU there. And we made them work, but we also did a lot of performance optimization. We ran a lot of benchmark comparing it with the GPU pass-through there. GPU pass-through is more like to pass through one whole GPU into the guest VM. So it's exclusive, and it has the best performance for a VM scenario. The only bad part is it could only be used by one VM, and there's a lot of limitation on that. So we also tried the different vGPU types there, because that's the good part for the vGPU too. Like you have one vGPU, for example, you use the Volta or Ampere GPU there, but you can also run other vGPU types there based on it. And also there's a different profile for the vGPU. Like some GPU is for the application, some GPU is for a workstation, and some GPU is only for the computing purpose. We only support the workstation and computing there. So I'll give you more detail there. So this is some tests we get. So one interesting part is that when we're doing the graphic performance, and from the first line is the default, like we just enable it. We didn't do anything to change the configuration. And we noticed that if you see the Maya Medical SW, the performance is really bad. And we spent time there to figure out why it happens. And eventually we found that it's actually the FTL. Like if you play games, you're probably familiar with the frame time limiter. And it is enabled by default, but we disabled it manually. And we also did some other optimization, like to enable display from the QEMU level, and also like disable ECC for that. And then we got a much better performance. Like you see, from like 1/3 going to like 120% there. That's a huge improvement. And like I said, graphic, this is just the bonus performance. But the other one, the computer performance results, is actually quite stable. That surprised us. And it's quite similar. Like when we're using a vGPU, it's quite similar with the GPU pass-through case. And we think that maybe it's because the GPU, the data plane there is quite straightforward. It's not like the graphic. There's a lot of like it's going to the OpenGL, render, DRM, all the drivers there, the GM, and all the even the gas top of that. That's so complicated the stack there. But for the computing side, it's just going to the CUDA or OpenCL and then going to the driver directly. Anyway, that gives us a very good GPU computer performance. That's also another insurance for us. So based on all the tests there, we found we managed to make our virtual GPU has the similar performance with the GPU pass-through. And we also found that no matter what kind of vGPU types you're doing that, like the workstation type or compute path, it has kind of a similar performance there. And we also saw that the performance is mainly decided by the hypervisor side. So no matter what kind of virtual VM there, like maybe we are using SUSE Linux or Red Hat or Ubuntu there, or even Windows there. It doesn't have too much difference. And we also running the multiple keys. For example, we run 4 vGPUs there. So it's not quite good for like we run 4 GPUs at the same time, but it's still better than our expectation. Like we run 4 vGPUs at the same time. One GPU should be like at least 1/4 of the general performance. But our results show that it's much better than 1/4. It's going about 1/2 there. So that's an interesting find there. So it at least gives us to know that if you run multiple vGPUs there, you should still have gains over it. And so we provide our solution, we make it a product, and we also implemented a lot of features there. Like you can run remote display, the VDI function, the graphic performance, we can support 3D, and the CUDA part, all kind of AI framework. This is done by another team, like AI and machine learning projects there, but it could all run where, or at least installment where inside a VM, guest VM there. And the computer performance, we also like the VM device snapshot there. We also provide line migration, but that's only technical preview, so we haven't really announced that. And the last part is the 800, the latest NVIDIA GPU architecture, Ampere architecture, Ampere 100. The biggest improvement that is 2 parts for this GPU. One is it also uses the same mechanism as AMD GPU we talked earlier. It uses a hardware mechanism called SRIOV. The other one is the MIG, the multiple instance. It's more like they put 7 GPUs in 1 GPU board there. So it actually has 7 GPU cores. You could use these cores to VM, or you can use it to container directly. That's, yeah, I'll give a little bit for the future side. Like that's another focus, like how do we provide device virtualization to container products there. So, and also we're also working on a security boot for vGPU. You see it's green, so we really have to work on that yet. So yeah, and I think from here you should know like how we really to put a hardware accelerator to make it work in an AI cloud. All the AI cloud, we running, we create an account there, we buy a instance there or drop plot there, and then we add a GPU there, and that's really how it's working. Like one vGPU, actually just one piece of the full GPU. Here, I'll just show the demo. We can start from the beginning to have a more clear. So. Open source, sadly. And during the preparation, you need to go to the NVIDIA website. You need to register an account, get a license. You can get a 3-month trial license there. You need to download the vGPU manager from their side and install it in your host. You need also set up a license server. And so basically, you need to get a license from their side, generate a license bin file, and then you create a local license server. You create a license server in your local, and then you upload the bin file there, and then it makes it work. So it's not ideal, but I think it's still better than, how to say, like it's still better like it's by one GPU rather than by 5 GPU for your teams there. So I think that's probably still very popular there. A lot of, I think most of the Linux distro has this partnership with them, like Red Hat or Ubuntu. SUSE is also part of it. So here is actually I upload the license bin file to the local license server. So at the bottom is the document from SUSE. So you can get the full instruction there. And also I said this is already a product for us. If you run it, if you found any bugs, you can just create a bug from our Bugzilla. We are obligated to support it. Here is, I'm already installed a vGPU manager there. Similar as the normal GPU driver, you can run the NVIDIA SMI to see it's there. And you can also see it actually uses the NVIDIA kernel module. It also uses the VFIO and MDV. That's we support there. So VFIO and MDV. And here is how I created a vGPU instance there. I'm actually using a UUID number there. You can see the 8400, that's the physical GPU. And I created this UUID, and I created, you can see there is a folder here. That's actually a vGPU. It has all the resources there for working. And here is we can remove it. Yeah, this you can check the detail. I'm actually created a V116C. Basically, it means this vGPU has 16 GB memory and for compute purpose. So I add it to a VM there. I already did. So this part is quite straightforward. You just add this command line there to pass through to the VM by the VFIO device platform. Now we do that. This is actually, you see a desktop based on a vGPU driver. I also did a little bit further, like to running a AI workload there. I'm not an expert on that side. I'm sure you could do better. Also, there's a lot of instruction. Instead, I choose to using NGC. You can call it the native GPU container or NVIDIA GPU container there. I just download it there, and then run it inside the guest VM. So here is, I'm doing, this is actually, I'm already inside the guest VM. And we also run the NVIDIA SMI status check. It's all there. And I'm going to get this NGC container here. You also need to register a key there for security purpose. Yeah, that's kind of a downside to use NVIDIA product there. Luckily, it's only one-time step. Once you set it up, you don't need to do it again. This part is very similar with a Docker process there. You just find the image you want to use, and then you pull it from the remote registry. Here I'm trying to find a TensorRT, the Tensor real time. Yeah, here I'm running the Docker to image. I already put it for time sieving. This is the one we're going to test. Now we just run the Docker commands there. Now we are getting into we already set up the GPU there. The GPUs we're using all. Now we're getting into the Docker environment. And I just run a TensorRT engine there. Here I choose a enter 8 type. And this will do, this engine is kind of a model we already trained. So what I'm showing here is actually a inference status here. Voila, it's running here. And it shows successful. So by the time here, we actually set up a vGPU in your host side, in your host environment. Back to the AI cloud side, this would be like, you don't know that this is all the detail. Like you run the VM, it's already set up there. You could just install the driver. They may already install the driver for you. You just check the NVIDIA-SMI to check the GPU status. And then you just pull the Docker image there and run the engine you want. What kind of image you want, engine you want to try? What kind of AI workload you want to test? Or you just want to start from the scratch to build it. But all this work we are running based on a GPU, a hardware accelerator, which would save a huge time there. And so that's basically the kind of the latest status for all these kind of virtual GPU. But let's take a little bit further to see how these kind of techniques going. What's the cutting edge part? So first is actually ARM side. I think ARM server is quite popular today. Everyone talking about it. Even NVIDIA, as we know, NVIDIA is trying to purchase ARM company there. And so we actually made it work on ARM server, but just the pass-through mode. We haven't done it with the vGPU manager side. But I have confidence that it will be soon. This would be driven by NVIDIA side, but that will be. The other side is the container side, the Kubernetes world. So like I said, vGPU could be working on our container directly, but before that, we can use the Kubernetes world a plugin, a Kubernetes plugin to running virtual VM, virtual machine there. So we also confirmed that, we verified that we could make our vGPU working with the KubeVirt. So if you run KubeVirt and start a VM there, and then you install the GPU, the hardware there, and you can just running all the container application directly. The other side is the Rust VMM world. So this is more like a light VM user scenario. Thinking about cutting edge, or not cutting edge, thinking about the edge computing. Or we don't want a QEMU or other like heavy virtualization application there. So Amazon, they provide this called the Firecracker. And also the Rust VM side has this cloud hypervisor. And this is also a discussion there. For example, the Firecracker recently discussed about how to enable a PCI bus there, which could potentially support vGPU. So that's also expecting. From the other world, from the vendor world, as we know, the AI machine learning is so popular. Everyone wants to jump in to get a piece of it. So far, NVIDIA dominated it. And AMD is also quite positive. I think they already partnership with Microsoft Azure public cloud there. You could use a GPU instance on that platform. Intel is about to announce to release a dedicated GPU. So the rumor been there for years, but it's close and closer. Another benefit for Intel is that they have a very good FPGA product there. So somehow you could still use their FPGA to do some inference acceleration there. And ARM side is also ambitious. So they have Samsung actually working on a similar mechanism there as the NVIDIA Ampere, the MIG, like to put multiple GPU cores in one board. So basically you have multiple GPUs. It's not a vGPU, it's more like multiple GPU cores, GPUs, their arbiter, and to do all the coordination and run it in one SoC. The other one is from the other solution, the ARM, the Mali GPU. They also have a similar mechanism as the Intel there to do the software implementation. And it's also ongoing. And for the last part is how to use device virtualization in a containerization environment. And that's quite new. NVIDIA has their GPU operator. You could use that for Kubernetes directly. It could be used as the plugin there. And the MIG, we just discussed that. It could be used by, like, run the Docker there. When we set up the commands there, we can just give one piece of the MIG there. So that, and from the community side, and we have this scalable I/O mode there. So that's basically that's a huge improvement, a huge feature there. So it could make the vGPU or virtual device there could be used by container directly. So I would say this is a quite interesting, quite excited. There's a quite exciting party outside. So looking forward what will come next. I think that's all for my today, and I hope you find something useful from side. So thank you again for your time. And if you have any questions, feel free to ask. I would be more than happy to answer. Thank you. Any question? Okay. Yeah, if you interested with this slides, you can get. I think I send it to the organizer here, or you can reach me. I will be pleased to send you. Also, like if you want to discuss further on all this stuff, I'm happy to be talked to it. Okay. Thank you. Thanks.
Good evening, everybody. Oh, come on, let's get a little bit more noise than that. Come on, good evening, everybody. All right, that's better, that's better. Thank you very much. I wanted to introduce our closing keynote, our final speaker for this year's event. And it's really an interesting person that we've gotten. It's Kate Stewart. She's working with the Linux Foundation in safety, security, and license compliance. And she was one of the founders of the SPDX project and is currently the specification coordinator is the title that she has for that project. And it's an interesting thing to designate licenses and make that information easily machine readable. And if you are not familiar with it, definitely check that out. She does have a huge background in the embedded space, and that's what we're going to be hearing about this evening. And think about it. How important is it that your code works? Pretty important. Well, how important is it that your code works if it's running on another planet? Probably a little bit more important. So we're going to hear about Linux in space, or Linux on Mars. And I want to welcome you and have a great round of applause for Kate Stewart.
Thank you. Thank you very much. Show of hands, and I love being in person so I can ask this again. How many of you guys grew up watching Star Trek reruns after school? Yeah, okay. My peeps. Space, the Final Frontier, right? And I think it's inspired a lot of what we're seeing emerge today.
How many people grew up watching the first run of Star Trek?
Okay, Mad Dog. I think it's you. But anyhow, yeah, no. I've been at the Linux Foundation now for about 6 years, and my focus in my career has been in embedded systems, from compilers to OSs and so forth. And embedded systems, we need to figure out how we can get things to be reliable, because it's a lot harder in certain circumstances to update and change things. They need to be maintainable. And in the last few years, I've been starting to focus more on to what do we need to do in order to be able to use embedded software and open source software in safety critical spaces, which ties in a lot of the themes of things that I've been caring about through my career. So I'm quite excited. And the highlight talk for me from this last year actually was in September from Tim Canahan. And he was at the Linux Foundation's open source event as one of the keynotes. And he was talking all about Linux on Mars. So I was just geeking out like you wouldn't believe. And one of the statements he made struck home to me, which is, in many ways, it was a conventional Linux hobbyist project. And, all the components are there are hobbyist projects. And then all of a sudden, this all gets put together by these folks, and it makes it up to Mars. So the Ingenuity drone, effectively, has Linux running on the copter itself as well as its base station. And we've got, it's a Qualcomm chip, and that is where the Linux system is running, and it's tying into Zigbee to do the communications. And so these are all things that are off the shelf and common parts. And most of the software, I think, for this is actually available online and free. The F Prime is the Splite software, as well as there is these various Linux builds that are used. And when he started talking about, okay, here's all the pieces that are inside, it was sort of like, oh, this is cool. They're using Lenaro's build, which was Yocto. And the challenge with embedded is it isn't always obvious what software is running in them. And so one of the things is like, oh, I get these little cookie crumbs here and there. And it's like, oh, that's Yocto, yay. And then Linux, obviously. And then they were talking about, how the BSP came about and then what was running on each core. And then they're using various utilities from the Linux kernel. basically doing the bzips, for taking the logs, doing the compression, and and then monitoring the system. Are you using all your cores effectively on this processor? Things that we'd all sort of do if we were working on systems here on Earth. But obviously, when it's running over there, it's going to be harder to do an update and do a fix. So I'll be posting the slides. The links are there if you want to watch the video itself and listen to him firsthand. I don't work for JPL and NASA, but I've just been really super geeky about this whole stuff. And then the other thing it was also on the Perseverance, the rover, and the cameras were being running Linux. So we had Linux running in multiple places here already. And this one was basically using an x86 and a 415, more recent kernel. And so he was going into all of the details of this. But it's also running Python, it's FFmpeg, it's curl. A lot of these utilities are there. And one of the things I thought was absolutely wonderful is they reached out with GitHub to give badges to everyone's open source project, to all the developers of the projects whose code was actually made it up onto Mars. I thought that was a beautiful touch. And I think we should be doing more of that as communities, is acknowledging the wins when these milestones, because we all build upon each other in open source. And that's part of where the magic's coming from. But it's not just there. We know it's been, at least since 2013, it's been on the space station. We're seeing the basic robots. They've got some free-flying robots that are now there on the space station that are running to act as assists and carrying things around. And so we've got these free-flying ones. We've got some of the Windows stations that Mad Dog was talking about have been converted over to Linux. There's no point in sending it back down to Earth. It's still good hardware. Let's get software on it that runs. And so we've seen that happening in the last 10 years. And then even more recently with the SpaceX work, they're using Linux. So they're even using the preempt RT patch, which I thought was kind of fun too. But they're seeing it on the spacecraft and on their rockets. We're running Linux, and in the satellites, in the Starlink system. So if you look at this, right, it's, there's 30,000 Linux nodes sitting there in our Starlight system circling the Earth. And so that's a lot of Linux out there in space. And I've got some links here if you want to read, if you enjoy geeking on this subject and the final frontier effectively. There's a lot of things that are emerging, and I think we'll see more in the years to come. And I guess the important part is Linux. Well, it started off as a hobby 30 years ago, and stick around after this. We'll be celebrating the 30th birthday of Linux. And it was, there was a book that was put out in 2001, just for fun, which gives a bit of a background. And inside Linux is a quote, "And sometimes revolutions just get stuck with it." And that's the challenge too with open source, is you put something out there and then people want you to support it and keep supporting it. And so the question is now, how do we start to get these types of things to scale? Because right now, Linux is one of the most important pieces of software platforms ever. It's dominated most of the markets it's gone to over the last 15 years. And even in embedded, it's at 69%, at least as of the numbers I could find in 2019. I haven't found any more recent numbers, but I think it's probably even higher. But the fact that we've got Linux sitting in all these places and driving so much of the world's infrastructure, it's kind of a larger, for something that started as a hobby and then just persisted for 30 years, it's a lot of questions as to why has it succeeded and what can we learn from it. Now, one of the things I like doing is doing some data mining on the kernel. I work with a researcher up at University of Victoria called Daniel German. And there's a project called Craigit. And basically it does an analysis of the Git commits onto the kernel down to the token level, which is, if you think of a line of code, it's all the variables and symbols. Each of those is a token. And that gives you a higher fidelity than just a line level to understand what's managed there. But right now, there's still tokens in the kernel back from the very first version. We've been able to parse it by resequencing the full Git sequence through it at the token level. We can find evidence of pieces in there that have been persisting since '91 So we build upon each other, we refine it, we enhance it, but we've been building on it for this whole period of time. And so I've got the data up to the 5.14 kernel. I've got some of the later kernels. We'll be working on them and finishing off the 91s, the 2021 stuff. But these tokens replace themselves over time too, right? As you add new features, as you rewrite code, you'll see that, this was in 2020 for the 5.8 kernel, and there was, 2009 64. It's down a few. So some of those tokens have been replaced. But the fact that you can literally go back and see tokens and evidence of how people are participating to the kernel, to me is very fascinating. And it sort of shows that we all have to build upon each other in the bridges we make. Now, another project that's got opening hobbyist roots is Yocto. And in 2003, they created a BitKeeper repository for it. So we have the full history there too. And then Richard Purdy worked on Pokey, which became the start of what eventually became Yocto. And in 2010, it was announced as a project. And they aligned with the Open Embedded and started to work on releases. And that Yocto is a distro for embedded. It's a way of basically forming a distro. And so, thanks to Phil Ballister for helping me to understand what the timeline was. But it also is like, okay, these two projects, Yocto is there for Mars, Linux is there for Mars. There's a lot of projects out there. There's, hundreds of millions if you look on GitHub and GitLab stats, right? So the challenge we see, and this is something we've been seeing in the LF, is, which projects really matter, which ones are going to persist. And more, it's the challenge is what's going to be sustainable. How can we sustain things over time? And to a large extent, it's who's building up an ecosystem? How is an ecosystem building up on these things? And I'd say more than sustainability, we need it to be dependable. If we're going to be having some of these softwares go into these critical infrastructures, we need to start figuring out how we can make it dependable so that people can rely on it. Because fixing bugs in some of these embedded systems is a lot harder, and then potentially there's consequences to safety critical lives and infrastructure, power grids, things like that. So at the LF, this is a slide that Jim Zemlin uses, and it really does tend to resonate with what seems to be working, is you have to have a developer community using the technology, and then have effectively commercial people making products around it to help support the infrastructure so that people can do development. And people can get jobs. And so we have something that's sustainable. That, at the heart, is a lot of what we're seeing with some of these projects and seems to be working with both Linux and Yocto. So the Yocto project was one of the Linux foundations. After Linux itself, Yocto was one of the first projects we started at the LF. It's available to members, but anyone can participate. You don't have to be a member to participate in the project technically. But the infrastructure is there from the members who are getting value from Yocto to help fund, testing hardware. Help fund Richard Purdy to make sure he stays neutral, right? Michael Halstead runs the system. Steve is working on the LTS. And then Bootland for documentation and integration work. These are tasks that not every developer wants to do. So the challenge now is, there are things that developers enjoy doing, and there are things that developers don't want to do. And for a project to be successful, both need to be there. So remembering the hobbyist roots, we're seeing basically a good growth in developers emerging in the Yocto core, and the commits are at a pretty good level coming in from this perspective. And these are not just members, these are all the community that's happening, and the open embedded participants. So the technical is there, we're working there. And these slides were just recently created by Nicholas Dechen for the Yocto Dev Days, which happened 2 days ago. So it's pretty fresh. Now on the Linux kernel side, like Yocto, the contributors keep growing year on year. So for like last year, I'll get the stats probably in another week or two's time for 2021, but for 2020, there's well over 4,100 developers participating in the kernel, putting those tokens in last year. So just think of that. There's over 4,000 people participating in coding on the same project. That's sustainability. And it was, in some ways, probably, like I say, I'm curious to see what the final numbers are for this year, whether it's higher or not. But it was one of these things that I thought was interesting. And obviously the commits, all those features and the churn and changeover and refinement and bug fixes and so forth, you know, up till the latest date I've got, 2020 has been, you know, another peak year. How much of that's COVID? How much of that's new trend line? We'll find out. And as I said, it's going to take real work to get these projects to be sustainable. There's things like releases. Not every developer wants to work on a release. You know, there's things like, you know, making sure that there's trademarks associated with it. There's guidelines. There's infrastructure, obviously, and then the best practices are followed. And then security. Who wants to fix the bugs? You know, what's reliability looking like? These are elements that we're going to need for open source to be sustainable and dependable in the future. So one of Jim's sendings is, you know, 80 to 90% of the software these days in modern systems is written by external parties. You don't have direct control over it. And we need to start creating a culture for secure coding backed up with incentive resources and training so that we can actually scale and keep the scaling going. And so now contrast that to the hobbyist contribution to open source. People are doing things, and this is where the innovation's coming from, okay? We need the hobbyists to stay engaged in open source. And some of it's spare time at home, like because you enjoy coding, you like learning the new things, you enjoy working with the community. These are sort of the main reasons I've heard. And then there's more and more discretionary time at work. A lot of enlightened companies will give people like a day a week to do what they want to do. And they still provide a salary. And so they can explore ideas, they can do new features. This is also a sort of, what I would call a sort of supported hobbyist, because they've got a salary associated with it. But they're doing things that are advancing the innovation. However, they're doing it for fun. They're not doing it for, they're not doing it for the view of, okay, I want to go fix, some people like fixing bugs, don't get me wrong, but you know, it's sort of like, there's certain things, certain tasks they don't want to do. I don't want to write documentation, or I don't want to do that. Various steps. So at the start of the year, the Linux Foundation and Harvard's Lish Group got together and did a survey of maintainers to try to understand what the motivations were. And we were looking at this from the viewpoint of, okay, secure coding. But these motivations are valid here for dependability as well. And the top one was people are doing this because they want to fix a feature, something they need. Then they enjoy learning. That was number 2 motivation for paid and unpaid people for contributing to open source. And then, you know, it allows me to fill a need for creative challenge and enjoyable work. That's why people want to contribute to open source. That's why I want to do the hobbyist. And that's where the innovation's coming. That was, I'm paid to develop FOSS was actually the least most popular, number 10 was the you know, least important, which was a bit of an insight. I had not realized that before we saw these results coming in. And then, you know, they weren't really caring about it for their careers, again, paid and unpaid. Or for that matter, you know, recognition of the peers. Like I say, we put the survey out and we heard back from these maintainers. This is what they valued, which sort of resonates with the just have fun. I want to have fun. I want to do something that's interesting to me. And hey, if it helps someone else, great. The other thing we saw from that survey is that the employers, their policies have improved. The free to contribute, that extra day, the supported thing, we're seeing that go up. And we're seeing, you know, it used to have more of an unclear policy 10 years ago. Now it's much more clear. So, you know, we're seeing some interesting trends. You know, some of them still require permissions, but fewer are not permitted at all. Mostly everyone's accepting that they can contribute out to open source in a lot of the companies now. So we're knowing that open source is critically important today. Most of the code bases, based on Synopsys' study, contain open source. You know, on the percentage of the code base is 70%. And you know, if you're starting to look at app space, the components per app, 5 years ago, about 84, now it's over 500. This is all a very modular system, and it's all building upon what others have done. These are all building blocks. So they're all building blocks. How do we deal with this one? This cartoon came out from XKCD last year. I love it. It just summarizes so many problems. So we have some person in Nebraska that's been thanklessly maintaining something that everyone else depends on and no one knows about. We also have the foundational pieces too, quite frankly, don't get me wrong. These are the Linux kernels, these are the octos, these are the tool chains, the build infrastructure. Things are important. But understanding, we've got a lot of really sophisticated infrastructure, and having the transparency to understand that is one of the problem areas this is where it touches into licensing for me, because the transparency and software transparency and understanding what software you're running is key to fixing things, okay? If you don't know what's running on your software to a couple levels of, through the dependency trees, if there's a bug there, you may not know. If there's a vulnerability there, you may not know. If there's a hazard coming in from a safety perspective, again, you may not know. So getting the dependability aspects, I'm just going to use Wikipedia definition. I figured enough people looked at it, everyone agrees on it. But availability, reliability, maintainability for durability and safety and security. When someone's doing something for fun, are they thinking of all these aspects? Likely not. However, when we start to use the work, we've got to start to think about these things when it's showing up in places like space and in things that are safety critical. And so I'd say that the next challenge for us all is, getting dependability with open source working well together. And this is personified very clearly in the embedded market segments, in the industrial segments. Getting the robots working that interact with people in shelves in big warehouses, okay? They could hurt someone if they run into them. Medical devices, yeah. I don't want anyone sort of snapping the data off of my device, seeing the data. I want security there. I want secure communications. I want to know that no one can hack into it and give me too big a dose of medicine, or some sensor monitoring information is skewed or something like that. Automotive, we know that Tesla's got cars running Linux today. There's other places we know that Linux is showing up in these automobiles. If there's a glitch somewhere, that could actually impact someone's life. So the world is changing. And software is emerging everywhere. But the challenge is a lot of the methodologies that have been used in the past for analyzing the safety aren't really scaling to what's happening in open source. So the other things, I guess, are obviously energy infrastructure. And as we were listening this morning, we're seeing these different systems and building the trust and having that trust in the systems as to what can be executed in places that, code from hobbyists can impact people's lives, flat out. So the other thing that's sort of interesting to look at, and this came from that earlier study, is where do people want to spend their time? What is actually important to them? Well, you can sort of see that this is reality. They're spending most of their time. They do like to do a lot less maintenance on their code. What they really want to do is spend more time developing new code and improving the features. That's more fun. And then fixing security. Hey, way down there, okay? Security isn't what people are caring about. But it is, certainly where we need to be focusing to make sure that we can trust the software and it becomes dependable in these spaces. So, in my mind, this is the next big challenge for us in the open source ecosystem, is how do we scale our projects for developability? When someone makes a decision to open source something that they've worked on, hey, it's useful to someone else. You've got a personal project you've done on GitHub, it's self-maintained, it's fun. You might attract one or two other people. Okay, that's fine. If they want to use it, good, but this is a way of sharing, but you don't have to worry. But then someone starts bringing more dependencies on it. I didn't sign up for that. I haven't signed up to support all those, but they're finding it useful. So how are we going to scale that? How are we going to scale that interaction? And, is the developer consciously thinking what they want their role to be? How long can they support it? A lot of people sort of burn out because all these people are sort of coming after them. And so the projects that we look at that have succeeded, what things have actually worked for, people defining their roles and then figuring out how long they're staying engaged. And then the other challenge I'm going to say, based on what I'm seeing from these motivations, are, how can you architect things so others can participate? Be that rearranging your code, partitioning it differently, carving out certain tasks, re-architecting like the modularity so that you minimize interference, basic software engineering types of principles. But if something's becoming really popular, how can you make sure you engineer it so there's other people who can do the things you don't want to do? Figure out what you want to do, figure out what you don't want to do, and then make it possible for others to participate, especially if they have a need for it. So how we can start to scale our projects and open source projects for dependability is what I consider quite a fascinating space. So I'm going to give a few examples here. We've got the Linux kernel, which we've talked about, real-time Linux, Lisa, Yocto, civil infrastructure, automotive-grade Linux, Zen, Zephyr, and then the Open Security Foundation. Talk a little bit about them, but not all of them. I'm just going to focus on a few. So what's worked? Well, in Linux, I think one of the biggest insights was establishing that maintainer hierarchy. I think that was probably the key for starting to scale this up. Now, and there's been a laser-like focus on quality. You can't get a new feature in unless you can prove it's improving the quality compared to what's there. So this has gone for a lot of back and forth when people want to put their new ideas into the kernel, and there's a real justification and technical meritocracy that emerges. And this has caused the code base to be evolved, and various models were tried in the 2.6 time frame, and then when we moved over to 3.0, that we hit on the cadence that we're working on today, and the release cycles, and the methodologies, and then there's that focus that, hey, you're not going to break the user API. And that's let, I think, the project scale. The other thing that's emerged is the technical decisions aren't coming from one company. It's coming from a wide consensus that's independent of who's funding the project. That neutrality has been key, I think. And then, quite frankly, it's the people who are benefiting from Linux who are funding the infrastructure. They're funding the servers we're using. They're funding Linus and Greg and Shua and Konstantin and others who are working the infrastructure for Linux. So that's what the membership of the Linux Foundation is doing, is helping to support this to happen. Now, other steps that have emerged are the notion of having a long-term support. This made it possible to make products and to keep the change rate down, but still have the key fixes you want. And that's become really attractive for the infrastructure side, from the civil infrastructure. There's a security focus. There's people who care about security and make sure that the fixes get backported and that regression testing is happening. Not every developer wants to work on that, but there's groups of people who do. And so carving spaces so that they can work on it effectively is key. And so getting those carved spaces and people who have a vested interest in making these things happen is one of the things that I consider a really healthy dynamic from the Linux kernel. So like real-time Linux patch, the preempt RT patch set, was being carried outside the kernel. No one really wanted to finish it off. A group of companies banded together and have funded, for the last 4 or 5 years now, the slow and steady upstreaming of the preempt RT patches, such that the main methodology in another year's time, well, probably, hopefully in the next 6 months actually, everything that will be there, so that a lot of the analysis we use for safety on the kernel, from what's upstream and all the rigor there, you're not carrying an extra set of patches for when you want to use real time, which is going to be key for embedded, because I got involved with needing embedded back in, I guess, 2007? For when I used to work at a company, we needed to have the embedded preempt patches. So I've been sort of aware of them, and we need them, but so forth. And then recently, there's a bunch of people that are banding together to improve the kernel CI infrastructure. The ELISA project is basically trying to figure out, okay, how do we collaborate on the processes for dependability and making things safe? Such that if you're using something in a safety critical application, you can do the right level of analysis and you have processes, because quite frankly, the standards really can't. They envision a different model of development and they look at things at a system level rather than at those component levels. And so we have some impedance mismatch. The thing is, the kernel has a lot of things it's doing right, and so how do we figure out how to do the right level of analysis to know that a system is truly safe? And then the civil infrastructure. Well, when you've got your street lights working for 30 years, you don't want to go up and update the software by putting people up there. so forth to change things. And trains, the software, the automobile cycles, some of these things, actually it's not the automobiles, that's a different set of rules, but the whole infrastructure, having ways that we can standardize that and keep things supported. They're working with the Debian project as well as the Linux kernel. And so these are some of the things that, Linux has provided a place for people to collaborate on problems together. That's helped to scale it up for all the contributors. And then it's also been very good about being public about documenting the best practices they're doing. You can go and look at the best practices badge for security. For Linux, it's one of the few gold badges. There's I think less than 10 of them, and Linux kernel is one of them. And one of the other things I do is I'm a volunteer for the Linux Plumbers Committee. And so I help put on the Plumbers event every year for the developers. And this year, Mad Dog was kind enough to keynote for us. And at the end of his keynote, he was looking back over 30 years, and we asked the developers, we asked them a little survey. Okay, what do you think is going to be happening? And the developers there, pretty much, and this was all virtual, once it filled in, we had 203 fill in the survey, and I think Linux will still be as popular 10 years from now. Yes. That was a pretty overwhelming yes. So the community is happy. Working with the infrastructure they've got today is my basic read on that. And that's partially because there's been separation, there's been logical extension so people can focus on what they care about the most. Sure, there's friction here and there, okay? But to see that, that proportion still thought that Linux kernel would be sustained, I think was an interesting indicator for me. The next sort of challenge we're looking at is, okay, how are we going to get Linux working in these safety critical spaces and get the analysis done? So there's a group of companies that are banding together and working with some of the, the TÜV suits and the experts in the certification like UL, Underwriters Laboratory, so forth, to talk about this and figure out, collaborate, what's the process that's going to make sense to you, to everyone. And so the ELISA project is basically looking at, okay, how are we going to define that common set of elements so that we can build an industry consensus up about what makes sense, and then people can apply it in a sane way. And no one's going to come up with this idea on their own. They're going to be coming up through discussion, through talking, and trying ideas, and then evolving. So innovation is needed in this area, no question. Another case study is Yocto. Again, early collaborative LFF project. It's evolved its governance since it started. The governance was actually reworked in 2019 to improve the neutrality and clarify the interactions with Open Embedded's TSC, the Yocto TSC, and the governing board, where the money is. Like the kernel, the project directly funds the architecture and the infrastructure to keep it neutral. And then members with that commercial interest are funding it to have the infrastructure there that they can all share. They've introduced having a long-term support. That was something that the members wanted to have. It's being used heavily for the automotive-grade Linux. All that infrastructure for AGL is based off of Yocto, so that people can take it and customize it and work from there. One of the things that they're doing that I'm really excited about is they've been very strong adopters of the reproducible builds and adopting security best practices for that, so that you have the full reproducibility happening, the ability to have that, which is going to be key for traceability and software understanding exactly what software you've got. And they're also very much at the forefront of improving the transparency and automatically generating a software bill of materials. So you can do your builds now for Yocto and generate an SBOM to have your full traceability of your dependencies. So that type of level of transparency and traceability helps with the visibility and be able to track down and understand if you are impacted or not by a vulnerability or some other flaw in the software. And as you can see now, Yocto's project is very diverse. We're getting multiple companies participating in the core and non-core. It's not dominated by any one company. This is a good story. It's got robustness in the ecosystem. It's not just one big elephant that is dominating a project. The fact that we have the diversity there and that the project is continuing to grow and attract more members means that we have more discretion on some of the infrastructure we can fund. And so there's no shortage of ideas. Like the Yocto project right now is working on their 5-year plan. and working at, and information's coming in from the members, from the TSC community, and they're trying to figure out, okay, as more members come in, what should they be funding, what should they be prioritizing? A slightly different one that's a bit more recent on the scene is Zephyr. Now, this project was just launched in 2016, and it was launched because, quite frankly, Linux doesn't get smaller than 2 meg these days. And there's a heck of a lot of sensors and actuators out there where the fractions of a cent are necessary. They don't want to have long power budget. And you need to be able to be in a very resource-constrained space. So Zephyr actually takes a lot of things and lessons from the Linux kernel. And the code base is very familiar to an embedded Linux person. It's using kconfig, it's using device tree, it's using these standard mechanisms. And so it was launched with the neutral government with 3 members at the start. And we evolved until it's over 20 members now with the project. But like the Linux kernel, the technical decisions are made by a TSC. They're made by the maintainers, and there's a TSC for this project rather than just a hierarchy, a Linus here. But the technical decisions are independent of the funding. The developers manage the code. And the project's funds from the members is supporting our build infrastructure. It's supporting the people doing the project management, the people arranging meetings, things that help keep a project vibrant and interacting and innovating on a technical side, doing things that the developers don't want to do. So that lesson we've learned from Linux, we applied it here, and it seems to be working out fairly well. The code base is continuing to evolve. We had micro and nano kernels initially, and it was refactored into one kernel. We've basically had a lot of new communication stacks that have been added over time. An LTS was forecast. We planned right from the start to do LTSs because we saw that working in the kernel in this project, and we just finished putting out our second LTS. And that is the basis that we're going to be doing for safety and for our safety certifications this year with this project. Right from the very start, there was a security committee. It became it manages vulnerabilities. It's handed bulk vulnerability reports. It's one of the few open source projects that's deliberately recognized as a CNA by MITRE for handling its own vulnerabilities. And it's got a PCERT team for resolving them. So it's trying to find the best practices and apply it here in the deep embedded space. And then this project is one of the few, and it's working with some few others, that has a safety committee. And they've actually, the funding from the project has hired a functional safety manager because none of the developers want to do that. And that's working to articulate the artifacts and work with the standards, and then work with the certification authority to make the project certify. Now the code, there's agreement in the developer community here to align towards MISRA coding standards. And we're working on putting tooling in place to make that happen, so that anytime you check in, you're sort of configured. Because a lot of what's in MISRA is weaknesses. It's trying to avoid weaknesses in the code base. So it's a good thing to do. It's higher quality. But having automatic checking, getting it on things, is what's going to help us get our dependability levels up and hopefully get 61508 certification next year. One of the other things that Zephyr is doing is it's got, in the build infrastructure there, again, you can automatically generate a software bill of materials on every build. In fact, it generates 4. One for the Zephyr code, one for the SDK, one for the app, and then one for all the build artifacts, the libraries to the executable, and linking back to the appropriate sources. So you have full traceability for an executable to exactly which sources made it in. And this was really useful in, going forward. And what drove it home that we needed this is last year Amnesia 33 came out, and that was FNet. It was a vulnerability with FNet. And we had FNet in our LTS. We knew we had some of that code there. It wasn't in our latest mainline or our tip, but it was in the LTS. And so we had to do the analysis to support the LTS. And none of the files that had the vulnerabilities in were actually in there. But if you just looked at the version numbers, it would say, oh, you've got FNet, you must be affected. Well, no, you have to look at the source files to know if you're affected or not. So we had no way of signaling this other than putting out a blog post for the project. We had to say, no, we're not affected, we're good. Nothing to see here. Now there's other ones we found that we were affected and they've been remediated. But being able to have that level of responsiveness, and the transparency is, I think, where we're going to need to go as a wider open source industry. And then, like the Linux kernel, there has been a best practices badge, and that's now under the OpenSSF. And what it is we basically publicly document all the processes that Zephyr follows and make it visible to people. And anytime we can find a new best practice, we're trying to apply it here. So OpenSSF is looking at figuring out how do we identify these projects, how do we make sure they're secure, how do we build up the ground level of security and knowledge in the industry. And we can apply it in some of these projects, and we can apply it to other projects too. There's a lot of other projects there. You know, what projects are most critical? This is the one that's looking, this group is looking at that and trying to understand that beyond these. And to look at whether or not Zephyr has been effective, as you can see, we start off with 4 boards in the project. There's now over 350. I think actually it's closer to 400, but I couldn't confirm it before this talk, so. We've got a pretty good long tail of contributors. I think actually when I refresh this mix, it'll be a little more thing. But you know, when we started off, it was pretty much 2 or 3 companies, right? And we've been slowly and surely pushing back the diversity and increasing the robustness for the code base. I missed a typo there. There's over 1,000 there. My bad. I'll fix it in the slides before I post it. But there's over 1,000 contributors now into Zephyr. And so 1,000 contributors, we were actually, in this project, we're seeing 2 commits an hour right now. The Linux kernel, for perspective, is about 10 commits per hour. And so for a deep embedded project, as an OS, that's kind of has something we're pretty proud of. So a few final thoughts to leave you with. So when the project's popularity and dependencies increase, starting to think about how do we architect it so that others can participate effectively, and consider re-architecting the code so that we can get the quality and the maintainability we're going to need. If there's a lot of people that are depending on it, it's kind of worth spending the time to do that. Not everyone wants to do the same thing. Not everyone thinks the same thing is fun. Recruiting other resources to do things you don't want to do as a developer is something we need to start looking at as on a wider. So you need to build up these communities. You need to build up these ecosystems. I think if we can do that, that seems to be working. If your project is getting really important, make sure the governance is known. Ideally, move it to somewhere neutral, but at least let people know the terms they're contributing under. I think these are all things that help establish good best practices. And then, these are modular blocks that are used in systems. Start to think about system engineering. Start to think about how the interfaces work. I think if we can get that clarified, all these things can start to get us to that dependability scale. So I think the world needs open source innovation, no question. Challenge is going to be how do we figure out how we can do it for sustainability and dependability. And with that, thank you. And does anyone have any questions?
What specific use case does Zephyr used for?
So Zephyr is being used right now in things like hearing aids. So Oticon's product line of hearing aids has Zephyr in it. We're seeing Zephyr being used in being welded onto the side of garbage trucks because it has to have a long battery life. And so every time a dump truck goes up, it triggers a signal. We're seeing it being used in tracking. We're seeing it being used in power management. It's a very, very lightweight OS, and it doesn't consume a lot of resources. We know that Zephyr is being used today in things like wind turbines. And so it's embedded, though. It's hard to find. We find it through communication paths things. Bluetooth, there's a lot of very interesting Bluetooth applications emerging. And that's some of the Bluetooth certs. That's how we find out some of the products. But you'll see it in quite a range of ecosystems right now. And I suspect you'll see a lot more rolling out next year. Go for it.
I had a hard time reading all the companies. The type is a little bit light, but what I did notice was there were no aerospace companies, Boeing or anybody else in
know.
that list.
I know. I'd
So
love to have some.
Well, we can talk about that. The automotive piece, though, I'm curious,
Sure.
how much of that is devoted on the safety side to autonomy?
So mostly right now, there's a lot of people that are interested in the autonomy space, and the training data stuff isn't really showing up into some of this area yet. But there's a lot of people working in that. On the Zephyr project, it's more happening in terms of some of the sensors and the actuators, LiDAR. So we've got a member in Zephyr Bomber sensors, and they're basically working on trying to make sure that their sensors can be working with this. Again, it's keeping the constraints down.
Yeah, no, definitely want to follow up with you about
Okay,
that.
sure. Anyone else have any more questions? Well, thank you very much then. Appreciate your attendance.
Thank you, Kate. I am so excited that you have chosen to continue the tradition of closing out our evening with a keynote with such distinction of being able to really see into the future of how not only the Linux kernel will be developed, but all of free software from industry and individual competitors. Please give a round of applause for Miss Kate Stewart. It has been an honor to work with you, Kate, with the Linux Foundation, and you, Mr. Dalton, and you, Kara Pritchard. I am so humbled by how much industry-focused 501c6 organization that had all of the industry support decided to support us, a community show, with a $5,000 grant to continue. And as of today, I heard that this is a perpetual grant to continue. So thank you so much. Thank you. 19 years ago, we decided to bring user groups together here in Central Ohio to come every fall and enjoy everything that is not just Linux, but all of free software. Here we are, 19 years later, re-emerging as Open Libre Free OLF Conference. There were a lot of points of uncertainty whenever we were putting together this year's event, especially with how is it that we would come back and reemerge in freedom with the autonomous community spirit that we were founded as a simple user group following. There were definitely twists and turns and weeks that I myself had personal doubts. As a team, we met every single week and discussed whether or not it would be practical, feasible to continue as an in-person hybrid conference, every single Wednesday night we had this conversation, and every single night we all said, go. And because you're sitting here, I am sure that you said, go. I want to thank every single last one of you looking at home who are not ready to come back and have tuned in and decided to believe in us as well. I am honestly touched from the bottom of my heart as to how in the world that the Ohio Linux Fest Corporation, a small little nonprofit, would reemerge in freedom. So thank you so much. We have had a fundraising tradition of passing a kitty that was started by John Mad Dog Hall, as we weren't sure whether or not we were going to even be able to exist year 2. And we came to the Hyatt Regency Columbus with a dream of, could we turn a user group meeting into an actual conference? And lo and behold, 19 years, we have done it. And with the reemergence, it does feel that we have done it again. And once again, we can continue to provide high quality, free and open source content to anybody who's crazy enough to join us in Central Ohio. And now, my lifelong dream of being able to deliver this to the world audience, I couldn't possibly be more thankful for the fact that we had a show with a live studio audience here in beautiful downtown Columbus, Ohio, with an international audience joining us live. So fantastic. Now, this kitty is now continued in the format of a crowdfunding site with the Linux Foundation, and I will be sending this out in the email blast, and this has been posted to Slack, and thank you to everybody who has contributed with that. At also the year 2 juncture, with much help from Mad Dog, we decided to do a raffle. And I am so pleased that we've been able to bring it back, and bring it back with the capability of bridging the in-person and online audience to participate. So that's just been astounding. From last check, I think that we have raised $2,000 just by our raffle. So honest to goodness, I thank you for doing that. Can I have a time check? It's 6:54, so at 7 o'clock sharp, it is going to notify me of the actual winners, and be able to email the winners to let them know that they've won the prize, whether or not they are physically present or not. One of the things that I had felt about the time of the shutdown, and as we continue to integrate and figure out, well, what next, and innovate with that, you gotta be comfortable. That's why, as an international thing, I am standing in front of everyone in my pajamas. And just because we did things one way in the before time, perhaps some of the innovations that come out of the way that we do business now is going to be essential to who we become in the future, as long as that we continue to keep the values that we have held so strong, and being able to bring everyone back in person to our home place has been absolutely beyond my wildest dreams. So honest to goodness, I can't say thank you enough, but thank you. We've continued to push on despite all of our trials, but I'm going to say that this was a wild success, and perhaps there are some ideas that you have about how we were able to execute this year that were something worth continuing to repeat, like having our professional training be brought back once again in person, but also offer it on Saturday as well. Thank you to anyone in the house who had participated in our professional training either Friday or Saturday. That is one of the ways that we were able to proceed with having such a high quality show for everyone and making it continually accessible to all. We also would like your feedback about what we could do to improve, because that's what it's about. That I had answered during Kara Pritchard's talk about open source jobs. What makes your open source job work? Why do you do it? I answered, I came for the software, but I stayed for the community. That is exactly how I feel today. I'm going to turn it over to Vance for a bit while I reconcile the winner, and then I will be ready to make that announcement. Fine work, Vance. Give it up for Vance, our first-time conference chair.
Thank you very much, Beth Lynn. And thanks everybody for your support. And a lot of people helped make this event take place. Beth Lynn already pointed out one of our sponsors, the Linux Foundation. We also have some other sponsors I'd like to recognize. First off, this one's a little bit, maybe a little more under the radar because they weren't here and didn't have a booth. But Red Hat did support us by providing some instructors who taught our OLFI professional classes without charging a fee. So we got to collect the fees that were paid for those classes and apply them to the cost of the conference. And yes, thank you very much. And we I wanted to recognize those folks. We've got a little token of appreciation for them if they're here. So we have Jay Ryan, Brad Crummy, Mark Rabney, and then we also have Don Corbett. If they're around here, otherwise we may have to catch up with them and provide them with these plaques of appreciation. I'm not seeing anybody standing up, so we'll have to move on then. All right, so we did have a lot of sponsors here who did appear. The Linux Professional Institute, Lacework, Secura, and SUSE all had booths, as well as Cover My Meds. We also had CentOS and Alma Linux. It's always great to have our community participants as well. Also Free Software Foundation, LAPSA Columbus, and the J.P. Johnson Law Firm. We had a couple more sponsors who weren't able to be here, but they did provide us some support, MySQL and HomeLight. And also, Linode provided us with sponsorship for the coffee that we had yesterday and today morning. So they're the people who got you activated. All right, so let's see if Beth Lynn has some raffle results for us.
Indeed we do. The Kubernetes Fundamentals package, I gladly announce, is won by Greg Harness. Greg Harness, are you here? Okay, well, he will definitely be thrilled that he has won that prize, because it is an exceptional prize. And thank you, Linux Foundation, for donating it. Fantastic. And next, we had the Freedom Box Lime 2 server donated by John Mad Dog Hall. And it is won by a Miss Kate Stewart. Next is the Raspberry Pi donated by Susie. I'm just so privileged to have them come back and participate almost every year for the past 18 years. So my goodness. And the winner of the Raspberry Pi, courtesy of Susie, is Nathan Dykmeyer? Is he present? Nathan Dykmeyer. Well, he will definitely get in the email about it, and they're going to go ahead and drop ship it him. Thank you, Susie. That was a very popular prize. Next, we have a Mad Dog's World of Foss Quilt. This has been a collection of around 20 years of Mad Dog's globetrotting in the name of free software, piecing together all of these t-shirts that he's picked up via all of the events that he's gone to patch this together, and LPI was honored to go ahead and pay for the commissioning of stitching that quilt together here on American soil. So thank you so much, LPI, for making that true and making it so that Mad Dog has about 40 some less t-shirts. How many more to go do you have to get rid of, Mad Dog? Only about 14,900 shirts to go. All right, all right. Well, it sounds like that you have a plan. Just a lot more to go. So, honest to goodness, the winner will be delighted. It's Mr. Paul Ferris. Outstanding. Another fine prize that was donated by Mad Dog was the games pack. So what this was a limited edition. Over 10 years ago, Monopoly made a special spin with Alan Turing's rules, as well as a deck of cards celebrating the heroes of the tradition of Unix, and it just such a spectacular vintage prize with the playing deck, because it was published in the 90s. So, unfortunately, Linus Torvalds is not there. Maybe the Linux Foundation or somebody, hint, hint, would publish a card playing deck of the heroes of Linux or the heroes of free software. But we have such an outstanding games pack awarded to Robert Provins. Robert, are you here? Yeah. Well, we know that he's still in the building, so we'll make sure that he leaves here with that. All right. Next was another fine prize donated from the Linux Professional Institute. It was called the Getting Started Pack to really boot or maybe even reboot your career with the Linux Foundation certification and a Kubernetes certification. And that proud winner is Sam Javer. Yeah! Sam has been one of the proud volunteers who have been working tirelessly to make the show a go. Wow, you've seen Mr. Paul Ferris, or at least heard Mr. Paul Ferris from the microphone communicating the questions online. But you've seen Paul Ferris here on stage. But the man behind the camera that's making sure that the video looks great, that the audio sounds great, and that the slides are in sync with the beautiful frame, that has been much to the effort of a lot of our volunteers. But I understand that Sam has been real trooper contributing most of that time. So Sam, we're definitely very pleased that you have won this prize. So thank you so much. Now, the last prize was a prize that I had donated from the National Aviary, which is from my hometown of Pittsburgh, Pennsylvania. And they do a lot of research about breeding African penguins. Now, these penguins are from South Africa genetically, but they do live all around the world, and they were successful in hatching a penguin and bringing him into the habitat as part of the population in 2021. Now, what they do as a fundraiser there at the National Aviary is that they allow you to have penguin encounters. And they also allow the animals who are particularly gifted in the artistry to get their feet wet with a little bit of paint and go on a little stroll. So the penguin walk portrait is an 8x10 walk of some real African penguins who live in the National Aviary. And I'm so pleased to thank Scott Redmond for his donation because he has won the Penguin Walk prize. So thank you, Scott. Is Scott here? That's you? Fantastic. Congratulations. We'll make sure that you get it tonight. So, quite honestly, from the bottom of my heart, I couldn't have done it without all of you here in the physical audience, all of you in the home audience, all of you who will now see this particular stream in archive, and all of Team OLF who made this possible. So to properly recognize everyone who has really tripped in and did this, I'm only the president of the corporation, the man who really made this event possible today with heroic efforts and keeping me in line is Vance Kofender for our conference chair.
Thank you so much, Beth Lynn. And don't go away, because I did want to point out she has done a lot more than what she is taking credit for. She did huge amounts of work in bringing in our sponsors and taking care of a lot of the details. I also wanted to give special recognition to, we had Jared Saichi, who is not only our speaker chair for this year, he also managed set up the whole streaming setup and got that running. Yeah, absolutely. And he also took care of getting all the T-shirts made and ordered. So that was a heroic effort as well. So thank you so much, Jared. I also want to recognize Mike Schulteis, who ran our registration, spent pretty much the whole day sitting behind the registration desk and taking care of random things. He's also the one who physically got the T-shirts from the printer here when they weren't delivered on time, and he had to pry them out of their hands and drive them from Indianapolis out here.
Supply chain. Yeah, no, we're not going to have a problem with that.
I also want to thank, yes, absolutely. I also want to thank Rafiq Raymond. He's actually not here at the moment, but he was instrumental in lining up a lot of the logistics for the professional training, getting all that set up as well. So thank you very much, Rafiq. And who else am I forgetting, Beth Lynn?
Warner is on our board. He's our vice president.
Yes, we have Warner Moore here. He's our vice president. He's kind of stepped back from taking an active role, but he has provided his support throughout the year. But I did want to call out Susan Rose. She's the person who manages our social media, and she puts out many tweets and helps generate a lot of publicity for us. So that's something that we really need. We also had many volunteers who helped us, some over a long time, some just for a few hours, but all of their help was really instrumental in us pulling this off. Well, I don't want to keep you any longer. We have a dessert reception coming up in the Fairfield room. we have a cake celebrating 30 years of Linux, and we'll be pleased to cut that with you and share it with you, and have a wonderful evening. So take care, and we'll see you in 2022.